Okay, so we should be now on YouTube.
Yeah, yes, we are.
Great.
Excellent. So it looks like we are live everywhere. I guess we can let in the other members on the Zoom meeting also.
Yes.
Good morning, Hermann. Hope you're doing well. I know it's very early in the morning for you. Sorry, I think he's muted.
Yeah, I suppose you're right. I'm muted. So good morning, everybody.
Good morning.
Good morning.
Good morning.
Hi, Christa.
Hi, Christa.
Good morning.
Okay, I see Professor Vinay Chandran is also on. So most of the speakers are coming on, and I see quite a few members also getting in. Hello, Professor Vinay Chandran. How are you doing?
I'm fine. Good morning to everyone. Good morning, Hermann. Good morning, Jessica.
Morning.
Very nice to meet you.
Yeah, very nice to meet you too, Lisa. Yeah, Lisa.
I'm looking forward to our discussion this afternoon very much.
Sure.
Thank you for agreeing
Sure.
to do it.
Yes. Yeah.
So the people who are already on, we are just setting things up, getting things going. We are officially starting in 9 minutes, as per my clock at least. So we'll just go through all the logistics to make sure things are okay. Online meetings are always a little more interesting in terms of logistics.
So, Hermann, how are things in Kiel? Do you have a big trouble with the pandemic?
Well, yeah, well, we have some problems and trouble with the pandemic, but in northern Germany, it's not that bad, I have to say. I mean, we're not facing so many infections and we're doing quite well here. It's much worse in the south, in southern Germany. So we're in the lucky part of Germany, I would say.
Yeah, we seem to be approaching the peak. I mean, last 3 weeks, we have been having many number of cases.
Oh yeah, okay.
Yeah.
But you
So
see the peak.
Yeah, our semester is starting tomorrow, and all classes are going to be online.
Oh, okay.
Yeah. So ISE has 0 classes in person, even the labs?
All classes will be online. Even our last semester was mostly online, half of it. Yeah.
Okay. And the hostels are still closed, are they?
No, we called the 4th and 3rd year PhD students a couple of weeks back, but then they have to eat in a mess where it's hard to maintain the social distancing. So there have been a little increase of cases in the last couple of weeks.
Oh my!
So the students who can do their work online are advised to stay back at home. Of course, they have the freedom to come back if they wish to. Yeah. So, but students like chemistry and biology, where they have to do stuff in the lab, they have to return. So they have given preferences. Yeah.
It's very interesting times, especially if you're a field scientist. There's absolutely no field work going on anywhere right now. So that's going to suffer a lot. We're going to have to rethink some of the PhD projects because quite a few of the projects depended on lab work and on field work, etc. So very interesting times.
That's absolutely true. We're facing the same situation. So all the cruises, for example, into the Indian Ocean have been cancelled now. So, well, that's very bad.
We were supposed to have a field program in the Andaman Sea. So that was supposed to be in March, April time. So it's been just postponed indefinitely, yes.
Oh, wow. Okay.
Good morning, Vinay. Good morning, everybody. Peter Burkill here, just to say I'm alive, well, happy to join you. I will mute myself and just stay quiet, but listen.
Good morning, Peter.
Hello, Peter. This is Vinay. Nice to see you after quite some time.
Yeah, good to see you all as well. I look forward to making some new friends today. At least I hope so. Good to see old friends as well.
Yeah.
Oh, I like Yoko's picture.
Hello.
Hi, Yoko.
Hello. Thank you.
Okay, so we've got 4 more minutes and then we start off. Is that right, Jesse?
Yes, sounds good.
Excellent. Okay. I see that the YouTube stream is also working very well, so hopefully we should not have any trouble. Good morning, Roxy.
Good morning, Anuba and all. How is it going? Everything set?
As far as we can tell, yes. It's always interesting doing this online, but as far as we can tell, we are at least ready from our side.
Yeah. It's a bit early for people like us, right?
Oh, no, we are the lucky ones. It's very early for people in Europe and very late for people in the US, etc.
Yeah, I guess so. I see Peter there. Peter, hi. How are you?
Yeah, morning, Roxy. You said it's early for you. It's 4 o'clock here in the morning. I've just got up.
I take back my remarks.
No, it's good to see the sun is shining on you outside. I can see that. It's still, it will be dark here for another few hours yet, but the spirit is willing. That's the important thing, I think. Good to see you anyway.
Yeah, you too.
Could I just ask how many people are we expecting at some stage? Jesse said 350. Is this going to be okay for bandwidth?
So there are 360 people who registered, and we might have 100 on Zoom and then the rest on YouTube.
Okay, yeah. And that's okay for bandwidth, is it?
Mm-hmm. Yes.
Okay. Very good.
We hope so.
I've got both fingers crossed, so I better shut the door, otherwise I'll upset my wife's dogs.
Good morning, Nidhi.
Good morning, sir. Good morning, everyone.
Welcome, welcome. Huh? We're looking forward to your talk today.
Yes.
Okay, Jesse, my clock tells me it's time to go. Is that right?
Yes, let's start.
Okay. All right, so we're going to start off. I see that there's plenty of people on Zoom and a few on YouTube already. First of all, thank you all for coming. It's very nice of you to take part in this meeting that we've been thinking of having for a very long time. Those of you who do not know me, my name is Anup Mahajan, and I work at the Indian Institute of Tropical Meteorology, basically as an atmospheric chemist, but working on the exchange of trace gases from the ocean to the atmosphere, which is why I'm working on SOLAS. A couple of things. First of all, this meeting is very exciting. There seems to be a pretty large gap in terms of the understanding of what's happening in the Indian Ocean, with just a few cruises, etc., that have happened in the past. So there's a lot of exciting research that we can do. I'm sure all the speakers that we have lined up through the day will tell you a little bit more about what gaps there are and what we can do as a community to address them. So I won't go into that in detail. However, I would like to start by apologizing to all of you. Initially, we wanted to have this in person during a meeting which was planned in March this year. Unfortunately, that had to be cancelled because of reasons that everybody knows, and hence we had to move this online. The good thing about moving it online is, of course, it's accessible to a lot more people, which is nice for the community. So instead of an initially planned number of about 40 to 50, we've had an incredible 360 people register for the meeting. So this is great in terms of the reach that we have and in terms of the interest there is in the community. However, it is also a big problem in terms of logistics. As all of you over the last few months have realized, organizing meetings online is not easy, especially because of bandwidth issues, how chaotic they can get and all. So what we have done is, unfortunately, we could not get everybody on the same platform on Zoom, just because it would just be way too chaotic. So what we have done is we've got the speakers, panelists, etc. on Zoom. And then we are also streaming it on YouTube. So quite a few of you will be watching this on YouTube. And we apologize for that. Wish we could have everybody on the same platform. However, if you have any questions during the meeting, these questions can be asked on the YouTube chat also. So basically, the way we are going to conduct this meeting is we'll have the speakers who will have their microphones on and their videos on. Everybody else, I'm going to request you to put your microphones off if you are on Zoom, of course, microphones off and the videos off so that only the speaker can be seen very clearly. If you have any questions, then can you please type in your questions on the chat window on Zoom if you're on Zoom, and if you're on YouTube, then on the YouTube chat window. Both of them are being monitored, and both the chats will be given to the chair, the session chair, so that they can ask the questions to the speakers itself. There will be about a 20-second lag on the YouTube, so we are aware of that, and we are keeping track of the questions accordingly on that itself. With that, hopefully, I'm hoping that the meeting goes smoothly. Hopefully, we won't face any troubles. We know people can have bandwidth issues, so if you lose connection, please just feel free to log in again. If we lose connection, we have some backups in place to make sure that the meeting proceeds smoothly. With that, I'm going to stop my logistics introduction, and I'm going to introduce the first speaker for the day. Lisa Miller is basically working at the Institute of Ocean Sciences in Canada. She, as you must know, is an accomplished climate geochemist and has worked extensively on ocean biogeochemistry and its impact on the atmosphere. She has done significant work on the carbon cycle, especially in the SOLAS domain. So she's definitely the right person to be talking about SOLAS activities. In fact, she is currently the chair of the SOLAS Scientific Steering Committee. So she's overseeing most of the work that the SOLAS organization itself is doing. And hence, she is definitely the right person to give you an introduction to this meeting. With that, Lisa, the floor, or should I say the screen, is yours.
Okay, thank you very much. So let's see if I can manage to share my screen and give you my introduction. Let's see here. Okay, I've practiced this a couple times. And share. Oh, screen sharing has failed to start. Try again later. Great. Let's try this one more time. Okay, let's try it this way. Are you seeing my slides?
I think
yes.
The background.
Do you?
There's a mountain.
Oh, you. You see a mountain, so you don't see my slides. Okay. Okay, no, damn. One more time. Share screen, PowerPoint, share.
Yes.
Run the slideshow. Do we have slides? Or
Yeah,
do you see my notes?
Your
You
notes.
see my notes, damn it. Okay, one more time. How's that?
That's perfect.
Perfect, woohoo! Okay, my apologies for that, everyone. So, first of all, so I want to thank you all. I want to second Anoop's welcome. This is really exciting. We had, as he said, we intended to have this meeting in March, and even though the IIOSC 2020 was postponed, we felt that the timing was really good to have a meeting and a discussion about SOLAS science in the Indian Ocean. And based on the interest we've received to this online meeting, it's really clear that that is true. So just to give you okay, there we go. Can we, next slide? Oh, great, now, there we go. Okay, my slides are advancing. So I just want to give you a very quick introduction. I suspect most of you already have some idea of what SOLAS is, but I just want to give you a brief rundown of our science and what we do. Now, the primary mission of SOLAS is to understand air-sea exchange processes, and most importantly, to quantify those processes and the feedbacks between the coupled air-sea, the ocean atmosphere system, and climate and global change. And the way we approach this is through a science plan that's organized around 5 core themes. Starting with greenhouse gases in the oceans, going to the actual physical chemistry of the air-sea interface. It includes the impacts of atmospheric deposition on the ocean, both pollutants and nutrients, and also how the ocean impacts atmospheric chemistry. Core theme 4 is focused mainly on aerosols and clouds and feedbacks, then back through light to the ocean ecosystem, and also through gas phase atmospheric chemistry, oxidizing capacity and cleansing capacity. Now, of course, as this figure shows, none of these things are actually independent. They're all intimately related, and we have a number of cross-cutting themes that directly integrate all of these. And the Indian Ocean is one of our core integrative initiatives. And the intent of our meeting today is to, in many ways, really launch that integrative initiative in the Indian Ocean and start bringing all of these ideas and all of you who are generating these ideas together to start talking about what we can do together and how to work together and how we can help each other with our science. And just to give you a quick rundown to our plan today of the science we're wanting to cover, we've put together a program that is rooted in the SOLAS science plan, but we've tried to adapt it to the Indian Ocean and the special characteristics of it. And we're going to start out this morning with a session on the air-sea interface and boundary layer exchange of trace gases. So the core themes 1 and 2 for SOLAS. But then we're going to talk about the importance of monsoons in air sea exchange, something that's really quite unique to the Indian Ocean. Then this afternoon, we're going to talk about how the atmosphere impacts the Indian Ocean. So atmospheric deposition, including pollution, and then wrap up with how the ocean impacts the atmosphere, specifically ocean biogeochemistry and the chemistry and biology of the ocean. And I want to also bring to your attention that during the break between the morning and afternoon sessions, there's going to be a meeting of the Indian SOLAS community. And we invite anyone who is working in India on SOLAS science to please join us. We're going to be trying, Anup is trying to reinvigorate the Indian SOLAS community. Anup or Jesse, can you please put the Zoom link for that that meeting into the chat so we can catch anyone else who we hadn't thought of before?
Yeah, since the meeting is to invitation only, I think Anup sent an email to the people who should be on that meeting already. So they have the link.
But he also wanted anyone else to know about it, who we might have missed. Anyway, we invite folks to join us. If you need that link, contact Anup for it. And so with that, I will stop talking so that we can actually start talking about some real science. And I want to introduce you to the chair of this morning's session, Hermann Bange. Hermann, you want to turn your camera on?
Yes, I've done already.
Oh, you have? Okay, I couldn't see you. Good, okay. So I introduce you all to Hermann Bange, who's a professor of chemical oceanography at GEOMAR in Kiel. He's also a member of International Indian Ocean Experiment, the second experiment steering committee. And he will be guiding you through this morning's session. Oh yes, he's also a member of the SOLAS India, and he was co-chair of SCORE Working Group 143 on dissolved nitrous oxide and methane measurements. And he's a chemical oceanographer who studies the biogeochemical cycles of nitrogen, sulfur, and carbon trace gases. So he's really one of the SOLAS stalwarts. And
Thank you.
And so with that, I will hand you over to Hermann so that he can introduce you to our first keynote speaker, which is very, very exciting. So over to you, Hermann.
Yeah, thank you. Thank you, Lisa. Thank you for this very nice introduction. So good morning, everybody, or good day, everybody. We start the scientific session with the first keynote talk, which will be given by Christa Marandino. She's a colleague of mine and working at the GEOMAR Helmholtz Center for Ocean Research in Kiel, Germany. She's heading a working group working on SC gas exchange, and she has a lot of expertise in short-lived trace gases like DMS, dimethyl sulfide, and isoprene. And she's a worldwide leading expert for eddy covariance measurements on board research vessels. She's also involved in several SOLAS activities, like the upcoming SOLAS International Summer School, which takes place on Cape Verde Islands. And she's also the German co-representative of SOLAS. So I stop here for introducing Christa. So Christa, the screen is yours. We're looking forward to your talk, which is entitled, let me see, Atmospheric Gas Phase Composition over the Indian Ocean.
So I cannot start my video. Someone has stopped my video. I have no permission to start it. Can someone help me out here? Okay. Here we go. Thank you, host.
Okay.
Here we are. So hi, everyone. So let me try to share my screen. I hope I don't have the same problems. Here. Let's see if it works. Nothing is happening. Let me try again. So I'm waking up, my computer's waking up. Let's see how it goes here. So nothing is happening, guys, so please bear with me. It's a little circle turning and turning. Am I back? Let's try this again.
Okay.
So can you see my screen? I'm going to try to just share my whole screen. Can you see my presentation?
Yes.
Okay, great. Now, as soon as the little circle stops turning, I will put it into presentation mode.
Oh yeah, still waking up.
Yeah, I don't know if it's the internet connection or what. I can't even advance the slides, so even in this particular presentation mode. Oh, guys, I'm sorry. As Anoop said, this is the downfall.
Yeah, that's true.
So while I'm waiting for the little circle to stop turning, I just want to say thank you to the organizers and conveners for inviting me here today to talk about atmospheric gas phase composition over the Indian Ocean. And of course, the air-sea exchange bits. Oh man. Any advice? I can try to change how the computer is connected to the internet. Does anyone think that this will help me?
Christa, I don't think it's an internet issue. I think it's PowerPoint. If you can try and close it and start it again, because your video is working very well. If not, one of us could present it if it's still going to be a problem.
Okay, so let's try that. Maybe I stop the share and, oh no, okay, let's try it again here. So now everyone can see it.
Yes, perfect.
Great. I'm going to minimize this. All right, everyone, good morning, good afternoon, and good evening. So as I said, I'm going to talk to you about atmospheric gas phase composition over the Indian Ocean. And this work was is actually based on a review that we just submitted to the Copernicus Joint Special Issue on understanding the Indian Ocean system, past, present, and future. So we submitted our review to ACP. It's not yet on the discussion, so everyone has to be patient. The lead author is Suzanne Tegmeyer, who will be a convener of a session later on in the afternoon. And you can see the other authors listed here. Many are participating in this meeting today. So first, why do we care about the atmosphere over the Indian Ocean? So we know that the Indian Ocean region is unique, and the Indian Ocean itself is coupled to atmospheric dynamics, transport, and chemical composition above the Indian Ocean via some unique features, such as the seasonal monsoon. And I'd like to note here that when I talk about seasons for the rest of the talk, I'm referring to boreal. So boreal summer, boreal winter. And because of things like the seasonal monsoon, we have some distinct atmospheric chemical regimes that are set up there above the Indian Ocean. So in the winter monsoon, we have a high pollution. And in the summer monsoon, we have more marine pristine air above the Indian Ocean. And as we also know, the Indian Ocean is surrounded uniquely by landmass. And a lot of the countries surrounding the Indian Ocean have very rapidly growing populations, rapidly growing industry, which means rapidly increasing anthropogenic emissions. And just to give an idea kind of what we're talking about in terms of population density, we see this picture here on the right-hand side that we're talking really very dense populations. So lots and lots of people, lots and lots of emissions. And these emissions come from things like biofuel and coal burning, as well as other fossil fuels. And this pollution has been shown to impact human health, ecosystem health, such as agricultural health, and things like weather and climate. So before I talk about the review specifically, I would like to give a little bit of space to the previous work that has gone on. So from the satellite image that you see on the left-hand side, we can see that the pollution layer above the Indian Ocean is visible from satellite. And this has been called the Asian brown cloud. And in order to study this Asian brown cloud, in the 90s, a study called the Indian Ocean Experiment was proposed to look at emissions and atmospheric composition over the Indian Ocean. So this is called INDOX for short, and it took place during the winter monsoon of 1999. And during this time period, there are strong northeasterly winds, which bring pollution from the continents to the Indian Ocean. And what was found is that this pollution plume contains continental aerosols, both from dust and land-based aerosols, and also from anthropogenically emitted aerosols, man-made trace species, as well as the reaction products in the plume. And what they found is that this pollution plume is different than what is found over Europe or North America because of the widespread biofuel burning. And so this creates enhanced CO, so carbon monoxide, and also many sunlight absorbing aerosols. And what was found is that this impact can be found on regional climate. So it can mask greenhouse gas warming because the aerosols are reflecting the radiation back out to space, and it can modify monsoon rainfall. So again, before I start showing you the results from what we found, I want to tell you a little bit which gases we're considering. So we have 3 classes of compounds. The first is ozone and pollutants, which are CO, nitrogen oxides, NOx, sulfur dioxide, and mercury. And these are interesting from the SOLAS perspective here of the deposition onto the sea surface, although carbon monoxide does have a source from the ocean. Greenhouse gases were considered, things like methane, nitrous oxide, carbon dioxide, and carbonyl sulfide. And these are pictured here in SOLAS theme 1, as we already heard from Lisa. And of course, short-lived biogenic trace gases, which are near and dear to my heart. And I'm sorry if I'm a little bit biased in the rest of this talk, talking about them. But these are gases like dimethyl sulfide, DMS, isoprene, and halocarbon compounds. And these gases are important for things, as well as the ozone and pollutants, for things like affecting the aerosol formation and oxidative capacity of the atmosphere. So when we sat down to write this review, we thought a little bit about what physical and biogeochemical processes affect the composition above the Indian Ocean, and how air-sea exchange is incorporated into this whole picture. And so we came up with a set of physical processes, for example, that we needed to consider. So in the atmosphere, they're listed here. So things like the seasonally reversing winds are obviously very important for these pollution regimes. And you can see that pictured here. So this is a figure of sea level pressure and surface wind. So the pressure is colored and the surface wind are in arrows. And you can see the direction of the arrows as well as the magnitude. So the magnitude 10 meters per second is pictured here. And in the summer monsoon season, the wind is coming from the ocean toward the land, and the reverse happens for the winter, so from the land to the sea. So this is a very important feature, as well as some other unique features such as seasonal equatorial westerlies. This is unique to the Indian Ocean, double ITCZ, and this anticyclone that brings air from the boundary layer into the stratosphere, as well as an elevated layer that brings pollution up aloft. Of course, we have to pay attention to things like the Madden-Julian oscillation, the Indian Ocean dipole, El Nino Southern Oscillation. So very interesting and unique features playing in the Indian Ocean atmosphere. So now my slides no longer advance. Here we go. Okay, so in the ocean, what do we have to care about? Very similar. So seasonally reversing currents, as you can see from these pictures here. So in the summer, we have flow in this direction. In the winter, we have flow that changes direction, and it also changes spatial features. We also have to care about freshwater input because the Indian Ocean is surrounded on so many sides by land. So this affects salinity as well as constituents in the ocean, such as nitrogen or dissolved organic material. And we have to care about things like sea surface temperature and productivity due to upwelling and other features. There are also some very interesting long-term trends in the Indian Ocean, as we know, and the most important is warming. So you can see from this figure that here's the Western Indian Ocean and here's the so-called warm pool, and both are warming through time. So you can see here from 1990 to 2012 that especially the Western Indian Ocean in red is warming something like 1 to 1.5 degrees. So long-term warming will also affect atmospheric composition, as well as changes in monsoon circulation and precipitation, salinity, and productivity changes. So just to show you that we tried very hard to scour the literature and have a look at what has happened past Indo-X. So we used all of these individual campaigns, as well as station data, satellite measurements, and the EDGAR database, emissions database for global atmospheric research in our review. And I apologize if we missed some campaigns, but we tried really hard to find everything that has happened since Indo-X. So now I want to show you a little bit of the major results. And I just want to bring your attention to the fact that there are no references for these results on these slides. So the next 5 slides don't have appropriate referencing. So please check out our review when it comes online to find out all the references. But I just want to try to summarize what were the most interesting findings from the different classes of gases. So first is pollutants. And we found through EDGAR that East and South Asia are the main emitters of pollutants to the region around the Indian Ocean, and that there have been increases between 15 and 120% from 2000 to 2015 in the different species that have been emitted, as well as the different regions, so a range. And we see also that ship emissions have been increasing in the Indian Ocean. And if we look at the carbon monoxide source from the ocean, as I mentioned earlier, it is basically on the same level as the ship emission carbon monoxide source. And if we look at this figure here presented on the left-hand side, this is just an example of NOx, so the pollutant NOx. And so this is from TROPE-OMI, a satellite image, and you can see basic trends that are true for most of the gases we will talk about. And so we see strong gradients from land to sea with highest values over the northern Indian Ocean in the wintertime. But what we also noticed is that not all chemical species are measured or observed the same. So sulfur measurements are extremely lacking in the Indian Ocean. So NOx and CO and ozone are better constrained. But we also noted that these unusual wind patterns that we already talked about a little bit in the atmosphere make deviations to this general gradient that is observed. And ozone is one example where these deviations can be seen very readily. So what I show you down here on the right-hand side is from a campaign, and you see values of ozone in the atmosphere in the spring and in the winter. So the color bar tells you the mixing ratio. And in the spring, we see something that we would typically expect. So higher values in the north, lower values in the south. But in the winter, again, we see things that we would expect higher values than in the spring, but we do see some gradients here that are slightly unexpected. And we think that this, or the hypothesis is that this is due to transport over the Indian Ocean, creating more sinks for this region here with time. And therefore you see these lower values more in the southern west area of the Bay of Bengal. Of course, this is still hypothesized. The complex patterns of ozone over the Indian Ocean are not completely clear at this time. So the next is greenhouse gases. And again, like the pollutants, we see that East and South Asia are the main emitters, with increases ranging between 15 and 137% since 2000. And the greenhouse gases have some unique properties compared to the pollutants, notably that the ocean is a source and a sink for these greenhouse gases, and that they have longer lifetimes than the pollutants. So the spatial distribution will be different. So what we can see here from this satellite image of methane, so this is from AIRS, is that we have the same basic trends, so higher values in the north and the south, and high values in the winter, much like the pollutants. But for example, with methane, we see another interesting feature, which is that the summer monsoon in the Arabian Sea has the highest values of methane. So this is hypothesized to be due to the upwelling and the emissions of methane from the upwelling. But again, this is not completely clear. So, and there are positive trends over the Indian Ocean in greenhouse gases. So what is happening with methane, as well as what the positive trends are going to be into the future, these are some unknowns or some debated topics. So now we turn to the short-lived gases, which are near and dear to my heart. So now there are 3 slides instead of just 1, so my bias. And so what I show you here is the climatology of DMS emissions from the Indian Ocean. And we know that the Indian Ocean is a hotspot for DMS emissions to the atmosphere. And here we can see that actually the summer is when we have the greatest emissions, which makes sense since this is biogenic trace gases. But what we found from our own studies and from the studies of others is that LANA climatology overestimates these emissions. So the actual value going into the atmosphere is not completely clear in this climatological perspective. We also found that ship emissions of sulfur are high in this region, and that the sulfur emissions are higher than the sulfur emissions from DMS. Nonetheless, DMS is an important sink for OH here, it has been found, so the hydroxyl radical. And we found in our own study that the DMS emissions can be an important local source of marine aerosols in this region. Now turning to isoprene, here I show you a climatology of emissions from Bange et al. 2016. And so these are isoprene emissions. And again, we know that the highest emissions of isoprene are in the summer, much like DMS, but we see a secondary high in the winter monsoon period in the Arabian Sea. This looks like the methane. And so perhaps it is also due to the upwelling, but this is not yet clear. Isoprene has a global emissions hotspot also in the Indian Ocean. But what we found from our own study in the Indian Ocean is that the atmospheric values are much higher than would be expected from the computed fluxes during our campaign. So we think there is a missing source of isoprene to the atmosphere over the Indian Ocean, also globally, but we found it really in the Indian Ocean. So finally, halocarbons. What I show you here is bromoform, and it's a climatology of bromoform fluxes from Fien et al. 2018. And again, like the other trace gases, we see that the summertime has the most elevated emissions of bromoform, but we also see that the coastlines have very, very elevated emissions in other times of the year. And this is due to activity, biological activity in the upwelling and due to macroalgae production, but also anthropogenic sources. So bromoform also has anthropogenic sources. And again, like the other trace gases, the Indian Ocean is a global hotspot for emissions of bromoform to the atmosphere. So this is a very important ocean basin for emissions of biogenic trace gases from the ocean. What we see nonetheless is that the oxidation products such as BRO from these emissions are low relative to other ocean basins. So this means relatively lower tropospheric ozone depletion here. So this is something to be investigated in the future. So some things we noticed are long-term composition trends in the ocean, that the CO emissions, for example, are increasing, but in the southern Indian Ocean, they've been decreasing, hypothesized to be due to La Nina rains and reduction of biomass burning in southern Africa. NOx has increased even in areas of the remote marine atmosphere. Ozone is showing a positive trend in the northern Indian Ocean and the northern Bay of Bengal, but a negative trend in the southern Bay of Bengal. So this is an interesting difference. So this is not completely clear at this time. And as I mentioned earlier, methane is showing a consistent positive trend over the Indian Ocean that is comparable to what's happening over land, but the trend is larger at higher altitudes. So again, methane is showing some interesting features, and it has been hypothesized to be due to increased convective activity uplifting the methane, but still an open question. As we mentioned earlier, there is this stratospheric injection point due to the anticyclone during the summer monsoon period. And so we wanted to know if marine trace gases can be transported into the stratosphere. And so we find through modeling studies that, through local convection and summer monsoon convection and the anticyclone, they can in fact be transported up to the lower troposphere, lower stratosphere, upper troposphere. And the main source regions are the Arabian Sea and Bay of Bengal in summer and the Western Pacific Ocean in winter. And projected dibromomethane entrainment is high from the Indian Ocean because there are high surface emissions. But things like bromoform and methyl iodide look smaller from the Indian Ocean compared to the West Pacific as far as entrainment into the stratosphere. So an interesting potential feedback is for example, with nitrous oxide, and I'll talk about that on the next slide shortly. But if there is increased emission due to over-fertilization of the Indian Ocean, then this increased amount of nitrous oxide can be entrained into the stratosphere, where it is a major contributor to ozone depletion in the stratosphere. So things that happen in the Indian Ocean can result in radiation changes at the ocean surface in other regions of the ocean. So this brings me to the interactions with the ocean. So the atmosphere impacting the ocean is very understudied in the Indian Ocean region, but it could have some very significant impacts. So one is, for example, this nitrogen deposition that I show you here in this plot on the left-hand side. This can potentially increase primary production and remineralization in the Arabian Sea and Bay of Bengal, which would contribute to enhanced deoxygenation, enhanced N2O production, and enhanced N2O air-sea flux, as I mentioned on the previous slide. So this is a very important potential feedback. However, this deposition on the ocean must have trends in the CO2 uptake, but this is not very clear yet. And how ocean acidification is impacted is also not clear at this time. But we do know that ocean acidification can impact other gases like dimethyl sulfide. And finally, deposition of things like ozone, specifically ozone as a pollutant, on the sea surface can be an important reactor for biogeochemistry in the sea surface. And specifically, ozone reaction with marine iodide increases inorganic iodine emissions. And these are significant sinks for ozone in the boundary layer of the ocean areas, in the remote, not the remote, but in the marine boundary layer. And so in polluted regions, when NOx is present, NOx can inactivate these inorganic iodine species, which would then not allow them to deplete the ozone. So these dynamics are very interesting and complex and should be studied in the future. So getting to the future studies, we identified some knowledge gaps within the Indian Ocean air-sea biogeochemistry, and I list them here. So just very briefly, we think we need to understand better connections between dynamics, emissions, and air-sea interactions. We need to understand better seasonal and interannual variability and how short-term observations hide the impacts of this variability. We need to understand better trends in biogeochemical and physical changes in the ocean for air-sea interactions, the impacts of atmospheric pollution on ocean biogeochemistry, and specifically trace gas cycling. This is extremely understudied. So the relative contributions of anthropogenic versus ocean sources of greenhouse gases needs clarification, and how the Indian Ocean source gases, so marine trace gases, how they can make it up into the stratosphere and the effects of that. And then also specific to ozone, we need to understand better the chemical production and loss mechanisms. And for these trace gases like isoprene and DMS, obviously we are having problems quantifying their sources, especially for climatologies. So with that, I have some recommendations for future work, and then I will take your questions. So first, we think we need long-term investigations of pollution in the Indian Ocean marine boundary layer and how they're driven by emissions and transport. We need long-term measurement stations for this. So we need to really understand over time what is happening and what are the feedbacks and forcings. We'd like to have a repository of past and future observations in order to really understand these mechanisms. And we want to focus on how interactions between anthropogenic and marine trace gases and aerosols will impact this region. So there is some evidence from the literature that this interaction creates new particles, which impacts cloud formation, wet deposition, and storm patterns and cyclones in the ocean regions. So this should be studied for the Indian Ocean. And we'd like to know how the joint effects of dynamic and supply of pollution and aerosols impact the Indian Ocean biogeochemistry itself. So with that, I thank you. I'm a little bit over, I'm sorry. Thank you, and acknowledgements for the review, and I'm happy to take questions. Should I stop my screen sharing?
You can do so if you want to. Thank you, Christa, for this very interesting and inspiring talk, I would say. All right, so let me check the chat. By the way, you're not over the time, so we still have some minutes for discussion. All right, so let me check the chat, and then yeah. All right, so here's one question from Anoop. Any reason why you think that halogen oxides would be low in the troposphere in the ocean as compared to the other oceans?
Well, this is a question for you, Anoop. So this, I don't know the answer to that. I mean, and I think as you know, we debated a little bit about these things when we were writing the review. So I think for me, it's completely not clear. I mean, I'm happy to hear from the community what they think. Sorry that I don't have really an answer for that.
No, that's okay. So,
yeah.
okay, another question from Peter Burkle. You talk about the Indian Ocean, yet 99% of the data is from the Northern Indian Ocean. How important is it that we also study the Southern Indian Ocean?
Very important. I think it's very important. I think this is also something that we noticed that I failed to mention it when I talked about the greenhouse gases, but when we look, for example, at the SOCAT database, we see that not only regionally are there lacking data, but also over time in the Indian Ocean. So in the SOCAT database, the number of observations for CO2 in the Indian Ocean have gone down in the last decades. So I think it's extremely important to get more observations and better spatial and temporal coverage. So definitely the Southern Indian Ocean needs to be looked at.
Okay, thank you. So a question from Roxy Koll. Thank you for enlightening us about the trace gas variation on seasonal and annual timescales. What do you think about the variations at finer timescales, including intra-seasonal timescales? Are ship-based observations sufficient? Shouldn't we think about sustained observation of these gases in the Indian Ocean?
Yeah, so I think this is a very true point. So we talked about this during the writing of the review, and I think Anup was a very strong voice on this, that we need more sustained measurements in the Indian Ocean, and therefore it comes up on the slide, the final slide. So these longer term measurements would be very useful, and there are some stations that can provide also spatial information in the Indian Ocean, and they should be maintained, and perhaps more need to be made. So I saw there were some posters about things like CLIBAR and sustained observations in the Indian Ocean, and I think it's necessary. It's true.
Okay. Again, a question from Roxy. Do we have a timeline for your review, and are comments welcome from the scientific community?
Yeah, so the review is already submitted to ACP, but it's going through the initial checks still. So I think they're waiting for one more reviewer before they put it on ACPD. So I don't know what's happening exactly with that, but this is what I see. And I think as soon as it goes on ACPD, everyone is welcome to make comments. So yes, you can find it there. So just keep looking. You can search for Techmeyer and ACPD and make your comments.
Thank you, Christa.
Okay, one more question from Vaishnavi Pandey. How aerosol optical depth influences the Indian Ocean surface?
Yeah, I mean, fine. I think this was a big part of IndoX. And I think the idea here is that it prevents light from coming to the surface, for example. And of course, the aerosols depositing on the surface will have effects on the biology as well as the chemistry. So I think this was a big part of the IndoX study. So I think there's a big body of literature on that. But I definitely think mostly it's light and masking the influence of greenhouse warming in the Indian Ocean area.
Okay, thank you, Christa.
Yep, thank you.
Any other questions? So please type in your questions into the Zoom chat or via the YouTube channel. So they will be displayed for me and I can ask them these questions to Christa. We still have 2 minutes to go. So if there's a question, please go ahead and ask the questions.
I guess I'll just take a moment to just reiterate that the Indian Ocean is very, very, very interesting. And it's obviously a big source to the atmosphere. So awesome here. The isoprene source. Could it be land-based? Yeah, so this is obviously something, sorry, I see the question here from Parv too, Hermann. Do you want to read it or?
I'm going to read it. Can you discuss the isoprene source further? Could it be land-based?
Yeah, so I think in principle, yes, it could be land-based, but we looked at the back trajectories and isoprene is very, very short-lived. So it has something like 1 hour lifetime. So we looked at the back trajectories during our Oasis cruise and we were too far away from land. So in principle, towards the coast, yes, but where we were in the Indian Ocean, no. So we think it has to do with the upper ocean, something with the microlayer or the upper centimeters of the surface ocean.
Okay, great. So thank you again, Christa. That was very inspiring, I guess. And we're looking forward to new, exciting research done on trace gases and aerosols in the Indian Ocean. Okay.
Thank you.
we now move on to the next talk. So we're now opening the session with 4 talks, and the opening talk for this session 1 will be given by Manish Naja. I hope I got this right. He is from, let me check this. Let's have a paper here. He's a senior scientist and chair of the Atmospheric Sciences Division at Aries in Nainital in India. And he worked as a postdoc for several years in Japan. Then he came back to India. His interests are coming along with high quality long-term observation of trace gases, ozone, and aerosols, using surface-based, balloon-borne, and ship-borne instruments. He has been involved in many, many international projects like IndoX, which was already mentioned by Christa, and I guess Lisa mentioned it as well. GOSA, GWAX, SUSCAT, and so on. I don't go through the whole list of projects he was involved. Currently, he is the PI of the ISRO 80CTM, whatever this means, I have no idea, project, and leading a radar facility at Aries. And he's a steering committee member of IGAC and co-chair of the IGAC Mango project or program. So he's going to talk about trace gases over the Arabian Sea, the Bay of Bengal, and the Indian Ocean. So Manish, the screen is yours.
Yes, I will say good morning, or some of you good afternoon. I think I'm audible.
Yes.
Yeah.
Could you go to full screen mode?
Yes, I am doing it.
Okay.
Okay, so maybe first of all, again, I will say thanks to Christa to give a nice overview and giving a nice background in general for the Indian Ocean study. And I would like to maybe make a discussion on some subset of that, including part of the Arabian Sea and Bay of Bengal. And I think the major focus will be on the previous study on the on IndoX, which maybe some of the things has been covered by Christa. Okay, well, so maybe to start with, I will just say this Indian Ocean is a very unique place in terms of it is providing a unique natural laboratory. And that is the probably, I think, only the place in the world where you have in the northern side or the basically east or west, you have surrounded by the lot of different kind of anthropogenic sources. And on the south, you have the very clean oceanic environment. If you compare over the Atlantic or Pacific, so this is the very unique place for that. And considering that, if you compare the first global observation of the surface ozone was basically made by the Max Planck Institute of Germany in collaboration with on the commercial ship, and they made this worldwide surface ozone observation. And that you can see here, this I think I would say the first observation in the 90s when the global observation were available. And this is the basically top panel is showing the surface observations in the say July, August, September, October period, almost 4 months, from basically covering from the Canadian region to going all the way to Pacific and then Indian Ocean, and then again coming to this Pacific region. And the bottom panel is showing the onward journey, and then bottom panel is showing the observation made during the return journey, and that is in the dry season. Basically, you can see in the November or December, January, February, so 4 months. And an interesting thing, if you compare overall, like if you compare over the Atlantic or the Pacific here, the difference between two seasons, like in the monsoon time or the post-monsoon time, the surface ozone level is not much different. Almost they are in the range of 40 to 50 ppb, this vertical bar is showing. Now, if you try to focus over this Indian Ocean or in the Arabian Sea or Bay of Bengal, surrounding the Indian regions or the Indian subcontinent, the increase in surface ozone is very tremendous. Like you see in this monsoon period, in the July, August, or in October, in wet season, you have this surface ozone level is around the 30 ppb. And now in the dry season, or in the, say, in the winter, in the November, December to February, the level goes to around 50 ppb. So this entire observation gave a very nice clue to the scientists that something different process is happening over the Indian Ocean, and you have the basically source when sitting on the north and the clean air on the clean ocean in the southern. Now these are the surface observation. Now during that time it was not known that how much this ozone or some other pollutants can go up to upper atmosphere, like say in the middle troposphere or upper troposphere, and then that may have very significant influence on the radiation budget. So considering this aspect, the proposal basically came for the Indo experiment. Now again, if you try to see, like in this region, how is the basically meteorology is helping the mixing of the polluted air and the clean air from the oceanic region. So during this, you can see in summertime, or as you say, the considering local period, you can say this is summer and monsoon period, which is peak. The ITCZ, it is basically reaches to the northern part of the South Asian region, and you can see in the northern region of the India and covering from the Thailand, Myanmar, and the China region. So this is basically summertime. So this time you have the basic clean air going from the Indian Ocean to this part. And where if you come in the basically winter time, or you can see in the dry season, the ITCG comes down here, and that goes up to the 10 to 15 degrees south. And here, this is the basically plays the boundary. When you have the polluted air coming from the source region or from Indian subcontinent, and it is basically merging, mixing with the clean air coming from the southern part of the Indian Ocean region. So this is the basically, you can say on the way, very critical or important role of ITC in this part, which allowing the basically mixing of the two different kind of the air mass over this region. So this is the basically, you can see the period wise, time period wise, in the dry season like November to March is very ideal place to have the observation in this zone on the when you have the polluted air mass, and in this zone when you have the clean air mass, and surface based or the shipborne or the satellite kind of thing. So considering that, I mean, like just taking you back to the 1990s when the plan of Indo-X was made. So considering this background, the several the platform-based observations were made, like the on shipborne, on surface-based, and the aircraft and satellite-based. And basically, you can see the two ships. One is the Indian ship, and another is the American ship. They made the simultaneous observation over the oceanic region, and the covering basically the Arabian Sea and Indian Ocean, or major focus was in the Indian Ocean. And the major aspect we can see, you can see the twofold was on the surface, how is the role of ITCG in this region for mixing the polluted air mass. And basically it was twofold. One, what about the surface level anthropogenic emission, how they are changing the free tropospheric region in the Indian Ocean. And apart from that, over the free troposphere, how this in the air mass is lifting up and going up in the higher height in the even in the stratosphere, and whether the how much countries northern hemisphere, how much contribution is southern hemisphere. That assessment was basically supposed to meet. So with this, like you see in the background, this is the showing the emissions and the population density over this Indian region. You can see here, and top panel is showing the population density. And if you try to see this high population density in this part and surrounding by this in the Southeast Asian region, where also you can see the moderately high population density. And this is basically reflecting very well with the NOx emission and the carbon monoxide emission in this part of the basically region. So this is basically again confirming that this is the very high source region which is surrounding from the all three sides, and one side is open. So to basically remind you, during this Indo-X, of course, the main campaign, main observation was in the intensive field campaign in the 99. But before that, three campaigns were also made. Basically, we call the pre-Indo-X observation in 1996 and 1997. And then the first field phase experiment was in 1998. So basically, out of these four, the 3 observation was made only by the Indian ship, and only in the 99 the American ship was also joined. So here you can see the cruise track of all these 4 campaigns in this part. So only the one campaign in 2001, which was not part of the in the Indo-X, and basically you can the post-Indo-X campaign, this called the BOVAX, the observation over the Bay of Bengal were also made. And you can see the ship went from almost, they started from the Goa and went up to the Mauritius, and they are almost the 20 degrees south in this part. And following this, the Indian the organizers have also planned another campaign like ICAR, which is basically observation for the trace gases and aerosol and radiation, and which is covering simultaneously in the same year over the Arabian Sea and Indian Ocean. So this is basically, you can say, we have the coverage over the Arabian Sea, Indian Ocean, Bay of Bengal, and they almost in the span of almost in the 10 years period. So if here I'm just trying to show the summary of the Indo-X campaign in terms of the surface-based ozone observation. And now here you can see these are the 4 years in 96, 97, 98, and 99, which I am starting from the top. And here this is the 15 degree north, and the observation started from the Goa region and went up to the 20 degrees south. So you can see very clearly the very systematic decrease in the surface ozone, as we know that we are moving from the source region to the to clean region, and the ozone level is from almost 70 ppb surface ozone going down to almost the 10 to 5 ppb. Or sometimes with some events we have observed 1 or 2 ppb of the ozone in the campaign in 1997. And now to confirm, these are all the observations were made in the winter period, in the dry season, starting from December to February or March. Now, interesting point also, you can see when you are in the coastal region, you have very large variability here. You can see here, but when you are moving to the oceanic region, the variability is very much less. And again, you can see the comparison with the global model, the 3D match model, and that is showing the purple color in the star. And you can see the model is showing very good agreement with the oceanic region, but when you come to the coastal region, the model is unable to reproduce this high level, or this such variability is not seen. So here you can see again indicating the very diverse sources over this part. So main idea was also to see what is the basically possible region of high level of ozone and with the large variability. And apart from this, this was for the ozone, and now I will try to make comparison of the 3 oceanic region. And in terms of the Darwin pattern in the different part of the Indian Ocean, we try to see here, if you focus on this part in the pre-Indo-X campaign in 1996, the Darwin values in ozone give a the first-hand information about the environment itself. And here you can see in the coastal region, you have very large variability and no systematic Darwin pattern. And sometimes you have the daytime buildup. And as we know by considering the photochemistry, when daytime buildup in ozone is seen, that means the polluted air mass is playing a role in photochemistry. But if you see in the middle panel here over the oceanic region, the daytime buildup of ozone is missing, and you can see the early morning time of peak in the ozone level. And the amplitude is lesser.
2 minutes left.
Yeah, I see. I hurry up. Sorry. Okay. And then if you try to see over when you go in the deep, the coastal region, you have the feature of daytime buildup here, you can see here. And maybe I will skip this part. This is trying to show the role of the halogen chemistry. And now you can see this, some kind of the compilation. You compare with the Arabian Sea on coastal India and Bay of Bengal, Indian Ocean, Southern Ocean. You can see ozone level is showing systematic decrease. And interestingly, you can see in the middle, the Bay of Bengal levels are much higher if you compare with the Arabian Sea. And same thing is also seen in the carbon monoxide. And you can see another tracer we had in the SF6. That is also saying Bay of Bengal level are relatively higher when you compare the Arabian Sea. So that means giving indication the Bay of Bengal is slightly different than the Arabian Sea. So depending on the oceanic process. Now this is another very nice result showing how the different sources are influencing over Indian Ocean. And this is the airborne measurement made by the NCAR C130. And you can see very high level of acetonitrile. And I would like to point out the acetonitrile is very good tracer for the biomass burning of biofuel. And another species is SO2, which is also saying same time high level, which is very good indicator for the fossil fuel burning. So this is again showing over the Indian Ocean. This is the region where the two different kind of the processes, they are basically coming at the one place, and again showing that they are originated from the same source region. So this is giving indication that there are different processes are happening, or the emission process are very much different over this part, and that is making the chemistry very much different over the Indian Ocean. And maybe I would like to come to concluding this remark by the one paper in the Lelyfield source. I would like to read, I'm just reading it. The B show that agriculture burning and especially biofuel use enhance carbon monoxide concentration, and the fossil fuel combustion and biomass burning case, they are contributing to high aerosol loading. And both the processes are basically originated from the same place and impacting over the Indian Ocean. And here again, maybe I was just trying to make you for the recent year, trying to show in the Bay of Bengal how diverse variability is seen over the different season and different region. I would like to maybe skip and then come to my final slide and giving the outlook. And this is the basically model simulation made by the Lawrence group. And of course, in IndoX, we could not see how the emissions are impacting of the higher height. And the top panel is showing very nice simulation, showing as a CO tracer, like the pollutant which is emitted from this part, they go at the very height up to around 250 hectopascal, and they are spread in the horizontal direction. So basically, this is showing that the lifting or the convective lifting is very high, and this basically you can see in the monsoon time in the month of the August. And apart from that, if you can see the horizontal extent on the bottom panel, like you can see almost the 20 or the 10 to 20 ppb of CO at the height of 20 hectopascal, they are spreading up to the down up to 20 degrees south in the Indian Oceanic region, apart from the extending this part. So and also during IndoX we could not also see, and that is basically I will say the clue for the future campaign, like how much the basically influence is coming from apart from South Asia, how much influence is coming from the Southeast Asian region. You can see this bottom panel showing the biomass burning in the month of April. A lot of biomass burning you can see over the Thailand and Myanmar region. And also like in the line of the Christa, I would like to add, like
sorry, we have to stop.
Are very limited, so we have to make this long-term ground-based observation. So with this, I would like to conclude, and if suppose time is left for some question, I will be happy to answer.
We have time for a very quick question, and there's already one on the chat. So from Anup Mahajan, why does NOx show higher concentration in the Arabian Sea as compared to the Bay of Bengal if the other trace gases are higher in the Bay of Bengal?
Arabian Sea, the levels are higher.
So why does NOx show higher concentrations in the Arabian Sea as compared to the Bay of Bengal if the other trace gases are higher in the Bay of Bengal?
Right. So basically, like for when you see other trace gases, basically we see in Bay of Bengal the ozone or the SF6 or methane. And in case of NO2, it depends on the source region. Like over the Bay of Bengal, there is in eastern part, there is basically sources of the power plant, and that is basically lifting to more level of the CO. But unlike in this case, over the Arabian Sea, these sources are different. And probably in case of NO, whether the photochemistry is playing a different role, that is, I think, I feel right now. But the different sources, particularly in the Bay of Bengal, the eastern coast is the power plant in the eastern side, they could be the contributing factor. And that is not helping in the enhancement of the NO2 level. But in case of CO, yes, it is there.
Okay, thank you very much. Unfortunately, we cannot accept any more questions. So if you have questions to Manish, please type it in the chat and he will answer it via the chat. So we move on to the next talk, which will be given by, thank you again, Manish, of course, I forgot to say this. We move on to the next talk, which will be given by Nidhi Tripathi. She's from the Physical Research Laboratory in Aryabhatta in India. She's a young student just about to finish her PhD. And she has done a lot of measurements on volatile organic compounds over urban and suburban areas, but also on the Arabian Sea. And I guess this is what she's going to talk about today. And she specialized in isoprene, but also measured the other gases, as I mentioned already. And the talk of her title is, let me check this. Yeah, here we are. SC exchange of volatile organic compounds, VOCs, over the Arabian Sea. So Nidhi, the screen is yours.
Thank you, Hermann, for your invitation. And good morning, everyone.
Good morning.
Good afternoon also. Okay, so is it visible?
Yes, can you go to full screen? Okay,
Yeah.
Great. Yeah, that's good.
Okay, again, very good morning and afternoon, everyone. So, as we have seen, like very nice talk given by Christa and Manish sir about the different trace gases over Arabian Sea, Bay of Bengal, and also over the Indian Ocean. So today I'm going to discuss about mainly volatile organic compound over the Indian Ocean. So as we know, ocean acts as a different source and sink for different trace gases, and volatile organic compound is one of them. And the air-sea exchange of these gases, volatile organic compound, can influence the composition and chemistry of the marine atmosphere. So today, my main focus about the volatile organic compound, and I will show why the study of these gases are important over northern Indian Ocean, especially Arabian Sea and Bay of Bengal. And also I will show one of the result of our study over the Arabian Sea. So first I would like to give the brief introduction about VOC in the marine atmosphere. As we know, like terrestrial plants, phytoplankton also do photosynthesis in seawater, and they release different type of organic gases, for example, isoprene. And after the death of these plankton, like zooplankton and phytoplankton, they are decomposed by viruses and bacteria and converted into dissolved organic carbon. These, through photochemistry, these dissolved organic carbon produce volatile organic compound in the seawater, and then air-sea exchange take place. Once these gases are released in the atmosphere, they get photo-oxidized with OH radical and give secondary VOCs and secondary organic aerosols also. And in the presence of NOx, these gases produce ozone. Several studies reported that the photochemical reaction of VOCs enhancing the particle formation in the marine atmosphere. But why this study is important over the Indian Ocean and especially northern Indian Ocean? So first I would like to give a reason, like these, especially these region, northern Indian Ocean, are highly productive, and as I have showed, the productivity is the major source for the trace gases, especially volatile organic compounds. And the second reason is the ship trafficking over these regions, Arabian Sea and Bay of Bengal, is increasing, and the emission from NOx also increased in these regions, as Manish sir has already showed. And one of his study reported that the elevation mixing ratio of the surface ozone over the Arabian Sea. And as in a earlier slide, I have showed that NOx is one of the precursor for the ozone. And in this campaign, Indo-X, they have reported higher mixing ratio, approx 70 ppb over the Arabian Sea. But in addition to transport, they speculated the role of photochemical formation and downdraft. But to explain the higher level of ozone due to photochemical formation, we need a VOC study in these regions, which were not measured during that campaign. And as Christa has presented, there is a very limited studies have been done over Arabian Sea and Best of Bengal. To best of my knowledge, we found that measurement of VOCs over these regions, Bay of Bengal and Arabian Sea, is very few. Like Srivastava et al., they have measured VOC in the atmosphere, marine atmosphere over Bay of Bengal and Arabian Sea, and their study were mainly focused on the transport part from the continent. And Sahu et al., they have also done measurement of VOC over Bay of Bengal in the marine atmosphere. They discussed about the transport. In addition to transport, they discussed about the oceanic emission of light alkene over the Bay of Bengal. Only 1 or 2 studies have reported that the concentration of VOCs in seawater and the marine atmosphere simultaneous. We have also participated in several field campaigns over Arabian Sea and Bay of Bengal, and we were trying to investigate the role of meteorology parameter and biology parameter for the emission of these gases, trace gases. So today I will present one of our results. This is the first study where we have measured the isoprene over the Arabian Sea, and what we observed, the high level isoprene over the marine boundary layer of Arabian Sea, and we also found this high level is associated with the microbial abundance. So this is the air sampling which have collected along the cruise track during the pre-monsoon season, and also we have collected the water sample for the measurement of microbial abundance, chlorophyll concentration, and SST. And these are the VOCs which we have measured: ethene, propene, and 1-butene, 1-pentene, cis-2-butene, ethane, propane, and isoprene. And also this is the time series for the meteorological parameters, solar radiation, wind speed. In addition to that, we have measured microbial abundance. And what we observed that among all these VOCs, ethene and propene were the dominant VOCs with higher mixing ratio, 8 to 9 ppb and 4 ppb. And also we found the strong correlation between ethene and propene, and they confirms their similar production mechanism in the ocean, and their slope 2.63 fall in the range of value reported for the several oceanic regions. And there is a large spatial temporal variation in these levels were associated with the higher abundance of the higher microbial abundance and variation in the meteorological parameters. In addition to that, we have also calculated the air-sea flux of few VOCs like isoprene and ethene. Using these parameters, where Cw is the concentration of a gas in seawater and C is the concentration of a gas in air, and K is the transfer velocity, U is the wind speed, we have calculated isoprene flux using this formula. Since we could not measure the concentration of isoprene in seawater, so we have taken the mean value given by Oki et al. For the Arabian Sea, 50 picomole per liter. And using this value, we have estimated the emission flux of isoprene, which were in order to 10 to the power 7 to 10 to the power 8. Similarly, we have also calculated the emission flux of ethene. For ethene, there is no measurement over these regions, so we have taken in the range because Bosong et al. In 1988, they have reported the higher concentration of ethene in seawater is 36. As our value, the level of ethene and other VOCs are higher in the atmosphere compared to the value reported by Bosong et al. So that's why we have taken this range. And we calculate the emission flux. The estimated emission flux of ethene were in the range of 10 to the power 2 to 7, 10 to the power 9 molecule per centimeter square per second. And the emission flux of these gases like ethene and isoprene over the Arabian Sea fall on the higher side of the range reported over the other oceanic regions. And a recent study reported by Lee et al., and they have reported the maximum emission flux is in the order of 10 to the power 9 over for Western Pacific region, which is also one of the most productive oceanic region. And our value is also our value is also coming in comparable to the value reported by Lee et al. But however, in the estimation, there is some significant uncertainty with the assumptions of the concentration of these value ethene and propene. But such high emission rate of VOCs in the marine region can significantly affect the regional tropospheric oxidation chemistry, leading to the formation of ozone and secondary organic aerosols. And for that, we need a detailed study of VOCs along with the other trace gases. With that, I would like to summarize my talk, and the major finding was the level of alkenes and isoprene in the marine air of Arabian Sea were higher than the value reported for the other productive region. And also we observed the estimated flux of ethene and isoprene in 10 to the power 9 and 10 to the power 8, which were also high for high and also comparable for the other productive oceanic region. But as Christa said, there is a large gap about the knowledge.
Nidhi, I think we lost you. Connection is interrupted. Ah, that's too bad. Jesse, how can we proceed here?
I think we should just move on to the next speaker and then let Nidhi in again for the questions. I think she was almost done.
Yeah, okay. Nidhi, if you can hear me, so, well, all right.
Yeah, she's probably gone.
Nidhi, can you switch on your microphone, then you're back?
You're muted.
Hello, is it audible?
Yes, we can hear you. We can see your slides. Can you please go on with your last slide? Sorry for the interruption.
Okay, so to understand the role of VOCs in ozone formation and secondary organic aerosols, and also VOCs are very highly reactive with OH radical. So it is well established that due to the VOC, the average lifetime of ozone, average lifetime of methane and carbon monoxide is also increasing. So to understand their impact on the oxidant level, we need a detailed investigation. Thank you.
Thank you, Nidhi. Thank you very much for this very interesting talk. I've seen already that there are questions. Let me check the chat. So there's one question from Christa Marandino. Have you looked at how your isoprene emissions compare to the Bange et al. 2016 climatology? And as a follow-up, do the air mixing ratios and emission match?
Actually, can you repeat?
Yeah, sure. Have you looked at how your isoprene emissions compare to the Bange et al.? Did we lose you again?
No.
No? Oh, of course. Yeah, all right. Sorry. So have you looked at how your isoprene emissions compare to the Bange et al. 2016 climatology? That's the first part of the question. The second one is, do the air mixing ratios and emissions match?
Okay, I have seen Bange et al. And our emission flux is comparable. Isoprene emission flux is comparable with what they have reported. And they have done mainly like southern Indian Ocean. They have reported for the southern Indian Ocean, I think so. And yeah, our flux is comparable, and we need more detailed investigation about the micro surface layer, because this is one of the most isoprene emitter.
Okay. Christa, just comment on your reply. We made a global climatology, so that's what, which is including the whole Indian Ocean. So that's a comment on your reply. There's another question by Ashish Bhargava. Is there any influence of 11-year solar cycle over VOCs?
Yeah, it can be, but we need to check, and we need continuous measurement, because solar cycle, like solar radiation, is one of the important factor for the emission of these gases, but we need to check.
Okay, so Nidhi, thank you very much. This was very interesting. Okay, so we move on to the next talk, which will be given by Swapna Panickal. She's a senior climate scientist at the Indian Institute of Tropical Meteorology in India. I guess it's based in Pune. She's the lead author of the IPCC 6 assessment report, and she's also a member of the working group on coupled modeling of the World Climate Research Program. And her interests includes research system modeling for addressing the science of climate change, sea level rise, and understanding the changes in monsoon hydrological cycle. So we're moving now from the atmosphere into the ocean. And I welcome Swapna Panickal to give her talk on, which is entitled Climate Change and Regional Sea Level Rise, an Indian Ocean Perspective. Swapna, the screen is yours. Okay, welcome.
Yeah, thank you. Thank you for the introduction. Just I'll share my screen. Is it visible?
Yes.
Yes.
Yeah, okay. Thank you. So good morning, all of you. Myself, Swapna Panickal from IITM Pune. So actually, we have heard a lot about trace gases and exchanges, mostly in the atmospheric fields. So in this talk, we'll move on to the impact of climate change, how it is affecting the Indian Ocean. So in my talk, basically, I'll be talking about how the sea level is changing over the Indian region and what are the regional forcings that contribute to the sea level rise in the Indian Ocean. So the side graph, we can see that this is an elevation map of India. And we know like India has a very long coastline, more than 7,000 kilometers, including the island territories. And most of our coastlines are low elevated. They are few meters above the sea level. And Indian Ocean is rapidly warming, and there is an increase in the sea level rise. So both of these can contribute to, will have implications for the coastal population. So as we already know, like there is Indian Ocean region is densely populated, major portion, like 40% of the global population, we can say, or 1/3 of Indian population, they live in and around Indian Ocean region. So high population also implies that there is a high climate related risk. So in this background, we will see like what are the factors that causes the sea level rise in the Indian Ocean and how it is different from the global, and how the changes because we know like for the Indian region, monsoon circulation is one of the dominant forcing for the Indian Ocean, and we'll see like how the changes in the monsoon causes the changes in the sea level in the Indian Ocean and some of its implications. As all of us know, like global temperatures has been increasing. And since the pre-industrial times, almost like more than 1 degree warming has been occurred globally, and the anthropogenic greenhouse gas emissions also are increasing. Like on carbon dioxide concentrations, for example, have been more than 400 ppm that has been recorded recently, and even they have crossed the recent years. So what are its implications? How it is impacting the ocean, or how it is impacting the Indian Ocean, that we will see something in detail. And most of the heat, because of the trapping of the heat in the Earth atmospheric system, we see that most of the heat is absorbed by the oceans. We can say like more than 90% of the heat is absorbed by the oceans, which is much higher compared to the other components like atmosphere, continents, or ice. So more than this 90% of the heat that is going into the oceans, what does it cause? We see the ocean heat content or the heat uptake by the oceans. We can see that this is from the last IPCC report, AR5, and they have shown that last 5-6 decades, the ocean heat content has been increasing globally. And most of this heat is trapped within upper few layers of the water column. In such a scenario, then there is much trapping of heat in the oceans. So what will happen? Most obvious consequence of the trapping of the heat is the rise in the sea level. Both the instrumental or proxy records available since 1860s, they show that global mean sea level has been rising. It is rising at a rate of about 1.7 millimeter per year. And recently, since 1993, we have got the satellite observations from altimetry of sea level that gives a global coverage. And they also shows that there is an increase in the sea level. However, the satellite altimetry estimate shows that the global mean sea level is rising by 3.3 millimeter per year. That is much higher compared to the previous estimates. So why this is caused and how it is different in the Indian Ocean? So this is a snapshot of the sea level, and we can very clearly see that sea level rise is not at all uniform. There are regions when sea level is rising and the other regions sea level fall. So we need to know like what causes these changes. So basically we can classify the factors like there is the increase in the volume, like when the temperature increases, or the salinity changes. That can cause a thermal expansion or the volume increase in the volume, and that can cause a rise in the sea level. And another is due to the addition of the mass, because as the temperature increases, there is a large-scale melting of the continental ice sheets and glaciers. They add up more water to the oceans. Both of these, like when the mass increases, that also causes a rise in sea level. And also when the temperature or the salinity changes, basically the temperature changes, that causes a thermal expansion and that causes a rise in the sea level. However, on a regional scale, there are other factors we have to consider, like changes in the wind stress that drives the oceans, changes in the ocean currents, and the heat distribution. These are the regional factors that contributes to the regional variations in the sea level. Because IPCC assessment report AR5, they have clearly indicated that whatever observed global mean sea level rise, which is high confidence is given like it is due to the anthropogenic causes. However, there are spatial departures or the deviations from the global mean that is entirely different from the global mean picture. So in the case of the Indian Ocean, the center figure, that is a sea level trend since 1950s from the available reanalysis data sets. And we can see that very prominently see that there is a rise in the sea level. It is not at all uniform in the Indian Ocean. We can see a very huge rise in the sea level in the South Indian Ocean and also in the north. Whereas in the just south of the equator, it is the open ocean of the upwelling dome where there is a fall in the sea level. So what causes these fluctuations? There have been studies like the lowering of the sea level is caused by the changes in the wind stress curve. Whereas the South Indian Ocean, it is connected to the Western Pacific through the Indian Ocean through flow. So the recent hiatus warming period that has occurred recently, many studies, they have reported that the heat from the Pacific is entering into the Indian Ocean. So these decadal and multi-decadal scale fluctuations like PDO and so everything will have a large impact on the heat exchange, heat and freshwater exchange to the South Indian Ocean, and they can cause a rise or fall in the sea level in that region. However, if we see the North Indian Ocean, Arabian Sea and Bay of Bengal, North Indian Ocean is landlocked. So there is no exchange of heat with the northern regions like it is happening for the Atlantic or Pacific Oceans. But here it is landlocked in the tropical regions. So whatever heat that is getting in the Northern Indian Ocean, it is getting accumulated there. That has an implications for the rise. And the line graphs they have shown are the observed tide gauge records along the west and east coast of India. And suppose like Mumbai, Cochin, many of the stations, they all record like there is a continuous rise in the sea level along our Indian coastlines. And these are the different data products. First, we try to understand like what causes these changes in the sea level in the Indian Ocean. Especially we are focusing on the north because south is having a lot of contributions from the Pacific variability. So, but in the North Indian Ocean, it is very much regional. So we see the North Indian Ocean, we see all the multiple lateral. First curve is from the satellite data and the tide gauges and also all the available reanalysis products. All of them shows that there is a rise in the sea level in the North Indian Ocean. And we know, like Indian Ocean, the wind pattern of the Indian Ocean is dominated by the southwest monsoon winds, which basically flow southwesterly during June to September, and there is a northeast monsoon. However, the winds during the summer monsoon is so strong that the annual mean winds over the Indian Ocean, it is dominated by the southwest monsoon. So what happens to the meridional heat transport? If there is a summer cross-equatorial southwest monsoon winds, so they transport heat according to the Ekman transport theory. It has to transport heat from northern Indian Ocean to the southern Indian Ocean. In a scenario when the monsoon is weakening, so what will happen? There is a less transport of heat which will happen from the North Indian Ocean to the South Indian Ocean. That means there is more heat is getting retained in the northern part of the Indian Ocean. So we looked at the different factors, like how the monsoon is changing over the Indian Ocean. The black curve, it is the wind shear between the upper and lower levels of the Indian Ocean, which show during the monsoon season, that is June to September, they shows that large-scale monsoon winds are weakening. Sea level pressure, Indian summer monsoon rainfall, all the indices are showing, like since the 1950s, like 5 to 6 decades, there's a large-scale weakening of the monsoon, which is also seen from the different wind stress products. And also we see the rainfall patterns over India. This is an observed rainfall from India Meteorological Department, which is available since 1870s. And we again see that the red bars, they are all the below normal rainfalls, which has been occurring very recurrently in the last 4 to 5 decades. And there are many studies like Roxy, Krishnan, Bolasina, et al. Many studies, they also have shown that there is a decline of rainfall over the Indian region in the last 5 to 6 decades. So in such a scenario, then how the ocean will respond, or what is the consequence for the Indian Ocean heat transport and the sea level? So when there is this is just a schematic representation of the meridional heat transport mechanism in the Indian Ocean. We have in the surface layers, we have a north to southward heat transport that get subducted in the south of the Indian Ocean, south of the equator. And there is a northward branch that flows through the subsurface, and that upwell one along the open ocean upwelling dome, which is south of the equator, and there is another branch that upwells along the upwelling regions of the Somalia, Arabia, in the Arabian Sea. So this is the structure of the cross-equatorial cell, and it is very shallow. It is about 500 meters. So when there is when the monsoon circulation is getting weakened, heat is getting retained in the North Indian Ocean. That causes exactly a rise in the sea level. We can see in the Arabian Sea, Bay of Bengal. And also when the monsoon winds weakens, there are strong westerlies along the equatorial Indian Ocean. They can depress the thermocline in the eastern part of the equatorial Indian Ocean. So they causes basically a rise in the sea level in the North Indian Ocean. So to further understand, like we have seen that there are different factors, like there's a temperature, salinity, mass, all of this can cause the changes in the sea level. So what is that applicable for the Indian Ocean? If we see different components, we again see that it is the thermal expansion. It causes the rise in the sea level. However, for the global oceans, it is basically the increase in the mass because of the melting of the ice and glaciers. So just quickly go to the future projections. They also shows that in the Arabian Sea, there is a projected increase in the sea level by the end of the century. This is again from the last IPCC assessment report. And what are its consequences? One of the consequences is that Indian Ocean is getting warmer because we are seeing many severe cyclonic events that has been occurring very, very frequently in the Indian Ocean. So there is an increase in the mean sea level, and also there are increases in the cyclonic events that causes long storm surges. So all of this can also lead to extreme sea level along the Indian coast, which is shown in the down graph. And so what we can do for this, how can we study them in detail? We need observations. So the up graph is the active tide gauges in the Indian Ocean from Beale et al. 2019. We have observations in Mumbai, Cochin along like since more than 100-year observations, but we need a continuous record of observations. And also we need some modeling studies so that we can understand the mechanism, what causes the rise in the sea level. This is one of the examples from our center. We have IIT and ESM, which is contributing to the CNIP 6. With the advancement of the modeling and observation techniques, we will be able to further understand our how the sea level is changing in the Indian Ocean in the present and in the future.
Sorry, 2 minutes left. Oh, okay, right, good. Okay, thank you very much. That was just in time. Well, I guess we have already a question on the chat. So there's a question from Vaishnavi Pandey. What is the prevailing Indian Ocean dipole conditions over the Indian Ocean region? Can IOD contribute to sea level rise?
Yeah, on an interannual time scale, yes, IOD can have a contribution to the sea level. But if we go to the multi-decadal scales, there are other factors. When IOD happens, we have two poles, and that will definitely contribute on an interannual scale.
Okay. Are there any questions? Then I have a question. So can you a little bit speculate about sea level rise and the connection to trace gas emission? Do you think that the enhanced sea level rise will increase or decrease the trace gas emission from the coastal areas?
Yeah, it is. I think it is related to the stability of the water column. When the water is getting more warmer and sea level is projected to rise, and when the water is more warmer, it causes more stability of the water column. So that will have an implications. Like Arabian Sea, we are seeing like Arabian Sea is warming at a much higher rate compared to even other regions. So that will have an implications for the trace gas emissions from the Indian Ocean.
Okay, good, interesting. Yes, thank you.
Thank you.
If there are no other questions, we move on, and thank you very much for this interesting talk. We move on to the next talk and the last talk of the session that is given by Roxy Mathew Koll from the Indian Institute of Tropical Meteorology in India. And Roxy is a climate scientist, and she is interested in research on climate change and how it extends the rapid warming in the Indo-Pacific Ocean and its implication to global rainfall patterns, the monsoon, and the marine ecosystem. Roxy is also co-chair of the CLIBA Indian Ocean Region Panel and the lead author of the IPCC Special Report on Oceans and Cryosphere in a Changing Climate. So, Roxy, we are looking forward to your talk. Swapna, could you please? Yeah, okay, thank you.
Yeah, perfect.
Okay, Roxy, the screen is yours.
Just a moment. Yeah, perfect. So thanks a lot for the beautiful introduction, Hermann. And I'm happy that some of the key points here have been already discussed by some of the speakers earlier. Christa talked to us about how the monsoon winds bring the rains from the Indian Ocean over to the Indian subcontinent. And Swapna talked about how the monsoon has been changing. So some of my task has been made easier, but there are some specific salient points which I would like to explore in this talk here. So let me highlight my pointer. Yeah, the pointer is here. I hope you guys can see. So this is a picture similar to the what Swapna showed about the all India summer monsoon rainfall. We have measurements from 1870s. That's about more than 140-50 years of data collected by the Indian Met Department and then organized by IITM. So at IITM, the Indian Institute of Tropical Meteorology, it's under the Ministry of Earth Sciences. We have about 150 scientists working on monsoon and related aspects. So we have been closely monitoring how the monsoon has been changing, what are the links with the Indian Ocean, because the Indian Ocean provides the moisture supply. It's the supplier of the moisture for this monsoon. So any changes in the monsoon or the monsoon extremes can be easily traced back to changes in the Indian Ocean as well. So let's see what are those changes. So this is a very simplistic view of the changes in the monsoon. So the blues here shows the wet years over the Indian subcontinent. The reds here shows the dry years over the Indian subcontinent. And this smooth line shows the multi-decadal variability. Obviously, there is a multi-decadal variability of the monsoon. But if you look at the earlier period from 1870s to 1950s, you can see the blues and the reds are like scattered over here and there, intermittent. There is no clear trend. And obviously, there is a multi-decadal variability. But if you look at the recent period, you can see there is a slump in this multi-decadal variability, which is caused by this number of reds, which means that the number of droughts are increasing in the recent period, and the number of wet periods are quite low, especially since, except this current year, 2020, we didn't have any wet years which went above 10% of the mean. But the All India summer monsoon rainfall doesn't give an insight into the regional distribution of rainfall or the monsoon extremes or how it is connected to the Indian Ocean. For that, we need to look at how it is changing across, on a spatial scale, which is why we have these figures. We have two figures. One is the trend in the total rainfall during the summer monsoon, when the monsoon winds carry the rains from the Indian Ocean towards the land. And the figure on the right is the trend in the frequency of extreme rainfall events. And let's have a look at the first figure. All the blues which you see are the decreasing trend in monsoon rainfall. So if you look at the subcontinent, you can see, and this is a key factor for the entire South Asia as well, there are large patches where the monsoon rainfall is declining. Central India, North India, Northeast India, parts of the west coast of India, where I'm located, and you can see there's a huge decrease in rainfall. It's up to 10 to 20% in some parts of India. So if you look at the All India rainfall, the mean of All India rainfall, we may not see this clear picture. And if you look at the trend in the frequency of extreme rainfall events, you can see, so the reds here are where the rainfall events are increasing. That's the extreme rainfall events where the daily rainfall is above 150 millimeter per day. So again, over Central India, Northeast India, and parts of Western Ghats near Mumbai. Mumbai is over here, and parts of other regions. So some of the heavily populated regions, you can see that the extreme rainfall events are increasing. So this presents us with a dilemma for not only the economy of the region, but also for the farmers, for the daily livelihood, and also presents us as interesting scientific questions. Why the total monsoon is decreasing while the extreme rainfall events are increasing? So the gray line here shows the temporal or the time series change in the total rainfall, and the red line shows the time series change in the extreme rainfall events. So you can see, so this essentially means we have more dry spells in this region, more dry monsoon spells, intermittent with short, heavy rainfall events. And this has been presented by several studies, some of our studies from IITM as well, and also the climate change assessment report in 2020. So that's one report which you guys can look into. IITM and the Ministry of Earth Science came out with a climate change assessment report, which consolidates many of these changes for the region. And this is a figure which Swapna has beautifully presented, which talks about where the additional heat from climate change or global warming has gone to. So I'm not getting into the details of it, but some more specifics. So the recent IPCC SROC, or the special report on ocean and cryosphere in a changing climate, shows that the numbers are in fact about 93%. 93% of the total heat from global warming is going in the oceans. And there's another study by Cheng et al. In scientific reports, which clearly gets into the calculation of these values. But one of the interesting point is that all ocean basins are warming, but some are warming more than the others. This is like a scenario from the novel from George Orwell, where he says all are equal, but some are more equal. So if you look at this figure, it compares the warming in different ocean basins for 0 to 700 meter. And this is true for the surface as well for the last 60, 70 years. And the green shows the Indian Ocean. So you can clearly see there is a monotonous continuous warming across all the ocean basins, but it's much more larger for the Indian Ocean. And if you look at the deeper ocean as well, this is reflected in the deeper ocean also. That is from 700 meters to 2,000 meters. So that's a lot of heat that the Indian Ocean is absorbing. Some of the reasons that Swapna explained recently. So how does it reflect on the surface? So many of you might have heard about the Indo-Pacific warm pool. So these are the sea surface temperatures during summer. These are the mean sea surface temperatures for 1900 to 1980. Okay, summer on the left and winter spring on the right. And bottom panel, we have the recent pictures of recent mean for the same sea surface temperature for both the seasons. Now the deep brown colors here indicate the warm pool regions. All the yellow deep brown colors indicates the warm pool region where the sea surface temperatures are above 28 degrees Celsius. So 28 degrees Celsius is quite important because above that, these ocean waters can support enhanced convection. So this is like the heat engine of the globe, the Indo-Pacific warm pool region. And if you look at the recent period, the dark colors are the enlarging or increasing. So the temperatures which are like 27, 26, you have the color scale on the rightmost panel. Temperatures which were like 26, 28, they are becoming 30 degrees Celsius in the recent period. And June to September is that monsoon period where convection is active. So it essentially has a huge impact on the convection. And are these due to global warming? Are these due to human-induced emissions? There has been a lot of studies. One of the studies here by Weller et al., human-caused Indo-Pacific warm pool expansion. So they explored observations and simulations, different forcings. So they saw that the Indo-Pacific warm pool is largely warming due to greenhouse gases. Natural forcing alone can't result in that scale of warming. And this is shown here. If you look at the blue line, that's the natural change in the warm pool intensity. It doesn't change at all. But if you look at the red line, it is due to the greenhouse gases. It shows a monotonous increase in the warm pool intensity. Same for the area also. So it's not just the intensity of the warm pool, but also the area of the Indo-Pacific warm pool that is increasing over time. Now, if you look at the trends of the Indo-Pacific warm pool, again, we know that the warm pool shifts north and south due to the solar radiation, seasonal migration of the solar radiation. And accordingly, the trends also, we have to look at the trends independently. So if you look at the summer trends, you can see there is a lot of warming in the equatorial region, particularly over the West Indian Ocean. Yeah, this was shown by Christa also in the first few slides. And these have an impact on the Asian monsoon, particularly in the weakening of the monsoon because of the changes in the land-sea temperature gradient. We will get into that. It has impacts on the sea level rise. Swapna already explored that. It has also impact on the extreme rainfall events because more moisture is available, more temperature is available. It makes the monsoon the monsoon variability much more increase. We will get into that. It has impact on the marine ecosystem, and it also has intensified the cyclones, which again are kind of pre-monsoon extremes. And there are other changes also because of the changes in the Indo-Pacific warm pool. So let's get into some of the monsoon extremes. One is the weakening of the monsoon circulation or the total monsoon rainfall. So what we have seen is that this is a picture of the local Hadley circulation for the South Asian domain, for this domain, what you see here in the middle. So if you look at the equatorial region, these are the trend in the vertical velocity again for the last 60 plus years. You can see the Indian Ocean warming has increased the ocean convection. I told you that about 26, 28 degrees Celsius, it supports enhanced warming. So there is that warm pool enhancement of the Indian Ocean, especially over the equatorial region, has enhanced this upward motion over the Indian Ocean. And that is compensated by a subsidence of dry air over the Indian landmass. It's a very simple explanation of how the Indian Ocean warming can reduce or weaken the local Hadley circulation or the monsoon circulation. And that is reflected in this picture.
Yes? Sorry, 2 minutes left.
Yeah, that means I have to speed up. Yeah, so this is reflected both in the surface and also in the upper tropospheric conditions also. You can explore some of our studies from our group. And as a result, if you look at the average of rainfall over central India, you can see a consistent decline in the monsoon rainfall. This is the same data, but for the central Indian region. Now, but why are the extreme rains increasing if the total monsoon is decreasing? So we all know that along with the Indian Ocean warming, there is a lot of warming over the Arabian Sea region also. And this has resulted in a lot of moisture available. And when there is more warm moisture in the atmosphere, it increases the monsoon variability of the monsoon westerlies. This is a trend in the daily variability of moisture transport. So there is a lot of variability or fluctuations, which results in a lot of variability in the precipitation. So occasionally we have these sudden spurts of increased rainfall over this region, which results in these extreme rainfall events. So that comes to my almost last two slides, which means that we need more observations to monitor the warming in the Indian Ocean. We talked about a lot of uncertainties today in the morning, and we still have these uncertainties left. So in the 1990s, we had more observations in the Pacific and Atlantic, but none in the Indian Ocean. This has been improved in the recent years, but with climate change, we know that we are presented with more uncertainties, especially with the heat budget and all. And which is why, so the INDOS, which I talk about here, is the Indian Ocean Observing System. With the Indian Ocean Region Panel and other scientific community, we did a major review in the last 3 years, where SOLAS also can collaborate. So INDOS is for sustained observations, which is why I asked about sustained observations in the trace gases as well. So we need more observations and collaborations in terms of better understanding these changes. And thank you all for listening to me. A lot of collaborators were involved in this work from my own lab, climate research lab, and also the INDOS team, the Indian Ocean Panel, Indian Research Forum, IOA2, IOBOOS teams. Peter Buchel is here, and IPCC and UN Decade of Ocean. So welcome for SOLAS as well, and let's hope we can collaborate more on these sustained observations. Thank you.
Thank you, Roxy, for this very interesting, nice talk, and for your plea of cooperation, which I really appreciate. Okay, there are 2 or 3 quick questions. So one is from Arvind Singh. Your analysis suggests a decrease in rainfall over India, but there is a lot of heterogeneity in rainfall over India. So over which regions in India rainfall have decreased in the recent decades? Well, sorry, the screen swapped, so I lost.
Yeah, so.
Yeah, you could, yeah.
But you can see me, I guess. I stopped sharing so that the next person it's easy.
Yeah.
So yeah, exactly. Which is why we need to look at the regional variations and the connection with the Indian Ocean to these regional variations depends on where the subsidence is, where the monsoon changes are larger or smaller. And what we have seen is the largest impact is over the where the regions where the west monsoon westerlies act. That is on the Western Ghats region, and also the central Indian region where the Western Ghats is open and where the westerlies penetrate. So, and then there is some impact on the northeast also. And these monsoon westerlies act along with the low pressure systems from the Bay of Bengal as well. So these interactions we need to explore that further. But these are the regions where the decrease in monsoon rainfall is the largest.
Okay, thank you. I guess we have time for 2 quick questions. So one is from Peter Burkel. Thanks for your clear talk. Heating of Indian Ocean depends in part of the leakage of heat via the Agulhas of South Africa. Can you comment?
Oh, yeah, very much. So the ocean currents and the interaction with the winds, like Swapna told, they all interact with each other and distribute the heat across the Indian Ocean. And one of the pathways is we have an inflow from the Indian Ocean through flow and outflow from the Agulhas. These are only few of the outflows because the north of Indian Ocean is landlocked. So, but we are still not clear about the changes in the outflow inflow because of lack of very clear observations. So obviously heating of IO also depends on the leakage of heat via the glass, but we need better observations, and that's the key point I made over there. Thank you.
We need better observation, and we need more money to do this.
Regional cooperation is the key,
yeah,
I guess.
Sure. Yeah. So one last question and a quick answer. The question came in via YouTube from Sumit Mukherjee. Dr. Roxy, can you make some comment on the temporal variation of depths of the Indo-Pacific warm pool? How is the mixed layer varying in recent decades?
That's quite an interesting question. I think I have seen at least one study looking at the temporal variation of the depth of Indo-Pacific warm pool. So along with the SSTs, so I showed in one of my earliest slides how along the sea surface temperature, the 0 to 700 meter temperatures are also increasing. So whatever you are seeing in terms of the warm pool expansion, it's reflected in the subsurface as well. But I'm not clear about the mixed layer variation in the recent decades, but the trends which we are seeing in the on the surface is reflected for the 0 to 700 meter also. That's for clear. Thank you.
Okay, thank you, Roxy. I think we need to stop here, and we thank you for this nice talk. And we moving on to the poster session, which will be led by Suntharalingam. She's from the University of East Anglia, and she's a modeler, modeling nitrogen cycles in the ocean, sulfur cycles in the ocean, and she's based at the University of East Anglia in Norwich. And also the poster session is led by Anil Kumar. He's from the National Center of Polar and Ocean Research in India. I guess it's in Goa. And he has participated in several cruises to the Indian sector of the Southern Ocean. And yeah, now I hand over to the poster session. Parv and Anil, please take over. And I thank all the speakers for the morning session, for the first session, for all these interesting and very inspiring talks. Thank you very much. So.
Okay. Good morning and good afternoon. And thank you for giving me an opportunity to share my time with the SOLAS session. So the posters we will keep the posters open for 1 week time for the members to see and make comments or questions about it. And now the posters are ready. So I think I can invite the presenters one by one. Those first presenter, Gad Devi, the topic Indian Ocean, ITCZ, and the Indian summer monsoon. Dr. Gad Devi, please.
Hello, maybe we can also...
So in 1 minute, what we are trying to do is to search for diagnostic and predictive signal of the monsoon interseasonal oscillation and monsoon breaks in observable and modeled large-scale circulation parameters like SST, ITCZ signature, precipitation, and fluxes. How we do it, we derive some indices, a meso break indice, an ITCZ phase index, and we apply different long-term series observation, time series observation, and blended analysis product to simulate them and analyze the data to establish diagnostic and predictive signal using different analysis methods. And the methods we use are automated and user-trained algorithm and indices, multi-resolution analysis via wavelet, transform, machine learning algorithm, fuzzy logic models. And the physics behind it, there is a conceptual model on the first background. And since it was such a short notice, not everything that we have done is included there.
Time is over, 1 minute. Yeah, let us go to the next poster, please. That is 1 minute. Dr. Banerjee, a case study of characteristics and vulnerability. Tropical cyclone.
Dr. Banerjee, could you unmute, please? Do we have Dr. Banerjee here?
Dr. Banerjee?
I think we lost him. He was here, but now he's gone.
The next one?
Okay, I'll move on.
Yeah, next one is by Chayanika Devi, Indian Ocean Salinity and Temperature.
Hello everyone. So my poster presentation's main focus is that how machine language can help for oceanography data visualization. So here I'm using the Python model. So I have using the NumPy as the NumPy can create the multi-dimensional array objects from a given table. So for here I am using the CSV data. So that CSV data I have plotted using the Python code. First I have read the file, then I have plotted the salinity and temperature data visualization. And for this work I am doing for the computational algorithm for the best data visualization processes, and I'm using here the stack bar plot and radar search for the best computational algorithm processes. And here I have using the Python coding to show the only the data visualization. Thank you so much.
Okay, thank you. So we will go to the next one. That is Dr. Anu, 10 to 20 day variability in sea level along the east coast of India.
So good morning all. So this study looks at the 10 to 20 day variability in sea level along the east coast of India. We show that the 10 to 20 day variability in wind has high spectral energy in northern Bay of Bengal, and we examine the implication of this high energy for the sea level variability in this band. Spectral analysis shows that the variability is decreasing equatorward, and it is more pronounced during June to November period. This sea level is seen to propagate equatorward as CTW wave having a phase speed of 2 to 4 meters per second. Here we also show that the energy from tropical cyclone and equatorial region also contribute to the sea level fluctuation along the east coast of India. Thank you, sir.
Okay, thank you. And next by Jayanti Paul, seasonal variability of different modes. Please, Jayanti Paul, please.
Good morning, all of you. My topic is basically to study the seasonal variability of the different modes of the tropical Indian Ocean during the warming climate. As we noted that the Indian Ocean has warmed, and it is from the Hermann diagram that is clearly depicted that since 1984 there is a continuous increase in the tropical Indian Ocean, and based on this warming, actually we have divided the three epochs. One considering the whole trade, that is from 1950 to 2019. The second epoch is 1950 to 1984, and the third one is 1985 to 2019. So here what we have done, that we have, by classifying this three epoch, we have analyzed the seasonal sea surface temperature anomaly through the empirical orthogonal functions. As we know that EOA first mode is basically considered as the white basin white mode. So here we clearly see that every season the first mode is continuously increasing, whereas Aryabhatta is shows a weakening trend in the recent decade, and also there is a seasonal variability of the cycle structure from one season to another. Thank you.
Okay, let us go to the next poster, please. Dr. Mithun Sundar, a note on the dissipation of interfacial waves.
Good morning. I am Mithun Sundar, an MS student from IIT Tripathi, working along with Dr. Girish Kumar Rajan to investigate dissipation.
Dr. Mithun, you are not audible.
Am I audible now?
Yeah.
Okay. Good morning. I am Mithun Sundar, an MS student from IIT Tirupati, working along with Dr. Girish Kumar Rajan to investigate dissipation in ocean spell. The aim is to develop an accurately predicting mathematical model. The schematic here shows an interfacial layer of finite thickness, which can be taken as a complex non-linear fluid. The reason for doing so is some of the important interfacial layer constituents like oil spill layer, chemical spill layer, and phytoplankton layer exhibit non-linear characteristic. The relation shows the non-linear characteristic, and the graph here, taken from Kumar et al. Published in Indian Journal of Chemical Engineering, shows a non-linear characteristic of crude oil under the ideal condition. In the recent Mauritius oil spill case, a 0.3 mm thickness of interfacial layer is recorded, while in Chennai oil spill case, a 0.02 mm thickness of interfacial layer is recorded few hours after this incident. So in our research work, we will derive the dispersive relation and dissipation rate. So so that we can validate our model with the field
Yes,
data.
Dr. Nidhi, your time is over. Thank you.
Thank you.
Then we will go to the next presenter, Dr. Saurav Sil, temperature inversions studies using Argo.
Yeah, good morning, everyone. So one thing I want to introduce that there are a lot of Argo profiles available over the Indian Oceans. And one important feature in the particularly Indian Ocean is the barrier layer, and within that there is a temperature inversion. So one of our studies shows that inversion layer can be up to almost 2.5 degrees centigrade. And it has a role to impact on the ERC interactions, particularly in pre-monsoon and post-monsoon time. In figure 4, you can see there are Argo profiles available in January from 2003 to 2019. And we can observe that temperature inversion go up to 4.5 degrees centigrade. So there is more observations are maybe needed, and some targeted processes, as Dr. Roxy told, that there is a warm pool reaching.
Thank you, Dr. Saurav. Your time is so we will go to the next presenter, Dr. Suresh. Province's tracing of long-range transported dust. Dr. Suresh, please. Dr. Suresh.
Okay, shall we move on then?
So the next presenter, Dr. Cicely Gue, major impact of atmospheric ion. Dr. Gue.
Okay. Shall I move on? Move on to the next.
So next presenter, Dr. Manjunatha, atmospheric input of nutrients to the southwestern continental margin of India.
Yes, sir.
Yeah.
Hi, everybody. This is a very nice occasion to exchange our ideas, especially the west coast of India is induced by southwest monsoon. But the major part of the Arabian Sea covered by the deserts and desert impacts. The main aspects of the study was to determine the nutrient values of the dust that is introduced to the Arabian Sea, particularly around Mangalore. Mangalore is the region where the monsoon flow is very high, the core of the monsoon flow. We get rain about more than 200 to about 700 centimeters along the Western Ghats. So we have used 3 stations to determine the nutrient properties of the dust, particularly during the north east monsoon, that is the winter monsoon. So the fluxes around, particularly the nitrate, phosphate, silicate, they induce ocean productivity.
Your time is getting over. So we will go to the next presenter, that is Dr. Ankush Kaushik, chemical characterization of coarse and fine aerosols. Dr. Ankush?
Yeah. Am I audible?
Yeah. Please go ahead.
Yeah, so my poster presentation topic is chemical characterization of coarse and fine aerosol over the Northeast Arabian Sea, their sources and temporal variability. So the objective is to assess the seasonal variability of chemical constituents in PM10 and 2.5 particles, and also to identify the major sources impacting on the study sites. So aerosol samples were collected by using high volume samplers for the both PM10 and 2.5 particles. So the results are here. So for the water soluble ionic composition, there was a large variability observed in post-monsoon season, and for the sea salt, that sea salt was contributed by PM10 particles majorly as compared to the PM2.5 particles, and also the percentage contribution of the sulfate of the ammonium is dominant in all the seasons, as we can see in the pie charts. And for the crustal species, so calcium and the magnesium are dominant.
So we are moving to the next presenter, that is Dr. Panickal.
Okay, I need to, Dr. Anil Kumar, I need to switch files now for the next file.
Okay.
So can you see my screen now?
Yeah, we can see.
Okay.
Dr. Panickal, please.
Good morning, everyone. Am I audible?
Yeah, you're audible.
Hello.
Yes.
Okay. Good morning, everyone. Hello.
Yes. Go ahead.
Hello.
Yes.
So,
Please go ahead.
objective of my study is to characterize the dust and trace metal, which is the major nutrient to the open ocean region. To understand and
IMD FATA, main road पे IMD FATA के opposite में, हाँ.
I think we need to mute. Thank you.
Yeah, I think some interruption is there. Shall we go to the next one? Yeah, that is Dr. Imandar.
Hello, everyone.
Suleha.
Yes, can you hear me?
Yes.
Yeah.
Yeah, hello. The focus of this poster is on the role of iodide parameterization. We did not have any sea surface iodide measurements in the Indian Ocean so far, only until the recent Chance et al. 2020 paper. So far we have been using parameterization.
I think we have Dr. Panda. Can you mute, please? Okay, Dr. Inamanda, can you continue?
Yeah.
Yeah, sure. So sea surface iodide so far has been measured using parameterization techniques given by Chance et al. 2014 and McDonald et al. 2014. Now what we did here is we applied these parameterization to the Indian Ocean and Southern Ocean, and we found that they do not match with the observations that we got during the 9th ISOE expedition. The focus here is to improve the iodide parameterization because these have been used by models to calculate the fluxes, inorganic iodine fluxes. And so we have seen that the observations of iodine oxide that we have made during these expeditions have not matched completely with the fluxes, even though we can say that there has been like some correlation, but improvement is necessary to get them right. I hope I'm within the time limit.
Okay. Next is by. Hello.
Hello.
Yeah. Next is by.
Yeah. Yeah. During the Aqaba cruise, we passed the Arabian Sea twice, and we measured in that region substantial amounts of biogenically derived VOCs. That is DMS, its oxidation product, DMSO2, and also, if you can scroll down a bit, a new found molecule, methane sulfonamide, or MSAM. And during the first passing, actually the concentrations of DMSO2 and MSAM were quite low. And this we attribute to the fact that the air masses were coming from the Somalia upwelling, and during the first passing, there was low biological activity. However, during the second passing, there was a lot of chlorophyll A concentration in the seawater, which points at biological activity. And then we also saw substantial amounts of these trace gases.
Okay, thank you. Next by Srivarthan Viswa, the third revision of the bottom-up DMS climatology.
Am I audible?
Yeah, you're audible.
Yeah. The previous DMS climatology L11 was revised using an updated DMS database and refining the processing algorithm. Firstly, by temporal unification to ensure there is no instrument-based bias. Secondly, using dynamic longest provinces for realistic biogeochemical response. Thirdly, by testing multiple radii of influence, ROI, for smoothing of the variability in DMS, thus creating REV3 climatology. The REV3 estimated higher values in the Indian sector of Southern Ocean, if you could scroll down, and in Antarctic region, while giving lower values in the tropical Indian Ocean as compared to L11. We observed that reducing ROI less than 75 kilometers had a little difference in the regional mean, indicating lower algorithm sensitivity below 75 kilometer scale. Thank you.
Okay, thank you so much. Next is by Dr. Sabu, abundance and activity of methane oxidizing bacteria. Sabu, please.
Hello, am I audible?
Yeah.
Good morning, everyone. My topic is the expansion of aquaculture industry has resulted in the methane emission, and the expansion of the aquaculture industry is to meet the protein demand of the global population. And India is ranking second in the global aquaculture production. Only part of my PhD work related to the methane aspect with specific interrelationships with various environmental parameters has been presented here. Methane-related microbial activities within the aquaculture shrimp ecosystems involve highly complex and dynamic interactions between the environmental parameters with the different bacterial communities belonging to various biogeochemical cycles. In the present study, the methane produced in this ecosystems are effectively being oxidized by the methanotrophic communities, which is enhanced by the aeration, probiotic application, as well as the pond management practices. Thus, acting as a sink for the methane generated within the system when it is being compared with the methane generation happening in the wetland regions in the nearby ecosystems. Due to the global of the methane, it is highly significant to have more insightful research. Thank you.
That is by Pramit Kumar, Quality Controls.
Hello.
Hello.
Hello, everyone. Can you hear me?
Yes.
Yeah. So today I'll be talking on the mangroves, which are very important, located at the juncture of air, sea, and ecosystems, and their ecohydrology over the Indian Ocean region and adjoining region. So basically, we have a flux tower of 10-meter height surrounding a mangrove of 3-meter canopy. And you can see the mangrove components in this paper or in this I have listed out here. So the main point is the transpiration of this mangrove that is primarily driven by the salinity. And as the ocean basin will get more saline, the transpiration will decrease, which will also decrease the carbon sequestration because both are controlled by the stomatal conductance mechanism. And although another very interesting finding is, although the mangrove is almost submerged throughout the year, but then their sensible and latent heat flux, they vary quite a lot, like a semi-arid ecosystem and a wetland ecosystem. So sometimes the mangrove behave like a semi-arid ecosystem where their moist heat feedback is dominated by the sensible heat feedback because of their the higher cost they pay due to getting exposed to the higher radiation and higher salinity zones. And
time is over. So we are going to the next slide. Next presentation. Dr. Mili.
Yes.
Yeah.
Am I audible?
Yeah.
Okay, good morning. I was looking for some metal concentration in my study, and this is related to adjacent to Bangladesh coast actually, as we do have lack of in situ data in the continental shelf of Northern Bay of Bengal. So I am trying to have a reference value of carbon, hydrogen, nitrogen, sulfur from surface sediment of continental shelf of Northern Bay of Bengal, and the result reveals for higher nitrogen concentration, and the result are in percent relative to dry wet, and then the range is for carbon and for hydrogen and for sulfur. Perhaps the higher nitrogen concentration it need to mean for higher productivity. However, one of my previous study reveals for lower productivity in from VGPM model, and it needs to further investigation that why there is higher nitrogen concentration in sediment also and in water also, but why this is less productive of Bay of Bengal. So this is my investigation here, and look for further study. Thank you.
Dr. Mili, and we are going to the next presenter. That is Dr. Amit Sarkar, Gulf of Opportunities, Marandino sees in the ocean.
Very good morning to all. I think I'm audible.
Yes, you're audible. Yeah.
I took the privilege to introduce the least explored marginal seas of Indian Ocean. It's the Persian Gulf to the SOLAS Indian Ocean fraternity. So the Gulf is extremely shallow water body, it has a negative water balance, and you cannot ignore its influence on the Northern Indian Ocean biogeochemistry. And I'm actually fascinated by the availability of nitrous oxide and the nitrite in the water column all through the year. And since it's very shallow, you cannot ignore its the sedimentary contribution. So I've been carrying out some experiments with the sediment, and we found that nitrification gives a huge role to the N2O and nitrite abundance. And I'm expecting a project next year. It's on the radiatory gases like CO2, N2, and methane. And I call for collaboration to the SOLAS scientists who are interested in the Indian.
Thank you, Dr. Amit.
Yeah. Sorry, I'm having a little bit of IT problems here. Can you see the screen?
I cannot see my poster.
Yeah, I know. I'm having a bit of an IT problem. Jesse, can you pull up the PDF on your screen? maybe I'll stop sharing and start again.
Mm-hmm.
Yeah.
Okay. No, I think I'm having
I think I am able to convey my message, and who are interested to do more research in the Persian Gulf can reach to me. There is email ID and the phone number in my poster.
Okay.
So we can discuss more. Yeah.
Thank you.
Okay, what I'm going to do, Dr. Kumar, what I'm going to do is I'm going to pull them up directly from the SOLAS website.
Okay,
and
fine.
I also wanted to let everyone know, can you see this? That all the posters are presented on the SOLAS Indian Ocean meeting website, along with a Google Doc, where you can leave questions for the presenters. The posters will be up for a whole week, so you can look at them at your leisure. And the presenters can look at your questions and answer them in the Google Doc. So I'll just go on to the next.
Yeah, Pamarthi Amarendra.
Okay.
Pamarthi, yeah. Yeah, Dr. Pamarthi Amarendra.
Okay. So I'll go on to the next one then. The
next
last
one is by the Cliver in the Indian Ocean by Jing Li.
Okay, hello everyone. This is Jingli from the International Clever Project Office, and thanks for SOLAS to invite us to this SOLAS Indian Ocean meeting. As you know, the Clever is one of the core projects of the World Climate Research Program focusing on the Earth interactions. Clever and the IOC Goods has established the Indian Ocean Region Panel, and the major responsibility of this panel is to oversight design and implementation of the Indian Ocean observing system. As you can see, and in this poster, that in the past 3 years, we review this Indos design, and we developed the roadmap for the Indos 2 for the next decade. And you can also check the poster for the highlighted climate research in the Indian Ocean. And we also identify the potential cooperation areas with SOLAS, particularly on the co-implementation of the Indos. And we would like to get a suggestion from SOLAS on the trace gas observations to be included in Indos. And the other areas for further cooperation we identified.
I think your time is over. Thanks so much. So, Jesse, are we giving the time for the presenters who could not make the presentation now?
Yes, I think that would be nice.
Okay, so we can go to Banerjee. Banerjee, are you ready? Banerjee?
I think he's gone.
Go to the next one, Suresh.
Mm-hmm.
Yeah. On behalf of Suresh, I'm Ashwini Kumar here. So I'm talking on behalf of Suresh, who is the first author of this poster.
Okay.
So this poster basically highlights the use of geochemical tracers, for example, radiogenic isotope, strontium, ruthenium, and then trace metal, rare earth, as well as the clay mineralogy. And we use these geochemical tools to identify the dust sources over the northeastern Arabian Sea during the southwest monsoon period. So basically, you can see that the result says that the dominant contribution is from the Arabian Peninsula. More than 80% is contributed from the Arabian Peninsula during the southwest monsoon, and there are partial contribution from Northeast Africa as well as the Thar Desert. So that's all about this poster.
Thank you so much. And one more is left, that is Dr. Cicely Guay, major impact of atmospheric ion. Dr. Cicely is ready.
I think she's not here.
Okay. I think now all presentations are over.
Yes,
and,
I think, again, can we encourage everyone to go and look at the posters on the SOLAS website and leave comments and questions for the presenters. And thank you to all the poster presenters.
Thank you so much for all presenters. Thank you.
Thank you, Dr. Anil Kumar and Pav. That was very well conducted. I'm glad that you managed to get the 21 posters through in time, which I thought was going to be a bit of a worry. Thank you so much for your help with this. And now we come to the close of our afternoon session. But before that, I'll just thank Hermann Bange also, because he did a wonderful job chairing the morning session itself. And of course, Dr. Anil Kumar and Pav for chairing the poster sessions. As they have mentioned, the posters are going to be available on the SOLAS website. The link is in the chat, and you can go and access them. And the document for asking questions will also be open for another week. So you can go over the next week and post your questions on the Google document, which has been shared. Or if not, we've also posted the email addresses of all the poster presenters in the chat window. So you should have all these details to get in touch with the respective authors and co-authors for their posters. Now we faced a bit of a technical issue. We were supposed to be having the SOLAS India organization meeting on another Zoom link. Unfortunately, we just found out that's not going to be possible. So we will continue the SOLAS India organization meeting on this very chat itself. So it will be available on Zoom and on YouTube also, as you are having a look at it right now. So nothing changes from your side itself. But before that, we will take a bit of a break. We are scheduled to start this meeting at 11:30 on Indian Standard Time, of course. So please keep this link with you. I will post this link once more in the chat window. So in case you want to go stretch your legs, you can always come back and join it over here if you're interested in the SOLAS India meeting. If you do not want to look at the SOLAS India organization meeting, which is focused on the Indian community itself, then we start again in the afternoon at 2 o'clock Indian Standard Time again. And the afternoon sessions will again include a similar format to the morning sessions itself. So either see you at 11:30 or at 2 p.m. Indian Standard Time. Thank you.
Thank you. Thank you.
Hi, Yoav.
Hi.
How you doing, buddy?
Good. How are you? Wait, don't
I'm
see.
doing okay.
Hey, long time, huh?
I know.
How is Corona for you?
Well, you know, in many ways, our lifestyle's suited to this situation. you know, it's like we don't really go anywhere anyway.
Oh.
And, you know, not getting on airplanes, I'm getting lots of work done.
Yeah, wait, for you it's a big advantage, yeah? Having all these online meetings.
Yeah, yeah. But I do miss sitting in bars and coffee shops in new cities.
Yeah. It will come back one day.
How are you guys doing?
Good, actually, very good. It's very obviously it's a challenging period and Israel is you know very bad in many senses handling the situation.
Yeah, that's what
as many other aspects in Israeli life. This is all these issues handled in a terrible way, and all many things. You know, it's an occasion for things come up that wouldn't come up or that are less profound in normal days. So it's tense. It's very tense. But you know, in our little corner,
in your little bubble.
Yeah, you know, we're again in what's the word in curfew now.
Are you in lockdown?
Lockdown, yeah. So it's so the kids are at home and they try to to study online, which doesn't for the little one. Uri, he's 6 years old, so it doesn't really, it's a lot of challenges and
yeah. No, my head technician has one kid who's 7 and then twins who are 3, and it's just impossible. He can't do anything. Just
no, so but we need to work. We need to. So it's but for us in the university, we are like, our jobs are not harmed, and everyone understands the situation. So the expectations are. I mean, it's a global thing. So yeah, I spent 6 weeks in curfew. Curfew is the word.
Lockdown is what we're calling it.
No, but myself, just that I wasn't allowed to meet anyone.
Oh, you were in isolation.
Isolation. Me and my kid.
In quarantine.
Quarantine, yes. So we were both, we had no symptoms, but we were both positively diagnosed. And at the time, so you should, in order to get out of the lockdowns, you were supposed to have 2 negative tests. Now they changed the rules. Now it's just time. So for 4 weeks I was with him by myself. Well, I don't know if everyone
with who?
With my kid, with Uri.
Oh.
And then hey Jessica.
Hi Yoav.
I think everyone is hearing us probably, right?
Yes.
So it's like an old friend meeting, but so anyway, so we're handling it. It's okay.
Oh, well, you're only the second person I know who's tested positive.
Oh no, here it's becoming likely. So chances are quite big that so I would say now from the whole population, so it's already 5%, I think, or diagnosed.
Wow. Yeah.
So it's
well, I live on an island and zombies can't swim, so.
And yeah, and with Jessica, I meet from time to time for the school issues. Right, Jessica?
Sorry, what did you say?
I say that with Lisa, I haven't met, I don't know, since a long time, but with you, we meet from time to time, with the school handling. Hi, Anoop, how are you?
Yeah, right.
Hi, how are you doing?
Good, good.
Yeah, I just heard that you were under lockdown and self-isolation.
Yeah, for 6 weeks.
Oh
So
my.
it was challenging, yeah.
But you're better now.
No symptoms. I mean, just
Excellent.
just positive test, but no symptoms.
Okay.
So
Well,
it was
that's
a bit,
really good news. Huh?
yeah.
At least you're fine health-wise.
Yeah,
And
and it
thanks a
was
lot for
good.
doing this. I'm looking forward to how you inspire us Indians to organize ourselves.
Yeah, it's a big challenge. I hope I mean, I try to think what to say. I hope it will.
Yeah.
I think, yeah, I don't know, some of our experience. I think, yeah, on the, yeah, I would share some experience. I think it will be good.
All right. Sounds good.
And the meeting seems working very well.
Yeah, so far at least the talks have been pretty interesting.
Yeah.
I think it's been going fairly smoothly also. The poster session, a few hiccups, but that was expected, right? With lots of people speaking. But thankfully, they're all offline. So hopefully people can still go and comment and discuss after the meeting itself. So no, I think so far so good.
Real telling part is whether people actually do go in and look at the posters and comment on the Google Doc, and if conversation develops there. That's the question. I hope it does.
Yeah. Yeah, it's challenging. This is, for me, it's the first online. I mean, the first conference since March. I mean, this kind of conference. So it's a challenge. It's nice. It seems to be working. I mean.
Yeah, no, it seems to be going okay. I have to admit, we've been doing lots of meetings online, but
of course.
Yeah, it's a bit different. But no, it's working so far.
Yeah. And how is Corona in India?
Oh, it's here.
It's here, huh? It's here to stay, I think.
Yeah, unfortunately, we've got fairly high numbers, but people are recovering. Yeah, with the population size, it's very hard to control either which way. And they tried doing that with a very strict lockdown, but then of course the economy just tanked.
Yeah.
So
Same
yeah, it's between it's you choose what is worse. It's the lesser of two evils. I don't think there's a right answer either which way.
Yes, and probably in remote villages and things like that, probably you don't even know the numbers, right? I mean, in remote areas and rural areas.
Yeah, honestly, I mean, the government has said officially that it doesn't have a very good hold on, how people have traveled, how many people have moved from the urban areas to rural areas and back. So yeah, I agree. I don't think we really know what's happening, which is the worrying part. It's the known unknowns and known knowns.
It's better not to know, maybe.
Yeah. Unfortunately, as scientists, we always want to know.
Sure. Yeah. Well, it's a Well, anyway, so it's the same everywhere, I guess.
Yeah.
Anyway, let me just make sure that my presentation is tight.
Sure.
We start in a few minutes, right? What time is it?
Yeah, in 7 minutes.
Okay. So let me just. So I'm muting. I just want to verify that everything is okay.
All right. Hello, everyone. I think we are pretty much on time now, 11:30. So we will start off. Jesse, is that okay if we start off?
Yes, sounds good.
Okay, excellent. I see we have quite a few participants over here. So hopefully we'll keep the same rules as before, which is if you're not speaking or you haven't been asked to speak, please mute your microphones. And well, now I want this to be a little more interactive. But before we start the interactive part of the session, we have a couple of talks. So during those talks, try and keep your videos off. But when we come to the last bit, it would be nice if you have your videos on while you're talking itself. So hopefully we will not run into any more trouble in terms of the logistics part of it. All right, so let me start off with why are we holding this meeting? So India has been involved in SOLAS activities for a very long time, actually. Especially in the past, organizations such as NIO or PRL, especially, these two were doing a lot of work in the SOLAS domain. But over the last few years, that has reduced in terms of direct active participation. There is still a lot of scientific research happening in the SOLAS domain, but we are not really connected to the international community through the same umbrella as the rest of the SOLAS community. So the idea is to try and rekindle this community and also try and make sure that it is sustainable into the future by forming a community which has a proper structure rather than led by just one or two people. So that structure keeps on evolving and growing in the future itself. So the aim of this meeting is to try and think about what is the kind of structure that would work and what are the kind of scientific goals that we should aim at as the SOLAS India community itself. For doing this, we need not repeat the same mistakes as other communities have faced in the past, so we can learn from their mistakes. That's one of the reasons why we have a couple of people from international communities to come and talk to us about what worked, what did not work. So hopefully through this afternoon session, we can at least get a good idea of what we should be doing, what we shouldn't be doing, and what we should be aiming at doing in terms of the science also. So to start off the afternoon session, the first speaker is Lisa Miller. You've already heard from her in the morning, so I won't give a very long introduction. But I want to tell you why we thought about inviting her for this afternoon session, the SOLAS India session. First of all, she is currently the chair of the SOLAS Scientific Steering Committee. So she has a very good hold on what should be done, what should not be done within SOLAS. So, she's the right person to talk about what we should be aiming for as the Indian community itself. She's also seen significant growth in the SOLAS community over her chair, which bodes well because she knows what works, what doesn't work in terms of around the world itself. So right now she's going to give like a brief introduction on SOLAS itself and briefly talk about why we do need a national community and what role we should be playing in terms of our national representation also. Lisa, please go for it.
Okay, so let's try this screen sharing again. PowerPoint. Slideshow. How's that?
Not yet.
Can you? Not yet? Is it coming?
No.
No? Huh. And I don't seem to have the option of unsharing. Let's see here. Ah, there we go. Have to actually hit the share button. That helps. How's that? Do you see my do you see my notes or do you see the slides?
We see the notes.
Ah! Someday I will learn to do this, I promise. Still my notes.
Oh, that's okay now.
That's good? Okay, okay. Excellent. Very good. Okay, so this morning I gave you folks a very brief introduction to SOLAS. And now I want to go into a bit more detail to help you all understand exactly what SOLAS is and what we do, so that you can, as the Indian community, can more effectively brainstorm about how you want to contribute as a group to SOLAS. So SOLAS is, come on, we can do this. There we go. So SOLAS is an international, non-governmental, non-profit organization that, as I said earlier this morning, is dedicated to quantifying key biogeochemical physical interactions between the ocean and atmosphere, and understanding how those interactions are affected by and affect climate and global change. Now, how we actually do this is SOLAS is run by an international project office under Jessica Geer, who's the executive director. She's based at the GEOMAR Center for Ocean Research in Kiel in Germany, along with project officer Esther Rickert, who is online, I believe, somewhere taking notes. And then we also have the International Project Office has a nodal office based at Xiamen University, which is run by Project Officer Lee, who is also online today helping us out. And the IPO, the project office, takes care of the nuts and bolts of the organization. They take care of all the communications. They manage the budget. They take care of logistics. They've done a lot of the organization for this meeting. If we were meeting in person, they would have booked hotel rooms and flights for keynote speakers, things like that. The science is managed by the Scientific Steering Committee. And these folks over here, and and we've got a diverse international group, but I want to point out Anup is on the committee, and he is the leader of our integrated topic on the Indian Ocean, and Parv, who was one of the moderators of the poster session, is also a member of that group. SOLAS is sponsored by 4 larger scientific organizations: SCORE, the Scientific Committee for Oceanic Research, the International Commission for Atmospheric Chemistry and Global Pollution, the World Climate Research Program, and Future Earth. And so that's our basic structure. The actual science, of course, is done by all of the SOLAS community scientists around the world. And we're up, it's more than 2,000 people. And many of those people are organized into national networks. And this is why we're here today. All of these all of the blue dots represent national networks. There are more than 30 of them. And they're all self-organized, and their structures really vary depending on national circumstances, resources, and cultures. And as I said, this is why we're here today, to try and brainstorm ways to try and reinvigorate the Indian national community, which has been there for a long time, but has been a bit disengaged from the rest of the SOLAS community. And we'd like to see that change. So now I want to talk some more about the science. I showed this figure this morning, but went through it pretty quickly. So now I want to go into a bit more detail on each of these, so you can see where each of you hopefully can fit. First core theme is greenhouse gases. And this is about all the things happening in the ocean that control atmospheric greenhouse gas concentrations. And it's not just carbon dioxide, but also nitrous oxide, methane, and other greenhouse gases. Next, we have the air-sea interface and fluxes of mass and energy. this is really the heart of SOLAS in my mind. This is the physics and chemistry of the interface and the boundary layers, and all of the uncertainty and weirdness that happens there. Third, we have atmospheric deposition and ocean biogeochemistry. This is, and this is about how the deposition, not just of pollutants, but also of nutrients, impact surface ocean ecosystems and biogeochemistry. And as we heard during the posters and during some of the talks this morning, that line between pollutants and nutrients can actually be pretty fuzzy, and is mainly a matter of degree. Next, we have the interconnections between aerosols, clouds, and marine systems. And this is about the production of marine aerosols and cloud formation. This is heterogeneous phase atmospheric chemistry and how the ocean contributes to that. And it's also two-way feedbacks, how then cloud formation impacts surface ocean ecosystems. This is the home of the claw hypothesis and the DMS story, but it also involves organics and sea salts. And then finally, the last of the core themes is ocean biogeochemistry, chemical controls on atmospheric chemistry. Although aerosols are part of this, this is mainly about gas phase chemistry, ozone halogens, oxidation and atmospheric oxidizing and cleansing capacity. Now, of course, none of these themes are independent. All are intimately linked and interconnected. Only very specific laboratory or numerical experiments might address only one theme. And we've identified a number of what we call cross-cutting themes that integrate all of these core themes. We have several integrated topics on specific types of high-sensitivity systems, including upwelling systems and the polar oceans. And now we're spinning up an Indian Ocean integrated topic, which is what this workshop we're having today is about. We also have a cross-cutting theme on geoengineering, and I'm going to talk a little bit more about that. And we have a program on science and society that is doing a lot of work on the impacts of ship plume emissions on ocean biogeochemistry. Most ship plume work has been focused on how shipping impacts the atmosphere, but we're trying to look at how that impacts the surface ocean. And we also have some initiatives on blue carbon and open ocean stewardship. Another way we do much of our work is through formalized. Okay, so one of the ways we do a lot of this work is through formalized international activities. And the main ones are listed here. We have a couple of working groups on carbon. The SOLAS India Ocean Acidification Working Group is actually the scientific advisory committee for the Ocean Acidification International Coordination Center in Monaco. And we have a new initiative spinning up with a number of sister organizations on integrated ocean carbon research, trying to look at the entire carbon cycle in the ocean. Much of our polar work is executed through two working groups. First, the biogeochemical exchange processes at sea ice interfaces, BEPC, looks at sea ice, by the chemistry and biology of the sea ice and how that impacts both the atmosphere and the underlying water. And then CATCH, the Cryosphere and Atmospheric Chemistry Program, looks at all forms of the cryosphere, not just and how it impacts atmospheric chemistry, not just sea ice, but also snow, permafrost, glaciers, and ice clouds. Finally, SOLAS is a co-sponsor of the Global Oxygen Network, which studies ocean deoxygenation and both its causes and its impacts. So I just want to now talk about a few of our less formal initiatives that are spinning up and a bit less mature. One is on remote sensing. And one of the things we came to realize is ocean scientists using remote sensing consider the atmosphere an interferent. And they put a lot of effort into identifying the atmospheric signals and subtracting it out in order to study the ocean. And conversely, a lot of atmospheric scientists find the signal from the ocean to be troublesome. Sun glint and reflection from the surface water messes up their atmospheric signal. So they throw out the ocean signal. And we realized that if we could get these people together and combine these data sets, these signals that they're throwing out, they might actually be able to tell us something about interactions between the ocean and the atmosphere. And we have very strong relationship and collaborations with both the European Science Agency and NASA in the United States, but we have not been able to develop very strong relationships with any of the Asian space agencies. And this is something we'd really like to change and try to build that, build more interactions there. And I promised you I'd talk a little bit more about geoengineering as well. In 2018, SOLAS issued a position statement on geoengineering, which I've reproduced here. But what it says essentially is that faced with climate change, there's going to be more and more pressure to implement some sort of technological interventions to mitigate climate change. So, and the scientific community has a responsibility to study geoengineering proposals, to determine one, can they be effective, and two, to identify possible unintended consequences. And right now, SOLAS is working with the WCRP to build a scientific, collaborative, and governance body that will facilitate research into geoengineering and into evaluating geoengineering proposals, and also to guide input from the scientific community to policy decisions. Another valuable way that SOLAS facilitates international collaboration is through project endorsement. When we endorse a project, it helps us to disseminate the information about the project and its activities and its results throughout the rest of the community. And it also helps us facilitate links between projects. We'll realize you're working on this and we know about these other people over there who are working on something similar but different. You guys should be talking to each other. And so we encourage you to request SOLAS endorsement of your projects. And we have two different categories of endorsements. One for projects, and they need to already be funded and addressing questions that are represented in the science plan. And as you've seen, the science plan is a big boat. We can carry a lot of people. And the other category we have is time series stations and observatories that are integrating atmospheric and ocean observations and running both of them. And we also want for there to be an intent to share data. Now we understand that depending on where you are and the country, sometimes you're not allowed to share your data, particularly in coastal stations in some countries. There are national security limitations. And we won't deny you sponsorship simply because you're not allowed to share the data. But what we're looking for is people with a will to work with other people, other observatories, and contribute to an a global network of these time series stations. And you can apply for project endorsement on the website. And another thing is if you're writing a proposal, we only endorse funded projects and operating time series stations. But if you're writing a proposal for a new project or trying to upgrade your time series and trying to raise some money, ask us for a support letter. We're happy to write letters that can go into your proposal saying, SOLAS thinks this is important. And sometimes that actually even helps. So I'm just going to wrap up here with a few of our upcoming events to encourage you to, because this event's been so much fun, right? I know you're going to want to do others. The big one is the applications are currently open for the next SOLAS summer school. I think it's either the 7th or the 8th. There are quite a few people logged in, I know, who are alumni of the summer school, Anoop among them. And it's a really powerful career development activity. It's people really benefit from it, and it makes a big difference to their careers. Applications are now open. Need to apply before the 6th of November. Now, this is scheduled for Cape Verde next June, and it is not clear whether the COVID-19 situation will allow it to actually occur. And so there is a contingency plan in place, and it may be delayed. However, they're taking applications anyway and are going to select students, and students selected now will be retained if the school is delayed. There are a number of other upcoming activities. Some of them will definitely be virtual. We're hoping some of the later ones can actually be in person. And I want to point out in particular 2022, the next SOLAS Open Science Conference is going to be in Cape Town, South Africa. And with that, I think I've pretty much filled up all my time. I just want to encourage you, if you have not already joined the SOLAS mailing list, please do so and get involved with our activities. And so if there are any questions at this point, or Anoop, should we just go on?
Yes, I think we'll have time for discussion later. I think right now it's better to just speed through this so that we leave as much time as possible for discussion later. I'll move on to the next talk. So Lisa, thanks a lot. That was a really good platform, let's say, to build on this for the session especially. So now we understand what SOLAS does and what SOLAS can do and what we can do for SOLAS. And obviously, it's going to work differently for every country. We are very sensitive to that. However, it's always useful to start looking at countries where things are working well. And in this case, Israel is doing very well from what I hear in terms of the SOLAS community. So you have not been introduced, so I'll just do a quick introduction for you. So Yoav Lehan, he is an oceanographer and he works at the School of Marine Sciences in the University of Haifa in Israel. He works on the investigation of marine systems at the interface between scientific disciplines. That's what his bio says. Now, this is very interesting because according to me, he works on everything. He does theoretical studies, he does in situ measurements, he does remote sensing with satellites and drones. Anything you want to do, Yoav has his hands and feet into it. But that's why he's a really good person to talk about how to form a community, because he's heavily involved in the Israel SOLAS community. So Yoav, it's yours now.
Okay, so I'm sharing the screen, right?
Yes, please.
Okay, so just a second, let me... just a second. Okay, so hi Anoop, hi everyone. Thanks a lot for organizing this beautiful conference and this very stimulating meeting. It's been very interesting, and I think SOLAS has many advantages, and it's a very it's a great opportunity to share some of the experience we have. And I think Lisa sets the stage to my talk in the sense that she mentioned that she emphasized how the interdisciplinary SOLAS is. And I think it's part of the strengths, but also of the difficulties with establishing a SOLAS national community, or the SOLAS community in general, comes from this very interdisciplinary nature of SOLAS as an organization. As I say, I'm not sure that we are the best example, and of course, but I will give some I will show some good sides and some bad sides in the way I see SOLAS in Israel. But of course, as Anup said, there are very dramatic changes or differences between Israel and India, and I will go over them shortly. So this is in a sense the SOLAS community, or a major part of the SOLAS community in Israel. And SOLAS Israel as a national network, as a national community, was established in 2014. It was a satellite event of the Scientific Steering Committee, SOLAS Scientific Steering Committee, which some of you have participated. And it consists of researchers from about 10 universities and research institutes, and all these people that you see here come from a large variety of disciplines, which is, as I said, this is the way I see it, this is the core, or one of the cores of SOLAS. We also use a variety of scientific approaches, including field campaign, remote sensing, lab experiments, modeling, etc. So I think one of the things that can be that are highlighted in SOLAS Israel is indeed the interdisciplinary and close. We have a very strong orientation toward interdisciplinary and close platform research. Again, because there are so many people with so many different expertise and different interests that are involved. And obviously, much, but not all of the investigation is focused on our backyard. So our backyard, this is Israel, and our backyard in the SOLAS sense is the Mediterranean Sea. And Anup, do you see the screen? Is it?
Yes, we can see it clearly.
Okay, so we have the Mediterranean and the Red Sea, and very importantly, we have many deserts surrounding us. If we zoom in on our region, we focus much of the work of, I would say, local work is focused on the Eastern Mediterranean and the Gulf of Eilat and Gulf of Aqaba, which are part of the Red Sea. As you can see in this big picture, we are located in a transition zone between the desert and the mid-latitude climate, and this makes our system very vulnerable to both terrestrial, but in our sense, in this context, the marine system, very vulnerable to climate changes. We have desertification is very present. It has an important signature. So all the systems here, both in the Eastern Mediterranean and the Red Sea, are very fragile and are very susceptible to climate changes. So in a sense, we consider these two regions, these two seas, or these two areas, as good laboratories for different climate change or environmental change scenarios. Now, also the distances, as I said, there are strong differences with respect to India. So we are very small. The area, both the Israel and the areas that we cover is very small, and it covers quite a lot of variability over small distances. So it's quite easily we can sample regions with strong variabilities. So what the bottom line is that the systems that we investigate are very accessible. So it's quite easy to extract, or relatively easy to go to sea and to sample quite frequently, not only in coastal regions but also in open sea regions. Now, as I said, the SOLAS community research is highly interdisciplinary. It's highly disciplinary. So I will give very quickly just very small examples, but it's just a few numbers from quite a lot of research that, of course, is being conducted. And I want to draw your attention to this plume of dust that comes here from probably the Sahara, covering the Eastern Mediterranean. And I highlight this because much of SOLAS Israel study is associated with the impact of dust on the marine systems. And I will show one example from the work of Rahab and his group in the Israel Institute of Oceanography. And these are sampling stations, dust or aerosol sampling stations. As you can see, it's near the sea. And here you can see an example to a severe dust event that was sampled. And as you know, dust has many impacts or can have many impact on marine systems. But they investigated the research that I will show here that was recently published is I would say the negative effect of dust on the marine ecosystem, and we see that. Basically, the bottom line is that addition of dust to sampled water resulted in this dramatic, very significant increase in the amount of Prochlorococcus or small phytoplanktons inhabiting the Eastern Mediterranean Sea. And you see here on the left-hand side, we see different the amount of cells after additioning dust, and you see that the yellow shows a high amount of dust, and you see that it influences dramatically the number of cells. Interestingly, when they did the same experiment, but after killing all the organisms in the dust, the effect, so this is what we see here, the effect on the phytoplankton community was much lower. So this brought, based on this, so the message here is that what kills the phytoplankton are organisms that are found on the dust, and in this sense, it is attributed to viruses that attack the cells. So this is one study. So as I said, much of the research is focused on our backyard, so Red Sea and Mediterranean Sea. But of course, we have a lot of international collaborations and work worldwide. And I think one of the most remarkable example for this is our participation, or people from SOLAS Israel participating in the Tara expedition. And what they did, it's a group mainly from Weizmann Institute. And what they did is they added a component of aerosol measurements on board the Tara, which is the boat that you see here. And to those of you who don't know, it is a boat it's a sailing boat, as you can see, that travels all over the world, all over the oceans, collecting various biological, physical, and chemical measurements at fixed, at relatively high spatial frequency. So, and they added an aerosol component to these measurements, and so I will not go to the results, of course, but this allows giving a very nice and broad perspective on the aerosol population worldwide along the Tara's track. So this is another thing. And last thing I would say, also not on the local level, but more on a large level, and this is a paper in which I'm involved, and the idea is to, again, we understand, and Lisa said it shortly, there is a lot of data out there, and there is, and much of it is available and made available by the researchers, and we identify a need for integrating all this data in a simple and automatic way. And we're now part of a large effort aimed at facilitating this data integration using state-of-the-art machine learning techniques. So this is a very, just very few examples from the work that is done. And I will summarize, and I think this would be useful for the discussion. So on the bright side, we have a very viable community, which is mainly characterized by a strong interdisciplinary and inter-institutional collaboration, working directly on SOLAS-related topics. I will not go on the list, but this is made possible because of by very I would say very close collaboration between people from different disciplines. And I think this is the key word. Finding the common language between disciplines, this is a big challenge. So this is on the bright side. There are some negative sides, and this is why I'm not sure that I'm the best example. And these are the things that, in a sense, although we exist for a few years, we haven't still been able to do a few things, and there is still we're still lacking a sense of a SOLAS community. So we have ad hoc collaborations, but not as part of a community. This SOLAS Israel is not sufficiently well structured. Many of the people that I showed at the beginning of the talk, they don't even know that they are part of SOLAS Israel. They do SOLAS related activities, but they don't know. If you ask them, yeah, I saw your picture in the SOLAS, and say, what is SOLAS? I'm not sure. And this is this is something that we need to work on. And again, I will be happy to exchange ideas on how to do it. And also, and this goes back to the end of Lisa's talk, we're not using the advantages of having SOLAS as a backup or as a sponsor for, not financially sponsor, but a sponsor for projects. So I think in this sense, many of the challenges that we're standing upon, we share the same challenges. So it would be nice to continue exchanging ideas on this. So thank you. I think this is it more or less.
Wonderful. Thank you so much. There was some really good information, very useful, especially that last slide where you note about what works, what is not working, because we want to avoid making the same pitfalls and make sure that it's a very active community. Before we start discussing about how to structure the SOLAS India community, maybe it's a good idea to have a look back at what all science has happened from India in the SOLAS field, even if it wasn't under the domain of SOLAS directly or not backed by SOLAS directly. For this, Cheryl Fernandez is going to be giving us a talk next. So Cheryl is also a SOLAS alumni. She's currently an assistant professor of marine sciences at the School of Earth, Ocean and Atmospheric Sciences at the Goa University. As I mentioned, she is an alumni of the 3rd International SOLAS Summer School. So indeed, she was in the same summer school that I went to. She's got her PhD in marine sciences from Goa University, and right now is focusing on assessing biogeochemical processes, mainly focused on the nitrogen cycle. And she's going to give us an overview of what's been happening in the Indian Ocean, and hopefully through that we can recognize what we can do in the future in the Indian Ocean itself. Cheryl, please go for it.
Thank you, Lanu. So going back to what activities have been done in the Indian Ocean under the SOLAS initiative. So so much of the scientific foundation for a modern understanding of the Indian Ocean has been provided by the International Indian Ocean Expedition. It was a monumental expedition conducted in the mid-20th century, and an unprecedented number of hydrographic surveys were conducted covering the entire Indian Ocean basin, as you can see in the cruise tracks. And the program was launched by the Scientific Committee on Ocean Research, that's CORE, and the Intergovernmental Oceanographic Commission, that's IOC. And it embraced various disciplines like physical oceanography, chemical oceanography, marine biology, meteorology, marine geology, and also geophysics. So there were about 46 ships that participated from 14 different countries and collected hydrographic data from the Indian Ocean basin. So the major outcomes of this campaign was that there was an advancement in the understanding of monsoon variability and dynamics, and the complex surface ocean circulation emerging in response to monsoon forcing was also described. So the next major multidisciplinary campaign that occurred was in 1990s, and it was the Indo-X, which conducted various measurements, systematic measurements in the Arabian Sea and the Indian Ocean. So the objective of this program was to study the role of transport processes in modifying the distribution of various trace gases and aerosols over the Arabian Sea and the Indian Ocean. So the major outcomes that were noted were there were elevated levels of pollutants observed over the northern Indian Ocean. Then these air masses were later revealed to be transported by the Bay of Bengal from the continent. So elevated levels of sunlight absorbing aerosols that were found, and which were linked to fuel combustion and biomass burning. Then the aerosol layer extended up to 3 kilometers high. And the black carbon constituted almost 14% to the fine particle mass. So after the Indo-X, there were many more expeditions that happened, like the Bob-X and the Peso, and also a cruise on board the academic Boris Petro. So I'm going to share some findings from these particular campaigns during the Bob-X, which was done during the February to March 2001. The significant findings were they found high ozone and carbon monoxide levels over the Bay of Bengal, then over the Arabian Sea. And these were linked to the transport of polluted air masses from Northeast India and South Asia. So later, ozone and related trace gases were also measured in the marine boundary layer over the Bay of Bengal in 2002 campaigns. And Sahu et al., they published that the continental influence air masses dominated over the northern region. Then whereas cleaner air masses prevailed over the southern Bay of Bengal, the ozone, carbon monoxide, methane, and some NMHCs are also measured, which showed latitudinal gradients. So these data were much higher compared to those during the Indo-X cruises in the Arabian Sea and the Indian Ocean. And there was a higher gradient in methane concentration with latitude. Several other cruises were also conducted on board ORV Sagarakanya. So some of the findings from these cruises are that the surface level measurements of ozone, carbon monoxide, methane, light NMHCs were done, and again they found that there were significantly higher trace gases over the Bay of Bengal compared to previous reports, and there was long range transport of these pollutants from the continent. And there was latitudinal distribution of trace gases showing significant north-south trends. So the next expedition was the Peso. That's the pilot expedition to the Southern Ocean. In this, the Southern Ocean was shown to have relatively cleaner air, and there were smaller aerosol loadings in the south of the ITCZ, Intertropical Convergence Zone. And later NIO conducted several studies in the Bay of Bengal. And the biogeochemical cycling of carbon and nitrogen was carried out by Dr. Sugandhini Sardesai and her group. And what they found was by doing partial carbon dioxide and total carbon dioxide measurements, they did not find any strong upwelling happening in the Bay of Bengal region, but the eddy pumping of this carbon dioxide-rich subsurface water was responsible for the diffusion of the radioactive gas to the atmosphere due to high prevailing winds in that area. So they concluded that the Bay of Bengal is a source of carbon dioxide to the atmosphere. Another big campaign was the integrated campaign for aerosol gases and radiation budget. It was sponsored by the Geosphere Biosphere program of the Indian Space Research Organization, and it was conducted over the Arabian Sea, the Bay of Bengal, and the Northern Indian Ocean in 2006. So the objective of this program was to characterize the physicochemical properties and radiative effects of atmospheric aerosols and trace gases over the Indian landmass and the adjoining oceanic regions of the Arabian Sea, Northern Indian Ocean, and Bay of Bengal. So these studies included ground-based measurements, on-island stations were there, and there were extensive ship campaigns conducted on board ORV Sagar Kanya, and also flight-based measurements were carried out. So later, almost 5 decades later, IOC and SCORE, they worked to stimulate a new phase of coordinate international research in the Indian Ocean. And this began in 2015, wherein exclusive ship-based observations were replaced with new measurement technologies. And what they were, we'll see in the next slide. There were a broad suite of oceanographic and meteorological sensors that were employed. So Argo floats were deployed. There was deployment of the research mood array for African, Asian, Australian monsoon analysis and prediction. Then there was characterization of physical and biological oceanographic variability and the atmospheric forcing of the variability. And ocean modeling also was used to provide greater insights on ocean variability and biochemical cycling. So several other studies also were carried out to understand the biogeochemical physical interactions and feedback between the ocean and atmosphere. So some of the results I'm presenting here, this was a study done by Yadav et al., wherein they studied the influence of atmospheric dry deposition on inorganic nutrients on phytoplankton biomass in the Bay of Bengal. And what they found was that aerosols transport almost 52 to 89% of the inorganic nitrogen to the coastal waters. And about 65% of this coastal fraction of aerosols deposited close to the coast. And they collected seawater from the Bay of Bengal, coastal Bay of Bengal, and spiked it with dust-borne nutrients. And what they found out was atmospheric borne nutrients support almost 3 to 33% of the coastal primary production. We can see that another study by Yadav et al. In 2019 on the spatial and temporal variability in concentration and characteristics of aerosol, wherein they measured TSP, that's total suspended particles, and the PM10 and P2.5 fraction. So what they found was that the PM10 and PM2.5 were higher at Visakhapatnam, as you can see in the highlighted data. And at Goa, they compared it between two places. That's one on the east coast, that's off Visakhapatnam, and off Goa on the west coast. So at Goa, it was the PM10 originated mostly from mining of ferromanganese ore. So they also said that the increase in PM2.5 during the winter, monsoon, and spring in Visakhapatnam coincided with the decrease in the total suspended particles, and the topography and ambient meteorological conditions favored in this area. And why is it so? It's because the Visakhapatnam has a unique orography, like it's bowl shaped, and it's surrounded by hill ranges, and the atmospheric temperature inversion during winter limits the transport of particles, increasing particle residence time over the city. So there's less flushing of these pollutants. And lastly, they also said that sulfate dominated the aerosol composition at both Goa as well as Visakhapatnam. Ozone measurements were also carried out during various seasons, but what I'm presenting here is only restricted to the winter, just to make you understand that there was latitudinal variation in the concentration of ozone in the atmosphere. As you can see from Anup Mahajan's paper, the data which I've made bold, you can see there is a change in with latitude in the concentration of ozone. And these continental emissions are the main drivers for this concentration in the Indian Ocean. In the highlighted data also, you can make out the latitudinal gradation. This is an example from the Bay of Bengal, which was conducted during the Burbex and the Burbex cruises. So Mahajan et al. Have also studied the iodine chemistry over the northern and equatorial Indian Ocean, and as part of this second international Indian Ocean expedition, and they calculated fluxes for hypoiodous acid and molecular iodine, and they found it to be higher, closer to the Indian subcontinent. So the iodine oxide mixing ratios peaked in remote ocean environment, and atmospheric iodine oxide observed was above the detection limit in the remote ocean due to reaction of iodine oxide with nitrite. So they concluded that the outflow of nitrogen oxide species from the Indian subcontinent can buffer iodine chemistry to the formation of iodine nitrate, even though the estimated oceanic iodine fluxes are higher. So it prevents the catalysis of the ozone. So in the future,
sorry, Cheryl, 2 more minutes to go.
Yes, this last slide. So the future initiatives would be to track the constituent exchange among suspended aerosol particles and understanding the role of sea surface microlayer in air-sea exchange of reactive gases. Thank you.
Thanks a lot, Cheryl. That was a really nice overview of what all has been happening in the Indian Ocean. As much as is possible in 15 minutes, of course, because thankfully there have been a lot of cruises. But interestingly, I think this presentation also identifies gaps that we need to address. In fact, our next speaker, Hermann Bange, he is going to be talking a little bit more about this. Hermann has already been introduced in the first session, so I will not go into too many details. The only thing I would like to mention is that Hermann has been extremely active in the IIOE2 cruises, and he's really one of the most active people from Europe working in the Indian Ocean. So he's the right person to talk about what we can do in the Indian Ocean region in the future. Hermann, yours. Hello, Hermann, I'm sorry, your mic is off. Do you mind?
Yeah, I'm just... Can you see my slides?
Yes, we can.
All right. Okay. All right. Yeah, thank you for this nice introduction. Maybe just a very brief, quick add-on to the previous talk. There was a JGOV's Arabian Sea flux studies, and there was a very huge contribution by India to this JGOV's flux study in the Arabian Sea, and all what we know about nitrous oxide and methane emissions and carbon dioxide distribution in the Arabian Sea mostly comes from this JGOV's activities in the 90s. Okay, now I'm going to talk about possible SOLAS contributions to future Indian Ocean. to future Indian Ocean region research programs. And I was very quick to say, yes, I can give this contribution. And the more I thought about this title and the more about, I was thinking about what you really want to hear from me, the more I was a bit afraid that this is a very tricky contribution, very tricky discussion. And to start with, I've chosen this picture. It shows a new sailing boat, which was reconstructed after the old plans for the old sailing boats crossing the Indian Ocean from the Arabian Peninsula, from East Africa to India and even further east, and of course going back. So, and I think it nicely shows that the Indian Ocean, because it's not that big ocean compared to the Atlantic or the Pacific Ocean, it's a rather small ocean, and it's all about connectivity. And if you listen to Lisa's introduction talk and to Johav's talk, it's all about connectivity, linking topics, linking people or bringing people together. So that is really well, let's say at the heart of SOLAS. So I think this picture is a nice indicator for this connectivity theme. Okay, so maybe a very general comments. Solar science, I really would like to go for a plea for a holistic approach. If wherever you're going to set up a SOLAS project or program or national committees or whatever, you need to, or you should do linking atmospheric sciences with ocean sciences and vice versa. And please do not forget to link it to the coast and the deep sea. And with deep sea, I mean everything below the surface layer. And I'm going to show you one very nice example. For example, when you look at the nitrous oxide emissions from the Arabian Sea or from the northern Indian Ocean, so Arabian Sea and Bay of Bengal, you really need to, of course, look for the SC gas exchange, but you also need to look for what kind of nitrogen compounds and how much nitrogen compounds are introduced into the Indian Ocean. That could be via the atmosphere, but also via the riverine input. So that's a really complex, let's say, story or very complex topic, and you need to connect all these different disciplines in order to figure out what's going on, to understand how nitrous oxide is produced and how much nitrous oxide is released, for example, to the atmosphere. The other 2 points I would like to mention, if you're doing solar science, you need to be interdisciplinary, think interdisciplinary, and you need to think about temporal and spatial scales. And what do I need with this, or what I would like to say with this is that the SOLAS domain is very broad, and actually this figure shows what Lisa has already shown in her nice figures about the solar science, but this is a kindly different approach. On the y-axis you find the temporal scales going from milliseconds or microseconds to 100 years, and on the x-axis you find a spatial scale going from sub-millimeter scale to 10 to the 4th kilometers. And when you look at all these circles in these figures, you see on the left corner, molecular processes, chemical reaction, enzymatic reaction, biochemical reactions, and it goes up to the upper right corner where you find climate change, El Nino effects, North Atlantic oscillation, and so on, basin scale variability, and all these processes are more or less covered by SOLAS science, as I see it. And in between, you find phytoplankton blooms, for example, or coastal upwelling, synoptic storms, and all these things. And it really shows that there's a really broad coverage of spatial and temporal scales, and that's the beauty, I think, and that's a challenge of SOLAS as well, to bring together people working on molecular genetics, biochemical reactions, or microbiology together with people linking the processes in the upper ocean or the lower atmosphere with climate change processes and ongoing climate change. Then the last point about this holistic approach is you need to think about societal relevance if it's possible. I mean, sometimes you have difficulties because we are doing mostly fundamental science or basic science, but of course, we also need to think about the consequences for societies and try to figure out what we can help to improve the societal conditions. And here are two recently published papers, which I like very much because it shows that solar science could be very easily connected to this societal relevance. For example, when you look at this figure which shows the title page of a publication which just recently was published in Scientific Reports, and it connects the interannual variability of the monsoon winds with the African small pelagic fisheries. And of course, the monsoon is driving the upwelling, is driving the nutrient enrichment in the surface layer, and then of course the biogeochemical cycles are driven by the nutrient input into the surface layer. And of course, if you go up the food web, you end up with the fisheries. And of course, fisheries is important for the people living at the coast because they depend on the fish supply. And when you look at the title page of the publication, which I've shown to the left, on the left side, it's more or less a similar story. It's understanding how physical, it's about understanding how physical biological coupling influences harmful algal blooms, low oxygen, and fish kills in the Sea of Oman and the Western Arabian Sea. And again, it's very nicely shows how all these physical processes in the atmosphere are connected to the biogeochemical processes in the upper ocean, and in the end, it leads to massive fish kills when you have the development of anoxia and hypoxia. And of course, this is very the influence affected very much the people living on the coast and depending on the fish. So that is what I mean with doing science and have a look and try to connect this to societal relevance. You may wonder if I'm going to tell you what to do. I'm really not, well, I'm not in a position to tell you what to do in the Indian Ocean, but I just listed here some selected key questions, and of course these suggestions are biased by my personal preferences, and I think these are key questions which should be tackled in the Indian Ocean. So I just very quickly go through these key questions. So what are the key interactions between the ocean and atmosphere in the context of the Australasian and African monsoon systems? That's clear. We really don't have a grip on this. We need to have more investigation on this. So what processes determine the natural variability of the biogeochemical cycles, ecosystems, and atmospheric chemistry of the Indian Ocean? That's clear. Maybe it's a tricky question because how do we know it's a natural variability? Because human beings are already influencing the whole Earth system to quite a bit. The third question is, what is the effect of the long-range transport of air pollution on ocean biogeochemistry, ecosystem, atmospheric chemistry, and climate? We heard a lot about this already during today's talks and in the posters. And last but not least, how are human-induced stressors, and with stressors I mean warming, eutrophication, acidification, and so on, impacting the biogeochemistry and ecosystem of the Indian Ocean? And of course, when you impact the biogeochemistry of the upper ocean, you also influence the composition of the lower atmosphere, because you have this exchange of trace gases and the input of aerosols and all these things across the ocean atmosphere interface. And in turn, of course, how in turn are these impacts affecting human population? I showed you two examples of how you can think along this line. And of course, I mean, these are 4 questions which crossed my mind when I was preparing this presentation, but of course there are many more, and these are the selection of this question is of course biased by my personal preferences. All right, so to continue, and I really think that the Indian Ocean is so small enough for a big effort. And what do I mean with this? And I have a vision. I would really like to see that if SOLAS could support or establish a pan-Indian ocean SOLAS project. That means we should join forces, develop a framework for coordinate and joint SOLAS campaigns. That means we should really join the forces, which mean join campaigns, join berths on ships and so on, just to have a very dedicated and very focused joint effort. I'm repeating myself here a little bit, across the whole Indian Ocean, and I really mean pan-Indian Ocean. I mean that we should look for Arabian Sea and Bange, but also go for the Southern Ocean. Sorry, not Southern Ocean, the Southern Indian Ocean, because I think there's a lot of work to do there as well. And last but not least, if such a pan-Indian Ocean SOLAS project is to be established or could be established, then it could be easily endorsed by the UN Decade of the Ocean, I guess, or by IOE2. And on the right side, I've put in the traditional pillars of these kind of projects. So you have the observation, of course, which could be done by ship, planes, satellite, any kind of robots, and so on. You have the modeling, can do climate modeling, of course, by geochemical modeling, ecology, coastal economic modeling, maybe. And then, of course, you have this pillar, or it's not a pillar here, it's a circle. The information, you need to, of course, make all the information you receive and you as a result you gain from such a project. You need to make this available to the public via data portals. Model scenarios should be set up, and training is an important point. I mean, if you really have a pan-Indian Ocean project, SOLAS project, then you should have also offer some training opportunities for young scientists, for PhD scientists, master students, and yeah, you can go for an assessment of the environmental condition of the Indian Ocean. All right, that's well, mostly everything I would like to say. I have one conclusion. I have a final slide. I just want to say thank you, and happy to take questions if we're allowed now to take questions. And yeah, thank you very much.
Thanks a lot, Hermann. And yes, let's open everything up now. So from now on, it's a discussion. I don't think we're going to have any more talks. We have a good hour to try and think about what all we're going to do. So as you said, maybe it's a good idea to have some questions first. So if anybody has questions, please feel free to either raise your hand and speak or type it into the chat window. Any one of the two is okay at this point. Okay, so before somebody else asks one, Hermann, one of the things I notice is there's a lot of work to be done, and what you spoke about in terms of joining efforts, that seems to be the key to answering most of these questions.
Yeah.
In terms of joining forces, how much has the IIOE2 program joined forces with the other programs which are going on? For example, the Indian Southern Ocean Expedition that has been going pretty much every year. Is there any synergy between the two? Is there any interaction between the two, or even other cruises such as the Sagar Kanya cruises, which keep happening in the Arabian Sea or Bay of Bengal?
Of course, we have collaboration with other programs. Within IOE2, we set up different regional programs. So there's, for example, a program for the Western Indian Ocean upwelling system, and there's one for the eastern side as well. We have tight connections to many other international programs. Yeah, I mean, we cannot spend money, so that's our main problem. I mean, we are a program. We have nice implementation plans and nice science plans, but we don't have any money to support projects. So to support scientific work, we can support some, I would say, some meetings and so on. But that's all. And what we do and is we endorse projects. So everybody who thinks this is an Indian Ocean project which should be endorsed by IO2 can come to us and we can endorse this project. And for example, when we have ship campaigns to be endorsed by IO2, then we request that several berths are kept free for other participants to join these cruises, for example. So these are the kind of collaboration we can offer as IO2, or we're really supporting. Maybe Peter can say more about this.
Yeah, thank you, Hermann. You know, I think in IOE2 we have a duty to help our colleagues. And one of the things that you said, and I completely agree with, is that the best science is done interdisciplinary. So this involves people working together. Often they work bringing their disciplines together, and often across different countries.
Yeah.
And one of the things that I just wonder is whether countries like Germany, and I would even offer the UK, could help other countries such as India. Help is kind of a prerogative term. I'm not quite sure whether that's right, but I think one of the successes, and I'm really delighted that Vinay is here because he's been instrumental in this, is the BOBBLE program in the Bay of Bengal, where he worked with people from the University of East Anglia, Adrian Matthews, for instance, who led up the Vinay, the program with Vinay. Whether having this multidisciplinary, multinational approach actually helps. Certainly I would hope that it would do, but maybe we should just ask Vinay, you know, if he feels that having involvement from other countries, other skills helps.
Yeah, Vinay Chandra, you had your hand up either which way. So do you want to answer that and continue?
Yeah, so I just wanted to add to the comments made by Hermann regarding our participation in the IOE2 program. So we had a reasonably good participation. Several projects have been endorsed in IOE2. So IOE2 provided an excellent platform to collaborate, exchange, interact with the international community involving several countries, like Peter had mentioned. Now, when we come to the specific program that we did with UK, so there is quite a bit of history that goes back to it regarding the research related to the air sea interaction and monsoons that we have been doing in India. There was a science plan written several years ago looking at the major problems that is concerned related to the interaction between the oceans around us and the monsoons. So several programs have spun off from that science plan and a follow-up of implementation plan. Several programs had been done. We had a Bay of Bengal monsoon experiment. We had an Arabian Sea monsoon experiment. We had a continental tropical convergence zone experiment, and so on. So it was the right time when the opportunity came with collaborating with the University of East Anglia to do this part of this research. So the university brought a whole lot of expertise and experience in terms of glider operations into this program. So when the opportunity came, we already had a science plan. We already had an implementation hand ready. And from this, the proposal could be readily written, which could be readily accepted by both NERC and Ministry of Earth Sciences. Now, when I try to put that in perspective with SOLAS, one may consider a similar approach to be useful. I'm saying this because if you look at the several pieces of the SOLAS research, a lot of research is already happening. There is ocean observations going on, and there is ocean modeling. There's quite a bit of biogeochemistry modeling going on in India. There are these bio-argo floats. There is ozone research. There is air-sea exchange of gases research. All of them is going on. So certain amount of coordination would definitely help to bring focus to this program. So one one approach, as also Hermann had suggested, is to come up with an excellent science plan focusing on the national interest, and also ways to link that with international programs and large-scale and global issues, because the science can never be completely dealt with regional approaches alone. And then that science plan should be followed by an international and implementation plan, with which we should be able to approach funding agencies readily, saying that yes, we have the science questions, we have the science objectives, we have the science programs, and these are the links happening, and these are the issues that we would try to address, and this is how we would like to link with the international community. We have this implementation plan, and we would like to have a plan where we would like to have a certain amount of grants allocated, so that individuals can apply for proposals, and that can be authenticated by programs like IOE2, SOLAS, and Ocean Decade, and so on. So I think that is my suggestion. So I also feel that the time is good, because the decade is going to be announced in January 2021, and IOE2 is maturing, and most probably there will be a second phase, and there are a lot of other things happening as well. So that's what I would like to see the way ahead is.
Thank you. That's really useful in terms of thinking of what we should do. So I see there are a couple of questions mainly relating to observations and how we need a long-term sight and all. And I think this is a question which I also had, is I also feel that the time is now right to actually think about pushing for a long-term marine observation site in India. It could be on one of the Indian islands or such, but I think the time is right to start thinking about starting to create a continuous data series rather than focusing only on process level studies, which tend to happen on ships. So maybe along with the ship-based campaigns, also have a long-term site. The other question is about flux studies in the Southern Ocean. This needs international collaboration. I completely agree. How can we link IOE2 into this study? This is a question for Hermann. And before we get into that, I was hoping that this session would be less about the science itself, because we have an entire discussion session for the science, and more about how we are planning to structure SOLAS itself. So there were a couple of things that I was hoping we could talk about, and if it's okay with everyone, I'll just put up a slide so that we can start looking at it, and I would like everyone's opinions on this, of course. So I'm just going to share my screen, and let me know if you cannot see it, but I'm pretty sure you should be able to. Okay, sorry, let's go back to this. Okay, hopefully you can all see this, right? So the questions I had about the structure and future of SOLAS India. Now, this is the main reason we are having this meeting, is to get the community together. The first thing is we need to form the community. So there are a few things which we have to do. Obviously, we need to have a SOLAS India website, which will help people from within India talk to each other a little bit more. We need to select a national representative. For my suggestion was a 2-year term, but this is again open to discussion. Right now, Cheryl has done a wonderful job at putting things together and has already made way to this. So I was going to suggest her name, but again, this is a decision to be made by our community itself. And we need to start meeting a little more often, because even this meeting itself, we are starting to see there's a lot of questions which everybody has, and if we join our forces, we would be able to do a lot of work together, and much better work. So starting to plan SOLAS meetings, SOLAS India meetings once a year at least, and maybe since now we are getting used to online meetings, maybe once every 3 months, so that we start correcting our course as time goes by. We need to start preparing a SOLAS national report, which is usually compiled by the national representative. And it is a bit of a job, obviously, because as Professor Vinay also said, there's a lot of SOLAS work happening in India. The problem is it's just not coordinated very well. So this is a bit of a tough job. So we need to create a mechanism through which everybody who's working on SOLAS is aware that they can contribute to the national report, and that this national report will give them some recognition, which might lead to further funding. So we need a certain mechanism to make that happen. Maybe also it is a good time to write a review or a white paper on the current SOLAS efforts from India. As was rightly mentioned, there's a lot of work which has happened on SOLAS, but because it has been loosely coordinated, maybe it's time to put those things together so we know who all are heavily involved in the field and how we can make use of their resources best. Then, of course, collaboration with other existing programs, IIOE2, or the other cruisers, the Sagar cruisers, or Bobble, etc. I mean, there is a lot of nice work that has been going on and is going to continue. We need to make the most of it. We need to identify certain funding mechanisms. I know we already have our DST fundings, we have our MOES fundings, etc. But people tend to approach these individually as individual groups. But do we need a consortium of sorts for SOLAS research? That's something worth thinking about, at least, I think. And then, in addition to what the cruises that have been happening, maybe start planning a comprehensive campaign in terms of focusing or refocusing what has been going on, and plan a campaign which will try and address as many of the points as what Hermann brought up. And of course, we as a community need to make a decision about which science do we go for, because as that plot was showing, there's so much that SOLAS can do. It's a very broad field, but exactly what should we commit to and what should we focus on as a community is something we need to decide. So these were the kind of questions that I was hoping we could have discussions around for this round. Remember, the scientific discussions, we have time for that, and we have most of the panelists are actually in this meeting also, but we'll have a proper discussion on the science. But if you have any thoughts on what kind of work we can do around this, please talk up or put something in the chat.
Okay, Anup, so can I come in? This is Arvind.
Yes, Arvind, please go for it.
Okay, perfect. So just a few comments. So one of the things we do not realize that IIOE2 and SOLAS are already linked, because they both receive significant amount of funding from SCOR. So somehow they are anyway linked, so we know each other. And your structure looks quite good, the way you presented. But I'm thinking now not from the science point of view, but from the capacity building point of view. So what we know about SOLAS? I mean, when we hear this word SOLAS, the first thing comes to our mind is the SOLAS Summer School. And in SOLAS Summer School, the number of students that can participate would be limited to 2 to 3, or maybe it could go to 5. So not many would be able to, or they are not able to participate in this summer school. And we are like 1.2 billion people. Of course, the same fraction is not, I mean, in terms of the population, the same fraction in terms of ocean sciences won't be there. But still, if I can give you the numbers, since I'm heading this IIOE2 early career group, so it's of course international community, and we have around 100 registered participants in IIOE2 early career, and around probably 900 or 900 plus Facebook and Twitter followers. So that's a big number. And in this number, I found that 90% of the students or the postdocs, they come from India. So that's a big number. So how do we train these people? So my proposal is that something like the SOLAS Summer School, the International Summer School, we should have a regional summer school in India. It could be alternate year or every year. And this could easily be done because in terms of money, it won't be that expensive. And then we can invite the international researchers who belong to SOLAS or who teach in the International Summer School. They can come to India and teach, and then the participation from the students will also increase. So just one point I would like to increase, because that's what the SOLAS is known for. I mean, that's what comes first to our mind when we hear about SOLAS.
Thank you. That's fair enough. I think having some sort of capacity building is a good idea. Gayatri also has mentioned on the chat saying that having online meetings or lecture series might be another alternative to having a full-blown summer school, because that involves funding and that comes with its own problems. Katie has mentioned that the South African Antarctic research community wrote a white paper together a number of years ago highlighting the research priorities. It was published in the South African Journal of Science and has proved to be useful for putting together this research community on the map, and was very useful to refer to when writing proposals. I share this experience to support the idea of writing a white paper or review, which might be beneficial for the Indian SOLAS community. Yes, I completely agree with this. I think sometimes when you want to start off something or cause a spark, you need to know what the baseline is. And as we've been learning through all the talks through this session, there's so much work that has happened, and maybe writing a white paper or something would be a good idea. I'm obviously speaking from the view of what work I have been doing, but I know there are other people on this session from even NCPR or Professor Vinay Chandran and all, who have been a part of lots of different cruises as a part of different programs. Are there any comments you have in terms of what you can do? If not, Haimandi Biswas has a comment, so it's open. If you have a comment, please do.
Hi, Anup. This is very interesting, and I'm very happy that we get to know the overview, what is happening. And as Dr. Vinay Chandran mentioned, that a lot of activities are happening. The lack of coordination is something I think we need to address. And one more point is to identify people who are really involved in oceanography. I mean, the core SOLAS theme area. I think that is something we should do, not keeping anyone behind. And review is really needed to identify the ideal experts in this field would really help. And then to groom the next generation, the current existing PhD students who are working actively in this field, we need to train them so that they can contribute in future.
Right, I completely agree with those points. I think this is the way to go. Professor Vinay Chandran, you've been obviously involved in SOLAS activities much more than most of us here, in India, I mean. Are there any comments you want to give about how you see SOLAS being coordinated, or how we can structure it?
Yeah, so some of the excellent suggestions that you have made, I think would work well. You are going to have some sort of a network, and you would have a white paper, and probably you should also have these summer schools within India, national summer schools, where you would be able to bring participants, and those can be done in a way where you also combine workshops with summer school, so that you would also get to know what is all happening, and invite people to give talks and invite students to give their presentations and so on. So that would help you to have a better awareness of what all is happening in different places and different institutions in this country. The other thing is that if you wish to go along with expeditions, you should also look for announcement from JSTAC, where the cruises are organized. And often you may not be able to get a ship time exclusively for a SOLAS program, but quite a bit can be done joining with others. For example, the Bobble cruise, which we had, was completely interdisciplinary. We had physics, we had biology, we had chemistry, and we had optics, and we had a whole lot of other things and so on. So there are opportunities. So linking with those programs would help to generate more activity and create a larger database than you would otherwise have. Yeah.
That's a very good point. So these are some things we need to keep in mind when we start getting the structure together. Bhaskar, I think, I think everybody's on board in terms of saying that it needs to be multidisciplinary. Biology obviously plays a very big role in SOLAS activities. So we would definitely not be thinking about leaving it out. In fact, I think biology might be driving most of the work that we are planning to do in the future. At this point, Lisa, can I ask you to comment a little bit about what you've seen work in other countries in terms of the structure and what might be a good way to go around this, or if there are any additional points we need to consider in addition to what has been mentioned. Lisa? Okay, I don't think Lisa is available. Maybe Jesse, you might be a good person to talk about this.
I think I'm, yeah, I'm here, I'm back. Sorry, I couldn't find my cursor. So sorry,
Fine.
repeat the question.
So between you and Jesse, if you can talk about what you've seen work in different countries in terms of their national communities, what kind of a structure works, what kind of a structure doesn't work, that might help us think about, what to go ahead with and what not to go ahead with.
Yeah, what my observation has been is that what's key is having at least a couple people with the energy to really pull the community together, and the will and to continue thinking about how to bring the whole community together. It can be really difficult to make recommendations because different countries have such different resources, like but I can give an example. In the United States, the SOLAS community was actually a lot like India's in that there was a lot of research going on, but they weren't a community. They weren't coordinated. And we had a national representative and supposedly a national network, but we almost never got reports from them. And a few years ago, a young scientist stepped up to become the national representative. That was Rachel Stanley, and she managed to get sponsorship for the community through the Ocean Carbon and Biogeochemistry program. And so now there's community developing, but it takes some effort and some time. I was very interested to hear what Yoav said about the lack of sense of community in the Israeli community, because from what I've seen, they actually did seem to be pretty relatively coherent compared to some. The issue we have in Canada is there's a nice big mailing list. Our national representative is Mathilde Lizotte, another summer school alum who maintains a mailing list, and she tries to keep people together, but pretty much the only real connection is when she sends out the message asking us for contributions to the national report. However, 20 years ago, SOLAS actually had a fully funded SOLAS program that conducted, I think, 4 or 5 cruises over a period of 2 years. But then our research council wasn't willing to fund anything else called SOLAS. And so every now and then, though, we manage another project that brings much of the community together and brings new people together. So if you have a funding mechanism that can fund something like this idea you had of an observatory, a long-term observing site at one of the islands. If you could get something like that you could pull people around, that I think could be really helpful. A lot of things, some things work, some don't, and some things will work in some places and not in others. But those are a few ideas. Jesse, do you want to add anything?
Yeah, I just wanted to follow up on Arvind's suggestion about the summer school. Yeah, capacity building is definitely really important. And I saw that there was a lot of good capacity building and networking during the SOLAS Open Science Conference in Japan. So after that, the community in Japan really was pushing things forward. And I think that worked very well. So once you brought all the people together, and maybe not only during summer school, but maybe during an open science conference, and Anup and I already did some brainstorming about a conference in India, which would be great and would bring together the whole community and could also have some workshops for students on capacity building. And I think that would be also something good. And for South Africa, for the conference in 2022, we also plan some kind of hybrid events, so also stream things online that not all people have to go there. So I think to have such an inclusive event really helps, and this might be helping to push the Indian community.
Yes, Lisa, please go ahead.
Yeah, Jesse reminded me the Japanese community is actually really strong, and they were really strong before the Open Science Conference. And I think part of the reason for that is that they are able to actually have an annual meeting. They've got some funding from some national scientific funder that gives them the money to do that meeting.
Yeah, Professor Vinay Chandran, this is actually a very good point in terms of the likelihood of getting funding just for SOLAS activities. What do you think is the best mechanism? I mean, obviously MOES, DSTs, those are the big funders, but do you think there is another way which we can think about securing funding for SOLAS activities rather than the scientific activities on the SOLAS?
You said it, Anu, we have two major funding agencies. One of them is MOES and another is DST. So we can also try Ministry of Environment and Forests, which supports activities those are related to climate change. I also want to respond to a couple of comments made by Lisa and Jessica. So there are forums in India, which is fairly well coordinated. The Ocean Society of India has annual meetings every year, and that's a forum where a lot of youngsters and people meet. So SOLAS could formally liaise with them and borrow a session or a day or an extra day and have your activities coordinated with that. So that's a fairly active ocean part. And we also have TropMet for tropical meteorology, which I think happens once in every 2 years. This year it is going to happen in December. So that's another forum where most of the people who work on air-sea interaction and meteorology meet. And they have these themes every year. This year it is mountain meteorology. You could propose that one of the years you could have a theme related to meteorology and SOLAS activities and so on. So that would be good enough to send a message to the national communities and also to the funding agencies that there are pressing issues which need to be addressed, and we are active. So, and the other point I want to touch upon is the mention about the capacity building. We have the UNESCO Center for Training in Oceanography in Hyderabad, and it's very active, and they have been doing a lot of courses. So it's fairly straightforward to propose them that we want to have a training course. It can, as far as I know, it can be of different duration, starting from a week to a semester. And with the help, with the support from, like Peter had suggested, we could take support from expertise in SOLAS from everywhere in the world. We could have students from all over the world and have a well-organized capacity building and training program under the auspices of the IDCU Training Center in Hyderabad. Yeah.
Thank you. Those are two very, very good points. I have to admit, I love the idea of having a side meeting rather than just a SOLAS meeting, because that just brings a lot more people together without expending much more energy. So we will definitely get in touch with the Ocean Science Society, the Ocean Society of India. I think that is a really good idea. And I wasn't aware of this UNESCO training center, but I might chase you for a few more details about it afterwards and see if we can actually do what you're suggesting, in addition to, well, instead of having like a full summer school just for SOLAS, maybe coordinate it with them and get them to organize something for us. I think those are very, very good points to mention. Peter made a couple of points, and Peter, I agree. SOLAS India is for India to decide. We are just trying to brainstorm over here. I'm hoping that this is the first of many meetings in order to put a successful structure together, which I think is key. And I know a couple of high energy individuals can drive these things, but to make it sustainable for the future, we really need to have a structure in place so that even if those high energy individuals are not there anymore, the structure itself survives. And okay, I have a couple more comments in the chat window, which I'll bring up. Yes, so from YouTube, there's a comment about having a summer school is a great idea, but also think about students from other countries, not just from India itself. This is, well, I mean, then essentially we would be replicating the SOLAS summer school, which is not exactly what we are trying to do here. We are trying to get SOLAS India going, but I do understand that we need to have certain mechanisms for some students from elsewhere also to join in, especially if they are not able to attend the international SOLAS summer school. So we will keep that in mind when we are writing our notes down. Ashwini Kumar, he's saying that a review white paper on current activities with contribution from active researchers from India is a nice idea. I think so far, at least, I haven't heard or have anybody say that it's not a good idea to do. The question, of course, is who puts in the effort and time to do it, because writing a review like this is not an easy job for sure. So maybe once this meeting is done, we need to, if anybody is interested in contributing to this white paper and review, please get in touch with me. We'll try and get a good, efficient team together so that we do come up with something that is comprehensive rather than biased by one or two research interests. For example, if I write about SOLAS review, it was definitely going to be biased more towards atmospheric chemistry, which I would not want. Okay, there are a few more comments. Coordination between atmospheric scientists and oceanographers is limited over India. Yes, I completely agree, Neeraj. This is something that we need to change, and that's the main reason we are trying to have some structure being put into place so that the conversation improves. And maybe having SOLAS meetings, SOLAS India meetings, as a part of TropMet and a part of the Ocean Society of India meetings, alternate years, might be a good idea, because that way the people would be forced to talk to both atmospheric scientists and oceanographers itself. I think thinking only Indian students might be better. Yes, this is why we need a team, so we can come to a consensus and see how to develop this summer school idea. My experience, at least, and I'm sure Jesse, etc., will back this up, is organizing summer schools is never as easy as it sounds. It requires a lot of effort and a lot of time. So we need to have some system in place. Otherwise, it's going to come on a couple of individuals' shoulders, and that's not sustainable in the long run at all. So we need to come up with a proper structure for, even if we decide to go with a summer school. One of the things I would suggest is, I know lots of you have ideas, and I know today the time is limited. We have just 15 more minutes to go. We'll go through the comments and all. But if anybody is interested in following up on this and interested in creating this really active and dynamic community which looks into the future also, please get in touch with me, because we want to start having these conversations and start building this structure. And this will obviously not be an overnight effort, but as long as we have a good core team together, I'm pretty sure we can manage to do this. Jingli from Clivar has made a couple of points. To foster future collaboration in the Indian Ocean, some information may be shared. Going from global to regional and to link observation, modeling, prediction are also emphasized by WCRP and CLIBAR. So there are identical areas that we could cooperate on and jointly contribute to the UN Ocean Decade. Yes, I agree. Instead of expending energy reinventing the wheel, I think there are things we can help each other out with. CLIBAR and WCRP obviously have much broader goals than just the SE exchange part. But I'm sure we can plug into certain areas over there. So this is definitely a conversation worth having. Collaboration in the sustainable observations in the Indian Ocean, in particular on expansion of coastal and shelf slope regions and enhancement of biogeochemical measurements is necessary, I'm assuming. We are hoping we will also appreciate to have suggestion from SOLAS on the trace gas measurement in Indus. This is great. I mean, I'm sure SOLAS, the parent body itself, and from SOLAS India also, we would be very, very happy to talk a little bit more about what measurements need to happen in terms of trace gases to aid with the understanding of the SE exchange. We could also collaborate on capacity building on the WIO, yes, and we need to have cross-panel discussion. So yes, Jingli, I completely agree with all the points you have made. Is there anybody who has anything else to contribute to what Jingli has put up?
So Anup, I just have one observation I would like to highlight, maybe something for us to ponder. So a lot of scientists joined this ocean atmospheric chemistry or even atmospheric physics during the JAGOPS time. A lot of you know them, a lot of people are here and they know them. But many of these scientists moved to the solid land atmospheric chemistry. They left the ocean. So but I think that is because the JAGOPS got over. So if we had something like SOLAS or some other platform, these people probably could have continued, or more people could have joined the ocean atmospheric chemistry part. So we definitely need something like SOLAS for people to attract and to contribute to the ocean atmospheric part. I agree.
And that's the main reason why we are trying to get out a structure over here. And hopefully that's what we'll achieve. It's a bit of a challenge, but hopefully we'll do that. Okay, Hermann has said that a summary of overall SOLAS theme researchers is essential from India. Yes, that's why we're hoping we can put together an overview, a review. Lisa has made a very good point saying leadership succession is very important. And this is the main reason why I'm pressing on developing a structure, because even if there are 5-6 of us who really want to do this, and we will do this, it might not last into the future unless there is a proper structure in place. So even if it feels like, even if it feels like a more difficult job, I think it's worth putting in extra effort in the first couple of years to make sure that there is a proper structure in place. And after that, after the structure is there, then we can be more hopeful about it continuing into the future. Which is why in the slides which I was showing, I was talking about having a mechanism for the national representative to be chosen, having the national reports coming out every year, and the people compiling these change, and also create a mechanism through which all this information gets to whoever the national representative is. So the focus on this meeting is to think about how to develop the structure. Pramit is saying that the SOLAS community have any plan to study the blue carbon storage and dynamics in the Indian Ocean basin, especially the mangroves. Honestly, I don't know how to answer that. Does anybody have a comment to that question from Pramit? I don't see it as being outside the SOLAS domain. So if there is enough willingness, I'm sure we can include that in what we want to do. But I'm not an expert myself, so I cannot comment directly. But it's not outside the SOLAS domain, if that's what you're looking for. Okay, so Hermann makes a very good point. Make a fixed timeline, because that's the only way things get done, right? So yes, so the main thing to know at this point, of course, is who all want to be involved. And my hope obviously is to have several people involved, because that brings in different dynamics and makes things a lot better. But here's what I'm going to do is, because this is our very first meeting, you're all finding out about how SOLAS can work, cannot work, what you want to contribute in it, what you don't want to contribute in it. You'll go back, you'll find out how much time you have, how much energy you have. All of these things are going to matter, obviously. So my suggestion is, after this meeting is over, send me an email. I'll compile a list of people who are willing to help make the structure of SOLAS over the next 4 or 5 years. And we need a commitment of the next 4 or 5 years in order to get the structure together, even start thinking about things like the summer school, approaching the right funding agencies, etc. And then once we have this team ready, that's when we can start tackling problems one after the other. People who would like to be involved but do not have the time or energy to do so because of different reasons, you're more than welcome to give us suggestions. So if you feel that there is something that the SOLAS India community should try and address, try and send us a suggestion. When we have a team together, we will try and find ways to address those suggestions itself. But for now, I think the most critical part is to get the team itself together. Is there anybody who has a different perspective or different suggestion about how to go ahead? Please let me know now. Okay, well, I guess that's a good thing if nobody is so okay. So I think there's a consensus that we need to get this team together. So the easiest way to do this is obviously offline right now. So send me an email. My email address, I'll put it on the chat so that everybody has it in case you don't. And in addition to whether you want to be a part of this team which gets the structure together, remember, we are not right now trying to dictate what science SOLAS should focus on. We are trying to come up with a structure for SOLAS India. And later on, once the structure is in place, we will identify the right experts, etc., who can contribute to different types of sciences. So if you want to contribute to that, please send me an email. If you have suggestions about how a structure could work, could not work in India or outside even, please send me those also. For example, Arvind was talking about how he has experience with IIOE2, and from India, Professor Vinay Chandran was talking about how all these different programs have worked. So there's obviously a huge amount of experience already in this, in the people who are in the session. So let's mind that, make sure we don't make mistakes, and we make sure that there's a team which would end up working well in India itself. Those were the main points I wanted to make. I will, however, end with, sorry, I should share my screen. Unless somebody has a point to make, please, feel free to speak up. I just wanted to, again, Christa has talked about the review which we have written right now. And one of the main things in that review, okay, sorry, before we get into this, Saurav, you have a comment. Do you want to unmute your mic and speak up, please?
Yeah, so I'm Saurav, so I'm basically from IIT Bhubaneswar. So what I am thinking that mostly SOLAS, you are talking about the cruise program and all those things. For me, it's not, maybe I don't have that much time to contribute in the SOLAS, but what I'm thinking that we have an academic program, like we have MSc students, MTech students, okay. So they do a bit of project in the final year, right? So that maybe some of the students can look into the work in the area which SOLAS is looking for, and you don't need an additional fund for that. But whatever the existing data, maybe some data shared by the SOLAS community, they can work on that and they can contribute a part of this SOLAS India or global SOLAS community. So that is my.
Okay, so am I right in understanding that if somebody has SOLAS related work and needs some extra manpower, we can tie these things together to make, okay. That's a very good point, because most of the times science suffers because of the lack of manpower. So it might be a good idea to come up with a mechanism which we can, scientists who have data related to SOLAS can open up to universities such as yourself and get projects going together. That might be a good thing to consider in the structure we come up with also.
Thank you.
Cheers. Okay, so what I wanted to, I know Christa has already spoken about this, and it might seem that I'm advertising our paper, which maybe on a certain level I am, but the main reason why we did put up this review together was also to highlight what are the big problems that we are facing. And we came up with like this text over here, which at least I think is very pertinent to what we are talking about. And what it says is our current understanding of the Indian Ocean is mostly based on sporadic ship campaigns and remote sensing data. Details of large-scale features such as the seasonal cycles over the individual basins, variations of the latitudinal gradients, the vertical distributions and long-term changes for several trace gases, etc. is not very well known, and nor are the processes well understood. Large uncertainties remain in the current emission inventories that are used in models, and data for validation of model simulations is sparse. Dedicated long-term measurement stations, such as they exist in the Atlantic, Pacific, or the Southern Ocean, are required in order to link the distribution of trace gases over the Indian Ocean to transport patterns, chemical regimes, and to investigate feedback and forcing mechanisms. In addition to long-term stations, it's imperative to maintain a repository of the past and future observations made in the Indian Ocean, identifying long-term trends which are crucial to understanding the processes and impacts of climate change are hindered by a lack of consolidated database. In fact, this does it is talking about a few things that Hermann made. He has made most of his points in the presentation that he did initially, and I think this is something that the SOLAS India community should be aiming to address, because in terms of having long-term sites, etc., we are just perfectly placed geographically to be able to address some of these points. So when we come up with the structure, my sincere request is to think about these things also. With that, we are basically running short of time, and I would like to bring this meeting to a close, saying that if you want to be a part of this effort, and I can see there's a lot of interest over here, please get in touch by email so we create a team which gets the structure into place, and hopefully with that we can actually start making dents into all of these big mountains of problems that we are facing in terms of the science itself. If anybody has anything else to contribute, please speak up. I'll stop sharing my screen now so we can end this with any conversation that needs to be had. Yes, Anil Kumar sir, you have a comment to make. Please, please speak up. Sorry, sir, can you unmute your mic, please?
Yes, yes. Now, can you hear me?
Yes, sir, I can.
Yeah, actually, we are conducting a lot of expeditions to the Southern Ocean. And you know that this atmospheric circulation, a lot of the CO2 is getting absorbed there. And this is again coming back and getting ventilated. So this is closely related with the tropical Indian Ocean and the tropical climate change. So SOLAS, anything can be contributed in that angle, and how we can approach to that question. That is what I think about.
That's a very good point. I think this Indian Southern Ocean expedition has been one of the most successful continuous expeditions happening for 11 expeditions now. Yes. So, there is a value in having these expeditions happen year to year, because they build up a trend, which is basically what we need to understand quite a few of the processes. And we need to involve more solar science into that, because not only is it focused only on the Southern Ocean, but you get a wonderful transact from the tropics to the Southern Ocean, which I have to admit, my group has benefited from it a lot. But this is something for other people from India or elsewhere who are in this meeting to also consider. I'm sure, using the Southern Ocean expedition as a platform, there's a lot of good research that can be made.
And especially with the time series observations we are planning to make in the future, that is the mooring platforms and all. So anybody is interested with that, especially with the air fluxes and all. These studies can be linked with these SOLAS objectives.
That's a good point. I'll mention this. I don't work with NCPR in the sense I'm not at NCPR, but my experience with the Southern Oceans has been absolutely excellent in terms of the cruises. So anybody from India who wants to apply for those expeditions, the process is fairly straightforward. You can go and check on the NCPR website, and Dr. Anil Kumar, he's heading the entire program, and he's always welcoming towards new and exciting projects. So let's make use of platforms such as the Southern Ocean Expedition and push the kind of science we can do also.
Thank you.
Thank you, sir. Anybody else have comments, or should we wrap things up? Lisa, Jesse, do you also have any extra points to make?
I'll just say I'm actually feeling really encouraged by this. I'm looking forward to hearing much more from the Indian community. I think you guys are on a good path. I feel like this sounds like a very productive meeting, and you've got some good ideas. So thank you. Congratulations. Good luck. Have fun.
Thank you from all of us, and hopefully we can actually get to something that is more productive within a short time. Great. Thank you, everyone. With that, I think we'll wrap this up because we also need to stretch our legs. And the main meeting, the SOLAS Indian Ocean meeting, is going to start in the next 30 minutes. So at 2 o'clock, we shall convene again at the exact same link on Zoom or YouTube, wherever you are. And we'll continue with the rest of the sessions. Thank you so much. Susan? I think you need to unmute yourself. Okay. Hi, Susan. Can you hear me?
Now I can hear you. Sorry.
Okay, wonderful. Good morning. I know it is super early for you. Did you manage to get some sleep?
I did. Yes.
Okay.
I was tired. I have to teach this semester, and it's killing me.
Oh my!
It's really hard.
But thank you so much for doing this. I know it's not the best in terms of time, etc. But thank you for doing this. Should we?
Great meeting. Yeah.
Sorry. Yeah. So far, it's been pretty good, and hopefully, the afternoon session should also be good.
Good.
Okay, so because we are running right on time, should I just do a quick introduction for you, and then you take over? Is that okay with you?
Sure.
Okay, wonderful. We have 1 minute, so you can relax a little bit.
Right. So I'm just wondering. Okay. And everyone's there? All the speakers are connected and have their presentations ready and everything?
Yeah, Arvind is here next. And in case the presentations do not show up, you have their presentations.
I have them. Yes. I don't have them open, but I can open them pretty quick. So
that's good. Hopefully, we should not have a problem at all. Yeah. So the rest of the meeting, hopefully, you can catch it online later. There is a recording in case there are some talks that you want to listen.
That's a good idea.
And the afternoon's lineup sounds pretty interesting to me. So
yeah, it does.
Okay, all right, so we'll start off. Welcome back, everybody. I know it's been a fairly long day for some of us already, and it's been a very short day for the others. One of those is Susan, because she's just woken up in the middle of the night to take over the session. So Susan, first of all, thank you for doing this. I'll do a quick introduction. Susan is an assistant professor at the University of Saskatchewan and is working on the field of atmospheric chemistry and climate interactions. Her research interests include oceanic halogen and sulfur emissions, so very similar to me, except she aims for much higher up in the stratosphere usually. She's done a lot of work, especially in the UTLS region impacts of these species, and also works on stratospheric chemistry and dynamics. With that, Susan, the floor and screen are yours.
Thank you very much, Anup, for a nice introduction. Hello, everyone. We're gonna get right into session 3, impact of the atmosphere on the Indian Ocean. And the first presentation is from Professor Arvind Singh, and he's gonna talk about bioavailable nitrogen inputs in the northern Indian Ocean. So Arvind is working in the field of ocean biogeochemistry, and he's working in the Physical Research Laboratory in Ahmedabad in India. He's interested in nitrogen fixation, he's working on primary production, and he's using enriched isotopes and carbon in the Indian Ocean. And he's also investigating the role of environmental parameters on the variability of the observed rates. So Arvind, can you please share your screen and start with your presentation? Thank you.
Okay, so thank you, Suzanne. I'm not professor yet, so, but yeah, thanks.
I thought it said that. I thought I was prepared. Sorry.
Yeah, so also thanks to the organizers for inviting me for this great session and great meeting. So I'm going to talk about bioavailable nitrogen inputs in the northern Indian Ocean. Are my slides in the slide share mode? Okay, perfect. Yeah, so we know in the atmosphere we have plenty of nitrogen, it's 78%, but this form of nitrogen is not usable by marine organisms, or I mean, for that matter, not many organisms.
I'm sorry, Arvind, sorry to interrupt you. Can you please go full screen mode?
Okay. Oh, okay, now it works, right?
Yes,
it is okay
that's
now?
Perfect. Yes, that's
okay,
perfect.
okay.
Thanks.
Okay, yeah, thanks Anu for pointing it out. Okay, yeah, so I am talking about the bioavailable nitrogen. That means anything but N2, because that is the form that can be utilized by the marine microorganisms. So in the ocean, and the ocean productivity is actually limited by the availability of bioavailable nitrogen. It means if we put more bioavailable nitrogen, the productivity will increase. So you will have more CO2 into the ocean going, and then probably also export of carbon to the deeper layers. So that's how it is important to understand these processes. And these are the two main processes through which the open ocean receives nitrogen. One is the nitrogen fixation, which I will talk in great detail. So this is a biological process through which the diazotrophs, they convert N2 to ammonium, and once it is converted to ammonium, it can be taken up by the other phytoplankton. And the second one is the atmospheric deposition. So in the atmosphere, we have aerosols, and also there is nitrogen atmospheric aerosols. So with the dry and wet deposition of aerosols, this form of nitrogen can again be utilized by the phytoplankton. And then of course, once these phytoplankton, they sink down, they can be remineralized, and then again with the upwelling in the ocean, they can come up. But essentially these two are the most important processes, because these are the new nitrogen inputs, because this nitrogen comes outside the system, outside the ocean, unlike the deep water upwelling. So that's why this is more important to understand. And then since these two are quite important processes, we would like to know that how much is the data from the Indian Ocean. So then it's a very sad story. If you look the bottom, let me use my pointer. Okay, so if you look these modeled nitrogen fixation estimates, you would see very high rates of nitrogen fixation in the Arabian Sea and in the Bay of Bengal, also covering a large part of Indian Ocean area. But if you see the upper part from where this model output is generated, actually there is no data. In fact, the Indian Ocean is not even shown on the map, because there was no data until 2014. But still you get from the modelers, I mean, this is the beauty of the models, that you can get whatever you want. So yes, but of course there was one study from the Indian Ocean, but that was limited to the coastal Arabian Sea, and that's the reason the authors did not include that data. So here I'm listing all the work done by only Indian groups in the Indian Ocean on nitrogen fixation. So it started in 2009 and published in 2011 in GBC. This is the first one, and then a few more studies in the Arabian Sea, and mostly limited to the eastern part of the Arabian Sea, mostly in the coastal Arabian Sea. And then we have just begun the nitrogen fixation experiments in the Bay of Bengal. There are only a couple of studies from the Indian group. There is one more by Karo, and she probably might have a slide, but I will also have a slide on that in later my slides. So what did we learn from the nitrogen fixation experiments in the Arabian Sea? So this is during the springtime in 2009. These are the locations where we did the measurements, and here we have the nitrogen fixation rates and the delta 15N, the isotopic composition of the particulate organic nitrogen. It goes up and then goes down, and this is the indicator for nitrogen fixation. When the diazotrophy is prevalent, then the isotopic composition goes towards zero, because of the reference we use for nitrogen. This is the productivity. So sometimes they go hand in hand, but not necessarily that when the nitrogen fixation will increase, the productivity will increase. It's not one-to-one, but mostly it can also be true. So we saw very high rates of nitrogen fixation. Actually, these were the highest rates measured anywhere else in the world ocean. I mean, compared to anywhere else, and probably 2 to 3 times magnitude higher compared to any one of those. So I will also have a slide. And most the reason that these rates were so high is because of these dense trichodesmium bloom that we observed. And this is the photo from the same cruise when we did the observation. So that's particularly the reason. But you could also say that this is the bias, because we identified the blooms and then we did the experiments there. So we thought that could be just the episodic thing, and since the rates were so high, but we went again in the same season next year, and we still saw the rates were still high in the coming year in 2010 as well. The other experiments we did was to do the dark N2 fixation, and we saw that the dark N2 fixation at times they could be as high as the light N2 fixation rates. So we do not know whether this is heterotrophy or this could also be chemoautotrophy. We have no idea, because we did not have the molecular biological data. But this is also to consider that, because we say a lot of time we have the imbalance in nitrogen inputs. So perhaps something to consider. And this is all in the euphotic zones we found these high rates. We did another, so the conditions, the oceanographic conditions or the physical conditions in the Arabian Sea are quite similar during the spring and during the autumn. So if the conditions create a niche for nitrogen fixation during the spring, we thought that it could also be true for the autumn season as well. So we did again the measurements in the autumn season in 2010, and here we have these integrated nitrogen fixation rates, and this is the primary productivity that we parallelly estimate, and this is the nitrogen demand for primary production based on the carbon to nitrogen in terms of Redfield ratio. So this was the nitrogen demand, and what we found is that the nitrogen demands actually is less than the N2 fixation rates, or sometimes it is equal to the N2 fixation rates. So this again has implication, because we say the productivity in the ocean is limited by the availability of bioavailable nitrogen, and N2 fixation could not be such a major source of nitrogen in terms of primary production to sustain primary production. But here we found something quite interesting, and perhaps we need to look that this is only a seasonal thing or a regional thing, because again this is in the coastal region. Other thing I would also like to highlight that normally it is believed that the N2 fixation rates are higher in the open ocean, but we even found high in the coastal seas. And this is the comparison with the others. So this is, I have included a lot of data. Maybe I have also missed some data. On the x-axis you have different oceanic regions where N2 fixation rates were measured, and the blue ones are rates from the Arabian Sea. And you can, you can easily make it out that these are the highest rates measured. Whenever you go and measure in the Arabian Sea, you get these high rates compared to the other oceans. In another study, we checked the importance of dust, or the impact of dust on nitrogen, the availability of iron and phosphate. And there was a proposal that Arabian Sea could also work like an HNLC region at times. So we did this study. So we have the natural N2 fixation rates in black bars, and we also added dust in the bioassay experiments, and we plotted them here, and you see that there is not much difference. So the dust doesn't seem to impact or doesn't seem to influence the N2 fixation rates. Now we have to interpret this with the caution. Of course, dust is important, but if we put more dust, probably the N2 fixation doesn't increase. So there is probably some other ingredient, probably phosphate, that is missing. So if we put these two together, probably it should increase. This is all the historical data on the nitrogen deposition. So the aerosol data. So on the left hand side you have the atmospheric deposition, on the right side you have the new production. And in this study we wanted to quantify that how much is the contribution of atmospheric nitrogen deposition to new production. And we found that maximum this go up to 3%. I would also highlight that this is a lot of data from the JAGOPS cruises, so a lot of historical data. So of course the uncertainty in the aerosol measurements are quite large, but in terms of number, you cannot decrease this uncertainty if you increase the number. So that's the highlight. Of course, in new production we have little less data. So this 3% sounds quite low, quite minor, but in terms, because this is additional. These are the additional nutrients supporting the new production. So like 3%, you are sequestering additional carbon. So in those terms, it is, from the climate perspective, it is still quite important. Okay, and now I come back to the Bay of Bengal study that we did during 2018, and this is the study we published recently. Because the Bay of Bengal and Arabian Sea, they are quite similar in many aspects, of course not in all aspects. And since they are situated in the similar latitudes, you expect them to behave similarly in many ways. And the conditions for nitrogen fixation, traditionally the way we thought, for example, nitrogen fixation requires water to be calm, to the temperature to be high, and water to be, of course, stratified. So when you compare these conditions between the Arabian Sea and the Bay of Bengal, you would think that the N2 fixation should be high in the Bay of Bengal, because the conditions are more suitable for nitrogen fixation in the Bay of Bengal. But in this study, we found we again estimated this contribution of N2 fixation to primary production. In the Arabian Sea, we found it could be at times 100%, or in the GBC paper, we found it is 92%. So quite high. Here we found it goes maximum to maximum to 1%. So here it is quite low. So again, very surprising, and we need to look more that what is the reason for this, why N2 fixation is not prevalent. One reason could be that we did this study during the monsoon time, during the very intense during the July time. So the clouds were very high. It was all cloudy and windy. So maybe we did not choose the right season. That could be the reason. So perhaps some more studies are needed in the Bay of Bengal to see this. And this is the study I was talking that Caro has published. She also found very similar no nitrogen fixation in the Bay of Bengal. I think the answer is yes here. But Caro had chosen mostly the oxygen minimum zones, and also one depth as the depth of chlorophyll maximum. So the results are quite similar. Even there is one more study recently published by Sharma et al. They also found quite similar results, and they attribute that the phosphate actually is limited for nitrogen fixation in the Bay of Bengal. They did the bioassay experiment with the phosphate. So there are a lot of questions from the Bay of Bengal perspective. Also, some of the questions we need to answer in the Arabian Sea, and the discrepancy in the nitrogen fixation rates in these two regions. And this is again, there is I just wanted to update the nitrogen budget slide. So on the left hand side you have these earlier estimates, and these are all provided by Hermann's study that he did long back, published in GBC in 2000 probably, and the numbers are taken from there. Many are question marks, and then from the modeling work very high rates, and then put the N2 fixation rates, and this is how the number looks like, because the high rates are, so this is only in the Arabian Sea. So when we have the high rates of N2 fixation, these numbers go up. Other numbers remain more or less at the same thing. And this is one in the Western Indian continental shelf study published by Amit Sarkar et al. Recently. These are the numbers he gave. So I thought also to put these numbers. So these numbers are the old numbers, and the nitrogen loss numbers, they have gone up. So maybe we need to look also from the basin bite that whether nitrogen budget is it in balance or is it in imbalance, and whether it should be in balance, that is another question in the basin scale. But these are some of the things we should think about this solving these problems. So I would like to stop here. If there are any questions, I would be happy to answer.
Thank you very much, Avi, for a very nice presentation. It's great to see all this interesting data and your results. So I'm just waiting for questions to come in. Anu, would I see the questions in the chat?
Yes, they should be coming into the chat. People have been asked to type them directly.
Okay.
Maybe everything was quite clear. So
so far I can't see any. What do you think? Where would you go to do the next measurements? What do you think is the most interesting place? If you would
so get the money most interesting, I mean, we have never done in the Western Arabian Sea, and that's because of the logistic reasons, the piracy problems there. So one could be that reason, because the hypothesis has been, and of course it has been challenged recently, that the upwelling regions may not be the drivers of nitrogen fixation. And the Western Arabian Sea, we know, is an intense upwelling region. So whether this is also true for the Western Arabian Sea, and I don't think it would be, because the dust would also be coming from the western side of the Arabian Sea. There is also excess phosphate because of the loss of nitrate during the denitrification. So I think there would be high nitrogen fixation rates that we are missing. And then of course the aphotic nitrogen fixation rates that we are missing in the ocean, those we need to look. And of course Bay of Bengal seems to be very interesting. For example, what is the role of eddies on nitrogen fixation? So there has been some studies in the other regions as well, that the cyclonic eddies and anticyclonic eddies, they behave quite differently. The dynamics is quite different. So and the Bay of Bengal is like home of eddies. There are plenty of eddies and also plenty of cyclones. So what kind of roles they play in terms of modulating nitrogen fixation? So those will be some of the things.
Yeah, you have more than one idea where to go. So I've seen now we have actually a couple of questions coming in, and I don't think we have time to go through all of them, but I start with Anup. He was the first. He was asking if you put your data back into the global inventory to see how much this changes.
Okay, so the numbers, of course, this is a very significant number. Of course, this 22, it looks very small, but if I remember, the global nitrogen input to the ocean is around 250 teragram nitrogen per year, and this is already 22.5 in the Arabian Sea. So, and Arabian Sea is being only 1% of the global surface area, and this is almost 10%. So, in terms of global significance, this is quite huge, so very significant. And if we have similar numbers in the aquatic zone and in the Bay of Bengal, because we did not choose the right season in the Bay of Bengal, then it makes more impactful. So I'm not sure if this was a question from Anup, but I guess.
Yeah, so I think he was asking if you have already put this into the global inventory, but maybe you can discuss with him afterwards. I see another question here from Caroline. She was wondering how regular are the trichodesmium blooms? Yeah, thank you. In the Arabian Sea.
Yeah, so we can see them with the naked eye every year. So they start occurring after the noctulica blooms. So the noctulica blooms occur during February, and during mid-March or late March, these trichodesmium blooms start occurring. And when the monsoon onsets somewhere middle of the May, then they try to, then they will have to go away. So that's the time, and they are every year. We have seen from the observations they occur every year. But I'm not sure how, in terms of spatial extent, how far do they go? But in the Eastern Arabian Sea, we have seen them many times.
Okay, well, there are more questions here, but I think we can't go through all of them. Maybe you can answer the questions in the chat after your presentation. That would be great. Okay, thanks again.
Thank you.
And we want to switch over to Mikael. Mikael, can you start your video? And then bring up your presentation. So it's Mikael Strelek, I hope I pronounced this right, and he's working at the Institute for Marine and Antarctic Studies at the University of Tasmania and at the Antarctic Climate and Ecosystem Cooperative Research Center. And Mikael, are you there?
Yes, I'm here. Could you hear me?
Yes, now I can hear you and I can see you. Hi, nice to meet you. I'm just introducing you. So Mikael is working on trace metals, and he's focusing his studies on source characterization of trace metal deposition, especially in the area around Australia and also part of the Indian Ocean. And he will talk about Western Australia to the Indian Ocean, the delivery of natural and anthropogenic errors or trace metals down under. Okay, go ahead.
So, thank you for a nice introduction. So now I try to start my presentation. And so today I'd like to tell you about the atmospheric trace metal deposition from Australia to the Indian Ocean. So let's start with basics on atmospheric trace metal deposition. All trace elements and other elements in the different kind of aerosols like mineral dust, emissions from bushfires or anthropogenic processes. They are drained into the atmosphere, transported long distances over the ocean, and they may be deposited even to remote area where their delivery may be consumed by marine biota. And Australia is an important source of mineral dust. This is because of the arid inland and plenty of deserts inside Australia. And this is the red areas on the map on the right side. And also Australia is a significant producer of black carbon. This is because of the spectacular bushfires occurring each year in the northern part of Australia, but also depending on year in the southern part. For example, 2 years ago, we've got massive bushfires in Hobart. And finally, Australia is responsible for below 6% of mineral dust production and about 11% of the biomass burning calculated as burnt areas in the global scale. So what's happened with those aerosols? They are basically transported into two directions. One of those directions is westward to the Indian Ocean, Middle Indian Ocean. Despite the eastward the transport path is bigger and is better understand it because of the more sampling size, more data. However, we decided to start investigation on the western aerosol transport path. As you can see on those map on the right side, Australia is the green area is where the dusts are and total iron are deposited, and the map on the bottom shows you simply the I need to show you the areas of the ocean where Australia is the main contributor of aerosols there. So what happened with aerosols? They contain, for example, iron. Iron is important micronutrients for oligotrophic waters, such as the Indian Ocean. Cyanobacteria needs the iron for grow and need it to be able to uptake nitrogen from the atmosphere, and finally to uptake the CO2 from the atmosphere and decrease its concentration in the atmosphere, what is good for us. And this is the issue for the Indian Ocean. It's the different effect is observed in the Southern Ocean where there's a lot of nutrients, a lot of nitrogen and other elements in the seawater, but photosynthesis is limited by iron, which is just lacking micronutrients. And those three areas on the map on the top indicates the places where the link between atmospheric iron deposition to the ocean is most probably to cause a biological response of the ocean. So the most probable places where the phytoplankton bloom or similar processes may occur. So we collect our samples on the western coast of Australia. We collected everything, no size selection or size aerosols were collected onto the cellulose filters, and then this filter was a subject of three-stage leaching protocol to find the concentration proportion of fractions of different solubilities. The most soluble fraction was soluble in milky water, it was called soluble. A bit less soluble is called leachable, and is dissolved in ammonium acetate, and the rest is refractory. Refractory fraction may only digest in aggressive acid environment. So those two first fractions, soluble and leachable, are called label, and we expect it's pretty good proxy for bioavailable iron. So let's start to talk about our results. First of all, we found that total iron is closely linked with the mineral dust emission. The concentration between atmospheric concentration of total iron and atmospheric concentration of mineral dust traces, titanium and aluminum, was very high. And enrichment factor, this is the white bars on the right chart, they are around 1. Enrichment factor 1 indicates that there's the same proportion between iron and titanium in the atmosphere and in the crustal materials, global average crustal materials. We also found a big seasonality in emission of mineral dust and therefore total iron. It was the emission of mineral dust during the warmer season was about 6 times higher than during the cool season. Regarding iron solubility, we found that our samples are generally less soluble than aerosols collected on the eastern coast of Australia. The collection was using the same sampling method, the same leaching protocol, so they are well comparable. And we see that in Western Australia, the fractional iron solubility was about 2.5%, it was about 3-4 times lower than iron solubility in Queensland or in Tasmania. Majority of the label fraction was in the easily soluble form, means they are expected to be easily bioavailable just after deposition to the ocean. And we also found that fractional iron solubility was the highest for samples contained the increased amount of emissions from bushfires. So this was the effect observed before in the Southern Ocean and other places in the world, and here we confirming it for bushfires from Australia. So how data from Western Australia looks in comparison to the eastern coast? You can see here there was much more of the total iron, much closer to the mineral dust sources, but due to the lower fractional iron solubility, the atmospheric concentration of label iron in Western Australia was not high, was at a similar level like in Tasmania and much lower than in Queensland. It's maybe because, as I said, that there was much closer to mineral dust sources, but also the western coast of Australia is much less inhabited than the east coast and much less industry as well. So that's the probably players of this effect. So I mentioned before about the seasonality in mineral dust emission, and in the warm season, this is the flux of mineral dust in warm and in cool season here. It was much lower during the cool season, it's logical, and the same for total iron, which is linked with the mineral dust tracers, but it remained the same ratio, this means maybe not the same ratio, but the same pattern for the label iron flux. What does it mean for us? It does mean that mineral dust is responsible not only for the total iron deposition, but also for the label iron deposition. Is the key player, it provides the highest amount of the label iron flux. The label iron from emission processes during the winter did not increase the fractional iron solubility significantly. So I try to put our data in the more global or regional context, and it appears that our samples are somewhere between the data from the Bay of Bengal, where there are plenty of aerosol from big cities of India, from industry there, but they are much higher than for data from Arabian Sea, where there was mostly dust were collected, and we've got also predominantly dust in our aerosol samples. However, we found that most of iron in our samples was contained in the aluminum silicates particles. We found it by SEM analysis, and alumina silicates are expected to be more soluble than the ionic. So that's maybe the explanation for that. So at the end, I'd like to focus on anthropogenic input, and we try to find and assess the anthropogenic signature in our aerosols. So we applied a fancy statistical tool of positive matrix factorization, and we found that our aerosols contain mostly natural aerosols called mineral dust, sea salt, and biomass burning, but we've also got the anthropogenic source, called it industrial aerosols, with elevated amount of zinc and lead, which in our study had the highest enrichment factor, and also with ammonia. So potential sources of those anthropogenic aerosols, we expect they may be from the coal-fired power plants. This is a big complex of power plants located about 200 kilometers south from Perth. And also, it's possible that they comes from the alumina refineries. And on those charts on the right side, you can easily see that there was a big difference in the enrichment factor of lead during the cool and in the warm season. This is because of the lower and higher dilution or by the mineral dust. So how the atmospheric concentration of total trace elements looks in the global scale, in the Indian Ocean scale, they're pretty high. They reasonably high. They, if we compare them with the other data from the basin of Indian Ocean. However, it's worth to remember about first, we collect our samples from the land, and those 5 studies below are from ship-based campaigns, so they are different kind of aerosols. We are able to collect more anthropogenic data because we are closer to sources. But on the other hand, the gravimetric velocity of the fine size anthropogenic aerosols is low, and those aerosols are able to be transported over very longer distances. So it suggests that we couldn't be 100% sure with this comparison, but we see that Australia is still a significant provider of anthropogenic elements. So let's summarize our findings. We've got that our aerosols are mostly natural origin. We've got low enrichment factor, good correlation with the crystal materials tracers, and natural aerosols dominating there. I didn't mention about it in the presentation, but we've got also low oxalate concentration and clear seasonal trend in the oxalate concentration, and it suggests that we collect our samples in the rural rather than the city area. It's more comparison from the nature, more contribution from the nature. And we also found the low solubility of iron, and we explain it by the fact that it was mostly mineral dust sources. You can find more details on our work in the publications here. There's more of them, but they're just basics. And there's on the top describe the finding from the Western Australia. And so thank you for your attention. Thank you for inviting me. Feel free to ask questions or just email me.
Okay. Thanks a lot, Mikael. That was very interesting. See what happens with the biomass burning particles. You had a couple of questions coming in while you were speaking already. So I'm going to start with the first one that was in the beginning. And Mirach was wondering, how was the biomass burning contribution estimated?
You mean those action?
Yes, so the biomass burning contribution from Australia.
No, that was shown in the beginning.
So from our data, we're not able to say exactly that the biomass burning was responsible for such a percent of the particles. We just only found that this among the major sources of the aerosols. So I don't know if
no, in the beginning. Hello.
Yeah, so I think he's referring to your estimates in the beginning of the presentation. Okay.
Yeah, you showed some estimate of biomass burning and mineral dust. So I was curious to know how the biomass burning was estimated, contribution of biomass burning.
So we estimated biomass burning. We found the oxalate was the best proxy for biomass burning in our study. Non-salt potassium didn't play well because probably because of the contribution from the coal-fired power plant, which also produced the potassium along with lead. So we tried to find the best proxy at the beginning, and we tested the major ions which are correlated with that. Yeah, and it was also visible by the satellite images we know from that which samples are suspected to contain elevated amount of the biomass burning. Our sampling time was pretty high because someone collect samples for us, and the sampling time varied between 1 and 2 weeks. And actually we've got a mixture of different aerosols, and so it makes the exact image of the contribution of sources a bit more blurry.
Okay. Just one more quick question from Lisa Lotte. She was wondering if the iron in the aerosols would be depleted during transport.
Yes and no. Yes, it could be, because during the each solubility of iron may release a part of the soluble iron, but actually the transports usually generate increase in fractional iron solubility due to the mixing with the major ion, with oxalates. So actually all the elements, all the particles are lost during the transport. Total iron is lost relatively quickly because the mineral dust particles are coarse and the settling velocity is rather high. So yes, we definitely lost iron, but also we lost our aerosols during the transport. I remember it was a publication studying the relative changes in the concentration of iron, titanium, and alumina during the transport. And what they found that the aluminum was more easily abraded than iron, if I could remember. So that's why we decided to use titanium to have more reliable information about the origin of our iron. So
okay, great, thank you very much. There are one or two more questions. Can you answer them in the chat?
Yes, sure.
Yeah, I think we have to move on for the sake of time.
Thank you very much.
10 minutes behind. Thanks again. We're going to move into session 4, and we're going to turn things around and now look at the impact of the ocean biogeochemistry and microbiology on the atmosphere over the Indian Ocean. We're going to have the first presentation in this session from Lisa Lotte Tinnell, and she's working in photochemistry at the atmospheric relevant surfaces. She's at the University of York, and particularly she's working on the surface microlayer and on interfacial reactions in this microlayer that involve iodine. Lisa Lotte, are you online? And
yes, I am.
Yeah.
Can you hear me? Yes.
Yes, I can hear you and see you. Welcome.
Great. Thank you. Okay.
Yeah, we can see your presentation as well.
Yeah, that should go full screen now. Any second, I hope. If that works. Come on. Yeah, that's it. Okay. Now I just put this on. Good afternoon or good morning, everybody, and welcome to my talk on the influence of the sea surface microlayer on oceanic iodine emissions. So my name is Lisa Lotte Tinnell, and I will present work mostly done at the University of York, but done in collaboration with the group of Dr. Ball at the University of Leicester and the group of Dr. Mahajan at IITM Pune in India. And I will talk a lot about iodine, not only because it's the coolest element of the periodic table, but also because it has some very real impacts. It has an impact on our health. It's an essential dietary mineral, and without it, our thyroid will not function correctly. It also has some interesting radioactive isotopes which need monitoring, and it can have an indirect impact on our health through air quality. And I will mainly talk about air quality and climate impacts of iodine here. So how can iodine impact on air quality and climate? That is because iodine is naturally present in the ocean, in the seawater, and it can be emitted also into the atmosphere. And once it's emitted in the atmosphere, it will create a very reactive species that can react with gas phase oxidants such as ozone or OH. And as it does so, it will lower the oxidation capacity of the atmosphere, which will impact the lifetime of greenhouse gases. It can also contribute to the formation of aerosols, and this will interact with the formation of clouds, and hence again have an indirect effect on climate change. So it's quite important to get this iodine right. And the main form of iodine in the ocean, which we will focus on, is iodide. The most important form, let's say, for atmospheric matters. So iodide here on this schematic in the red dots is I-, and when that is present at the sea surface, it can react with ozone in the gas phase here in blue. And this reaction is actually a major sink for ozone over the open ocean. Through a series of steps of reactions, it will form through this reaction HOY and I2 molecular iodine. And these two can be emitted then into the atmosphere. And once they are emitted, they will react as I showed in the previous slide. And so these two species are actually the major source of iodine in the marine atmosphere. There is a third source of iodine, which is also important, organic iodine, which is emitted through biological actions, such as methyl iodide, for instance. But the flux, as shown here by the numbers in the arrows, the flux of the organic iodine is a bit lower than the inorganic fluxes that are predicted for HOI and I2. So if we want to have a better understanding of the ozone deposition on the ocean, we need to know how much iodide is present at the ocean surface, because that's what ozone reacts with. And this is a map, a global map, showing all the iodide observations up till date and done at the surface of the ocean. So as you can see, there's quite globally representations of observations. We have almost in every ocean basin except the Arctic observations now. And also in the Indian Ocean, quite a few now. We have 1,300 data points, but this spans a period of 50 years. So that's not an awful lot of data in the end. And if we look at how much iodide is actually present, this is a probability distribution. So you can see that actually most of the oceans have iodide concentration somewhere between 35 nanomolar and 140 nanomolar. On average, it's 45 nanomolar. So it's low concentrations of iodide present in the oceans. This data has been published recently in a paper of Chance et al. In 2019. So the whole compilation is now available for everybody to use. And so because there is not an awful lot of observations, here on this plot, we have all the observations in dots in function of latitude, and this is the iodide concentration. So we have to come up with clever ways of parameterizing iodide concentration at the sea surface in order to predict the iodine fluxes to the atmosphere. And so the main parameterizations used so far have been Chance et al. In 2014, which is the orange line on the plot. And this is driven by sea surface temperature. Then there has been a second one in green, McDonald et al. 2014, which is also driven by sea surface temperature. And then a very recent machine learning algorithm also does predictions for iodide at the sea surface. This is the blue line. And as you can see, all of them predict that actually iodide is higher at the lower latitudes, so towards the tropics. And this is very well reflected, reflecting the data, but none of them is obviously perfect. The machine learning algorithm probably captures best currently the observations. And so if we see this, parameterizations have been optimized. How well do they do in the Indian Ocean? We can see first what are the specificities of iodine in the Indian Ocean. Here, the same plot, we have latitude in function of iodide concentration in the sea surface water, and all the green filled symbols are Indian Ocean data for the open Indian Ocean. And the other open symbols are other ocean basins. In blue is, in black is the Atlantic, and in red the Pacific, and in blue the Southern Ocean. So the first thing that strikes is these two very high iodide concentrations here in the Indian Ocean, and these are two very high outliers in the Bay of Bengal, where iodide was measured over 900 nanomolar. You might recall that the average iodide concentration is about 95 nanomolar, so quite a bit higher. And then another thing we noticed is that actually this gradient in the subtropical Indian Ocean is much steeper for the Indian Ocean, as you can see here, as opposed to the other ocean basins. So there is some particularities in the Indian Ocean for iodide concentrations, and this can have implications for the validity of the parameterizations, because as you might recall, they are driven by sea surface temperature, or that's related to latitude. And so this is exactly what has been shown in this recent publication by Inamdar et al. She also presented a poster earlier on. They looked at observations of iodine oxide in the gas phase from 3 different cruises in the Indian Ocean, and compared their observations with modeled iodine oxide using 2 different global models, GeoSchem and CamChem. And they compared they used 6 different parameterization to estimate the iodide concentrations at the sea surface. And we will focus on this upper panel here, because that's north of the polar front. This is the actual open Indian Ocean. This dotted line here is the 1-1 line for the model output compared with the observation of iodine oxide. And as you can see, actually the model shows some skill in predicting the observed iodine oxide, but in general, the predicted iodine oxide is too high over the Indian Ocean. What they also saw is that there is actually no significant correlation between the parameterized iodide in the ocean and what they actually observed as iodine chemistry later on in the gas phase. But they did see a positive correlation between iodine oxide and chlorophyll A north of the polar front. And so that actually means that the fluxes of iodine are more complex than they are currently considered in the models, and that we need more studies to accurately parameterize these fluxes. And so if we go back to our sea surface, in the model considers the sea surface as being just seawater. So we can wonder if there would be an influence on the fluxes from the presence of the sea surface microlayer. Just to remind you, the sea surface microlayer is a very thin layer at the top of the ocean, up to 1,000 micron at the top of the ocean, which is enriched in inorganics and certain organics, and it can be very enriched. So this could have an influence on gas fluxes to the atmosphere. And so we wanted to investigate this more, and we decided to measure iodine emissions in the presence of surface microlayer. And to do that, we had to measure molecular iodine. And we did that with a broadband cavity enhanced optical absorption spectroscopy. And so we used this setup. Here we have a custom reaction vessel where we introduce seawater at the bottom, and we can have a flow of gas on the top containing ozone, so it can react with iodide in the seawater. And then we monitor the uptake of the ozone with an ozone monitor. And right above the seawater, we will measure with our BBC EAS the I2 emitted from the reaction of ozone with iodide in the seawater. And so we use the spectrum of I2 for that, between 520 and 570 nanometer. And the advantages of our setup is that we have very reduced wall losses and it's temperature controlled. Okay, so we did that. We did that over 4 different solutions. Here in gray, the dots are observations we did. We see here flux against iodide concentration. So we did that in function of different iodide concentrations and for different ozone concentrations. And here for 35 are the results shown. And so the first solution we used was potassium iodide, a buffered solution, so very simple water and iodide. Then in red here is artificial seawater, the same thing as the Ki solution, but we added chloride and bromide and no organics. And then here in blue is subsurface seawater, which we actually sampled in the North Sea. And in green is surface microlayer sample. And so what you can very clearly see, this is a log scale, is that we have an important reduction as soon as we start using natural seawater samples. And the highest reduction is shown for, of the I2 flux is shown over the surface microlayer sample. And the difference between the subsurface and the surface microlayer water is actually 65% on average. So it's quite an important reduction of the flux. And so we then try to understand what happened there, and we try to see if this reduction could be caused by the formation of volatile organic iodine emissions, which we measured by GC in separate experiments. But we could see that actually they represent less than 1% of the total iodine flux and are negligible. So they don't explain this big reduction. The reduction between the Ki solution and the artificial seawater can be explained by an additional heterogeneous reaction of HOI that forms more iodate, so we have less formation of I2. And then the strong reduction with the natural samples we explained by an increased solubility of I2 in the organic enriched seawater. And we had to increase the solubility by 6 for the subsurface water and by 30 for the surface microlayer as opposed to just pure water. And these factors seem to roughly correspond to the enrichment factors of the surface tension, but we definitely need more data to confirm this trend. So to conclude, I would say we have a better parameterization of iodide at the sea surface, but we still can't measure very accurately the iodide chemistry over the Indian Ocean. There are some regional specificities of iodide concentrations in basins, so we need more basin-focused observations, especially in the Indian Ocean and the Arctic region. Iodine fluxes observed over natural samples showed an important decrease compared to artificial solutions. That's the last points I showed. And then this reduction was most pronounced over the SML, which points toward a change in solubility of the I2 produced. Volatile organic iodine species are negligible in the total flux of this ozone and iodide reaction. And HOI remains the main iodine flux, and so that flux might not be affected by the solubility effect. We only looked at molecular iodine. And so again, a call for more flux data in the field and in the lab to understand better this whole mechanism. And then I would like to thank you for your attention and happy to take any questions if there are.
Okay, great. Thanks, Lieselotte, for a very interesting talk on the coolest element of the periodic table, how you called it. Anup was the fastest with this question. He's wondering if you believe that the surface microlayer in the Indian Ocean is different from other oceans.
Oh, that's a very...
overestimate the atmospheric iodine.
I think it's very difficult to answer that question at the moment. There's, to my knowledge, no data on the SML in the Indian Ocean. There might be some, but there's definitely, yeah. This is the first study on the influence of SML on fluxes of iodine, so it's very difficult to extrapolate this to other basins at the moment. We don't have enough data on SML, and we don't have enough knowledge of the iodine fluxes themselves over the Indian Ocean, so I don't dare to pronounce there.
Okay. Calling for measurements.
Exactly.
And Christa is wondering if you, what do you think are the reasons for the reduction in the I2 over the natural waters besides solubility?
Yeah, we think it's for the moment, that's our only guess. We tried other hypotheses, but yeah, solubility seems to be the most plausible one. So we think it's plausible. It's probably just the solubility, so a physical chemistry issue. There might be other things, but we would need to do more systematic experiments and different samples to better explore this.
Okay, all right. Okay, thanks a lot. I think one or two more questions for you, if you don't mind answering them in the chat.
No, not at all.
we're going to move on to the second speaker of this session, Caroline Löscher. I can already see Caroline. Hi. So Caroline is working at the in the field of marine microbiome ecology and microbiofeedbacks at the University of Southern Denmark, and her research is focused on nitrogen and carbon turnover processes, and she's using chemical profiling and weight measurements as well as bioassay manipulation to understand how the ecosystem works and how the system responds to potential future changes. And she's going to talk about how microbial community composition determines the future of carbon pumping and greenhouse gas production in the two northern Indian Ocean basins.
Yeah, roughly that.
It's ready. Perfect.
Yeah, I think it's shared, right? It's
shared, but maybe you can go into the presentation mode. We can see notes and next slides and all of this. Yeah.
Okay, where do I do this? What's that?
I don't know.
Wait, I probably have to do it here. Like this? No.
Yeah, this one. Yeah, perfect.
Yeah, it's good like this. Awesome. Okay. Thanks for your introduction, actually, and good morning or afternoon. Or
Can you
evening.
try it again one more time? It's
still not good.
No, just maybe try this one again there. Yeah.
Let me see. Does it work, kind of? Or?
No, not on my end. I don't know why.
Let me check. Well, you know what? I share again.
No.
Now that it worked. Let me share this one. Now?
Yes. Thank you.
Finally, I now have it on my other screen. I don't know how that happened, but it happened. All right, I'm going to talk about a bit of a short version of the title that you just gave us and just talk a bit about a thought that I had about the carbon pump and how it interacts with the oxygen minimum zone intensities essentially in the different Indian Ocean basins. And this talk is essentially based on a paper that made a big impression on me, which is a paper by Greg and Rousseau from last year. And it was basically talking about global primary production. The authors then took chlorophylls, or basically the pigment markers of different groups of phytoplankton, namely of diatoms and coccolithophores and chlorophytes and cyanobacteria, to interpolate primary production from it. And what they found was some sort of decrease in primary production, which was actually quite a statement to make, I thought. And the authors didn't stop there, but actually took it very far and mapped it for a time frame over 2 decades. And I'm just showing the initial point in 1998 and the end point in 2015 here, which is just basically determined by the satellite imaging they used for this. And they found that this decrease in primary production is very visible in the Indian Ocean, that we have it a lot in the equatorial regions of the Indian Ocean, but also in the Bay of Bengal, especially in the northern parts where we have it basically, well, disappearing. The Arabian Sea seems to also be affected rather in the southern parts and on the continental shelves. But strongest effects are, as I said, in the equatorial regions and the Bay of Bengal. So they aimed at quantifying this decrease in carbon fixation in the Indian Ocean regions and came up with quite a significant number, between 10 and 16% of a reduction in primary production. And also this kind of translates into a decrease in carbon fixation at the same level, therefore impacting largely the greenhouse gas flux of CO2 into the water column, of course, because it just decreases. But also it has, of course, huge impacts of the whole biogeochemistry of the system. And yeah, let me check it. And if we look at it a bit more closely and look at the different clusters, I would like you to just pay attention to 2 of the clusters which were especially affected or which have some ecologically interesting pattern in this reduction. So what we see is basically the chlorophytes and the cyanobacteria occupying very different niches, and those two plots come now from 1998, so the earliest time point in the time series. And what we see is that the chlorophytes are very abundant in the northern part of the Arabian Sea and in the equatorial Indian Ocean, while the cyanobacteria basically take an exactly opposite pattern. So they seem to avoid each other. They seem to occupy actually very different niches. And this is very interesting ecologically per se, because it means they are determined by two opposing environmental factors, or maybe by the same one, which one can deal better with and the other one can deal worse with. If we look at the second time point at 2015 and the same two clusters, the chlorophytes, green algae, and the cyanobacteria, then we see that actually the chlorophytes decreased quite a bit. The authors calculated something around 25%, while the cyanobacteria increased and extended their niche quite a bit into the Arabian Sea and into the central parts of the Indian Ocean, the equatorial Indian Ocean, but also in the Bay of Bengal. So one can ask, like how comes? But this is certainly a very obvious pattern that changes in the community composition. Here we also have changes in the coccolithophores and the diatoms, but I found this pattern especially interesting as it seems to have to do with the different oxygen minimum zones in the Bay of Bengal and the Arabian Sea. So this is basically also from the same study, just that I replotted the nutrient distributions here. The authors already correlated the change in, or the decrease in primary production to the decrease in nitrate and silicate in those two, or in the Indian Ocean regions, actually not specifically in the basins. And nitrate and silicate decrease actually by around 30 and 20% respectively, which is quite a big change, of course. So now this provokes this change in community composition, and this of course can come from the fact, and this is especially true for nitrate, that smaller cyanobacteria of the Prochlorococcus type, which we find to increase in abundance, have a very small volume. So they have a big surface to volume ratio, and also they have a very high affinity to nitrate. So they may just deal better with this decrease in nitrate that we can observe because they are more efficient in taking it up. Another question that came directly up to my mind, because I'm a big fan of nitrogen fixation, is of course, if we have a decrease in nitrate, why do we not have nitrogen fixation popping up like hell? We would expect this, right? And Arvind already put it out. We actually have high nitrogen fixation by cyanobacteria, for example, in the Arabian Sea. This is very special. We observe here those big cyanobacteria, and I just stole a screenshot from Arvind's presentation where he showed so nicely how this actually does look if you look into the water. And seems to be a more or less permanent and reoccurring feature. And we do have some observation for the equatorial Indian Ocean to also have those large cyanobacteria that are able to fix nitrogen. But we do not have this in the Bay of Bengal. We hardly have observation covering Trichodesmium, and if so, they are from the south. But well, we have some other organisms fixing the nitrogen there, but not very efficiently. And those are heterotrophic nitrogen fixers, which is, well, they are shown to be active sometimes, but usually at very low rates. A bit more sophisticated way to plot this is basically to show it in the shape of a phylogenetic tree, where we see Trichodesmium, which is typical for the Arabian Sea, popping up, and the heterotrophs in the blue box here popping up in the Bay of Bengal regions. Why this difference? Well, we do not know, but it seems to impact the community composition of primary producers, as the bigger scale nitrogen fixers, the Trichodesmium type, are able to supplement just more nitrogen to other phytoplankton, bigger phytoplankton that of course also have a higher requirement and a lower affinity for it. So this could explain why we see those differences in community composition. We don't know why they distribute as they do. It could be iron, it could be the availability of other vitamins. We do not know this exactly. This is actually one of our gaps in understanding the Indian Ocean microbiology with regard to nitrogen fixation, but it certainly impacts the whole ecosystem. And to explore basically how nitrogen fixation and carbon fixation interact in those different basins of the Indian Ocean, so of the Arabian Sea and the Bay of Bengal. I tried a bit around with this little box model. This is based on Canfield's 5-box model. Don Canfield is a colleague of mine, and we use this model as a tradition of ours. And it connects an upwelling system in a typical style with an intermediate water cell and a deep water cell being upwelled in contact with sediments, transporting nutrients up into the coastal and open ocean euphotic zones, therefore feeding the primary production in the top layers. So if we now play this through with a nitrogen fixation scenario in the Arabian Sea and a non-nitrogen fixation scenario in the Bay of Bengal and consider different carbon pumping efficiencies slightly with like determining the phytoplankton classes in our box model, we get a very simplistic result that I actually created for a nitrogen fixation paper from last year. And if we look at the Bay of Bengal with low primary production, no nitrogen fixation, we see that we only through upwelling can get in a bit of nitrate, but as soon but because of the stratification we see in the Bay of Bengal, we actually do not cause any full accumulation of ammonia or any exhaustion of oxygen. We do also process-wise not really see a lot of primary production and a lot of export production unless we break the stratification that is present in the system. And we almost never see denitrification coming up, only if we really, really break the layering and force the carbon pump to act strong. Opposed to this, we see a completely different picture in scenarios like the Arabian Sea, where we indeed can feed the system with external nitrogen sources, just pronouncing again the important role that nitrogen fixation plays in those regions, where we indeed have ammonia accumulating. This is, of course, an exaggeration of what really happens. It is a model after all. But we also see nitrate being consumed by denitrification. And this complete drawdown is basically due to the different stoichiometries of nitrogen fixation and denitrification. And it leads also to nitrous oxide production, which is not resolved in this model, but one of the future goals for it. If we look in the lower plot at processes again, we see that primary production expressed as export production, of course, is very high if we are able to produce, because we are not nitrogen limited anymore. This also allows for denitrification as massive rates and for a strong sources nitrous oxide, for example, during denitrification as we observe in the Arabian Sea. So, but what happens now if we play a future scenario where we have the Bay of Bengal now having an increase of primary producers that are maybe a bit more efficient in using the available nitrogen and recycling the available nitrate? Well, if we assume that those cyanobacteria can do this, which it seems to be, because actually, we see them increasing in abundance, we would expect some sort of minor intensification of the oxygen minimum zone as we have more export production, slightly more though. We, however, have a certain limit because denitrification will not be able to occur unless we have a new nitrogen source bringing new nitrogen into the system. You cannot denitrify what you don't have. So after all, the Bay of Bengal will always be limited by the lack of external nitrogen input, which can be supplemented by nitrogen fixation, but also by changes in upwelling, which have been put forward, could be eddies or anything, and I'm a big fan of this idea too, or also atmospheric nitrogen deposition. This indeed could tip the Bay of Bengal over the point at any point and make the carbon pump running, suck up more CO2, but also denitrify and produce nitrous oxide. For the Arabian Sea, well, if we lose primary production, that would be a quite significant impact on the oxygen minimum zone. Well, we would be optimistic and expect an oxygen minimum zone weakening, though we cannot be quite sure if this will really happen because it's also majorly determined by the water mass dynamics and other conditions too. Or we will have an ongoing and continuous community change, and what decreases now is just replaced by other organisms. And we will need long-term studies and time series studies to find out about this, because this is not what we can prove with the model. We can just suggest it. So for both basins, however, there will be an impact on denitrification, nitrous oxide production, and set intensity, which is basically governed by what governs the carbon pump, which I suggest to be the nitrogen import largely. And my current work is targeting very much to figure out the tipping points for those processes and for when denitrification will take off in the Bay of Bengal or will be switched off in the Arabian Sea, under which conditions we could reach this. But this is not what I can provide to you so far, so I'll stop here and hope this was provoking some thought, and I'm happy to discuss anything. I will stick around in the chat for the whole afternoon. So yeah, with this I'm done. And I guess I can stop sharing the screen. Oh, I put up my acknowledgements. I stopped sharing the screen anyway.
Okay, great. Thanks, Caroline. That was very interesting. So there was one question. I just have to scroll a little bit from Islamir Shariful. Was this to Caroline, the question? What kind of cyanobacteria is available in the Bay of Bengal?
So yeah, this is so the ones that we can map with the satellite imaging, and this is also confirmed by my metagenomes, is Prochlorococcus mainly, and some minor types of Synechococcus, but it's those very small ones which are efficient in taking up nutrients, but otherwise do not produce a whole lot of biomass, right, and are not able to fix nitrogen, as opposed to the big ones that we find in the Arabian Sea, which can fix nitrogen and are big because they are trichodesmium, right?
Okay, so there's another, so I'd say it's more a comment from Hermann T. Biswas, and he's saying, thanks for the nice talk, and that they've compared data from the JGOVs from the 1990s with data from now that they've taken, and that they don't see any significant change.
In what? In the community composition? Depends on the spatial coverage, I would say, right? The satellite imaging shows it pretty clearly, I would say, and well, this also fits to the nutrient decrease, and it fits to the particulate organic carbon.
But you know what? The nutrient biogeochemistry is very much linked to the atmospheric process in the Arabian Sea because it changes with monsoon reversal. And we have covered the Central Arabian Sea, pretty much the India GEOMAR track, and also the Eastern Arabian Sea. And we compared now, we have the HPLC data, we have the microscopic data, and we have particulate organic carbon and isotopes. And we don't see any significant change in the Central Arabian Sea or even in the coast. I mean, the diatom-dinoflagellate ratio also doesn't show much change. There is significant interannual variability within 2 monsoon seasons. Okay. And we see significant contribution of Prochlorococcus and Synechococcus in the south of the faint letter jet.
Yeah, that I would expect, yeah.
Yes, but we didn't see any significant decrease in chlorophyll, and I mean, that was something very interesting. No significant change in total biomass and also in the community.
So I would think in the Central Arabian Sea that may be this area which is still, it's kind of consistent with what you see here, right? Because where you found the community change was more the northern part of the Arabian Sea, the coastal bit, and then you found it in the Bay of Bengal and in the equatorial Indian Ocean. But it would be quite cool to look into those data and compare it to the satellite imaging, so to get a bit of a more consistent, of a bit more solid estimate of the community change. Because I think your methods, of course, are very direct methods, and this is actually, after all, preferable. Though, if you want to have the spatial coverage, you always go back to satellite imaging. Wherever it was possible, I compared to metagenomes. But as you probably know better than I do, this is limited, right? We only have so and so many. But hey, I guess we could maybe at a point look at this together. I'd be very interested. I would be very interested in this.
Yeah. Thank you. I'll get back to you. Okay.
Cool. Yeah, looking forward.
Yeah.
Thanks again, Caroline. Very interesting talk. You actually have more questions, but again, I have to cut it off here. And
sure, I look into them and answer them.
Yes, perfect. Thank you. So it's my pleasure to introduce the second keynote talk of the day. We're gonna have Peter Burkle, and Peter is currently Professor Emeritus at the Ocean Sciences at the University of Plymouth in the UK. He's co-chair of the International Indian Ocean Expedition. He was president of SCORE for a while, and he has worked intensely in the field of microbial dynamics based on experimental and observational molecular research. So, Peter.
Okay, thank you very much for a very generous introduction, and thank you to everybody who has participated in the meeting. Let me start off by saying, friends and friends-to-be, it's a pleasure really to share some views on the Indian Ocean. Before I do that, and well, maybe as part of that, I'm going to say where we are with IIOE2, setting it in context before offering some thoughts on the future. I confess I'm not really going to talk about SOLAS. I'm no longer an active scientist, although I do claim that I once wrote a paper with Cliff Law, who I understand is likely to be your next chair of SOLAS, on methane in the Indian Ocean, but that was back in 1991, but it was published in Nature, which I'm very proud of. So onwards. The context of the talk is really, I want to address interactions between SOLAS and IIOE2 involving SCORE. I will touch briefly on how SCORE operates. I will then go on to talk about how IIOE2 is evolving and how the Indian Ocean is evolving. And I will then touch on future opportunities that I perceive around the corner. And finally, as requested by the people that kindly invited me, I need to look backwards from 10 years ahead, if you can understand what I'm saying, to see what sort of legacies IIOE2 may leave. So this is a very busy diagram, but please just focus on the red circles. Here I show what SCORE does and what sort of responsibilities it has. It covers a lot of ground, as you might expect of an international organization that was set up over 60 years ago. Interestingly, its first role was to coordinate the research of the first international study of the Indian Ocean. SCORE is part of the International Science Council. I hope you can see a little logo there. But to all intents purposes is autonomous, receiving funding from its national committees and from the US NSF. As this figure indicates, SCORE does many things, but one of them is that it sponsors large-scale research projects, which are shown up here. We currently have 5, and 2 of these are SOLAS and IIOE2. Both projects have multi-sponsorship, and this offers, I would say, advantages and disadvantages. And those of you that are responsible for taking SOLAS forward will understand this with your evolution. Decision-making in SCORE is probably no different from any other organization, in the sense that we have an executive, which is shown up here, and a series of national committees. The executive has responsibility for making decisions on a day-to-day basis. And these are all elected posts, except for the director. She's the only paid post in SCORE, Patricia Miloslavich. The president at the moment is Mary Alexandrine Sikra. Paul Myers is our secretary, and I'm the past president. We meet on an annual basis, and at the annual basis, and it's going to be virtual this year, we have national committees, and collectively we debate how SCORE is operating. The countries that are involved in SCORE are shown here, and I give the website here. The annual meeting is going to be held from the 20th to the 22nd of October this year, and it's open to anybody. If you are interested in finding out about how SCORE is operating, then please join. You will find the registration via the SCORE website. One point that I just alluded to, and that is on the day-to-day basis, the executive, each of us has a responsibility for each of the activities that SCORE carries out, And for SOLAS, the executive reporter is Sinjae Yu from Korea. Great guy. And I hope that you feel Sinjae looks after you well. Now, let me switch and talk a little bit about IOE2 and how it operates. Our logo, which I'm sure many of you are familiar with, is shown there. And we have this rather grandiose aim to advance our understanding of the Indian Ocean and its role in the Earth system in order to enable informed decisions in support of sustainable development and the well-being of humankind. That is quite a mouthful. But the three co-chairs, this is Vladimir Ryabanin of IOC, Secretary General. Here we have Satish Shenoy, Chair of IOGOOS, and myself, I really represent SCORE on IOE2. We have three pillars. I show two here, the science plan, which was set up by Raleigh Hood and Hermann Bange and a cast of thousands that brainstormed over a 5-year period what the science plan should comprise. And you will see here 2015, which was our launch, to 2020. This has now been superseded to 2025 because SCORE Executive has agreed to extend its sponsorship of IOE2. And this is why I have here 2025. We also have an implementation strategy that was set up again by quite a large committee chaired by Satish Shenoy. I've forgotten whether I said Raleigh Hood, Hermann Bange, who's one of your key players in SOLAS, was also hugely institutional in this. But this raises an interesting question, and that is SCORE operates very much in a bottom-up process. In other words, scientists have a view. If that view is expressed well, succinctly, and it finds a lot of provenance with the peers, it will generally be upheld. Whereas UNESCO and IOGOOS are very much political animals. And this is important because these guys have the resources that often SCORE does not have. And in the politics of getting international programs up and operation, that is really, really important. Looking to the future, is IOE2 evolving? I alluded just now to the science plan. A lot of the science plan, for those of you that may have looked at it, and I should say that this is available from the Indian Ocean IOE2 website, shown here. You can download that for free. Please do. Both these documents are available. A lot of the work which has been done has involved the pure research, but pure research in itself is evolving. So the answer to my question is this evolving? Yes, it is. But we also need to recognize that the Indian Ocean itself is evolving. It's a highly dynamic region. And I will spend a little bit of time on this a bit later on. What about the scientific goals of IOE2, those that are currently outstanding? Let us remind ourselves of the aim of IOE2, to advance our understanding of the Indian Ocean. Anything in green we are tackling. So I've put here, to advance our understanding of the Indian Ocean. This is largely peer-reviewed manuscripts. They're rolling well. These are documented for those programs which are involved in IOE2 on this website. And altogether, including IOE2, but a lot of other activities outside, we're publishing about 2,000 publications a year altogether. This is the whole community of scientists working on the Indian Ocean. But in red, these are issues which we have yet to really tackle. The role in the Earth system. I'll talk about heating in just a moment, but I think this is the single biggest issue because it affects a very, very large number of people indeed. And here I see an opportunity for SOLAS. I think the second part of the scientific goal, which we've yet to really address, is sustainable development. And this was touched on earlier on. Hermann touched on it. I'm going to unpack this a little bit in the way of the United Nations Decade Initiative, which I'm sure quite a few of you will know something about. So, is the political landscape changing? The new kid on the block, well, it's not a kid, it's actually a huge organization, the United Nations Decade of Ocean Science for Sustainable Development. I hope you've all had a chance to have a look at it. It's a very rapidly evolving, highly political situation. It's very much the brainchild of Vladimir Ryabinin, who you may recall is actually one of the co-chairs of IOE2, so we're in a good position. And he describes it as the science we want for the ocean we need. Now, you could say, perhaps cynically, that this means all things to all people, and there has to be an element of truth in that, because what he says, what Vladimir argues, is that actually this is an opportunity for ocean scientists to put on the political agenda the requirement for the future work that is needed, and one will have to argue the case of why that is needed for society. It begins next year and will go on for a decade, so it's a big, big platform, and it contributes to the United Nations SDG 14, which is life below water, whatever that means, but you understand what I mean, I hope. And we're posed at the moment to discuss in SCORE, in IOC, and also in IAGOOS, whether IOE2 could become an early flagship for the decade. Now, let me go back to why I think this is hugely important by talking about the recent understandings of how the Indian Ocean is changing. One of which, as Roxy reminded us so elegantly, the Indian Ocean is warming rapidly. Despite its small size, the Indian Ocean has accounted for 33%. Look at this red here. This is time. This is oxygen averaged over the top 700 meters, but Roxy also demonstrated 700 to 2000 meters. 30% increase of the global ocean heat content over the last decade. That is just huge, and it's going to have a huge impact. Most of the heat seems to be going into the southern Indian Ocean for reasons that we don't really know. Roxy talked about the heat leakage through the Indonesian archipelagos shown here, and it seems as though whilst that process of heat transfer continues, the Agulhas may be waning a bit. So there may then be a buildup of heat as a result of the discrepancy between this flux and this flux. Now, this process is shown here. If you look at this red arrow coming here and then going out of the Indian Ocean, there's also mixing that occurs on the southern boundary, and we really don't know enough about what is happening on that southern boundary. We don't know where the heat will go. We don't really know in any detail what the consequences of this is. But warming creates increased vulnerability. As I'm sure those of us that work in the Indian Ocean know, 1/3 of the global population occurs around the rim of the Indian Ocean, and that proportion is growing. There are many small island developing states and least developed countries that are dependent on fisheries. And these are shown here, particularly the red ones. We also have an increasing of episodic events such as cyclones. The Arabian Sea cyclones and the Bay of Bengal cyclone is increasing. 5% of global cyclones occur in the Bay of Bengal, with 80% of the global casualties. Huge numbers of dead in 2018. One cyclone alone accounted for 140,000 lives, sadly, 1 million people homeless, and $10 billion worth of damage. So we can say that the Indian Ocean is changing. The increase in temperature increases its vulnerability, and with things like pH, which I haven't talked about, but is also happening, the corals and some plankton are decreasing. There's a change in the plankton Oxygen, also the deoxygenation is occurring, which will affect all living creatures, mostly decrease. So how do we go from this into sustainable development? Let me share with you a simple model which I've spent some time thinking about. My model is shown here. There are two boxes. There are the conceptual steps and the international programs. Let me just walk you through this. What we are involved in as natural scientists is understanding the natural environment. And what this translates to are resources in terms of routes, rates, and controls and process. And this then relates to international programs that SCORE sponsors, including SOLAS and the International Indian Ocean Expedition 2. From this, we need to go to understanding sustainability, whatever that may be. And in particular, we need to ask how sensitive are resources and processes, the sort of things we're dealing with up here, to change. And the international programs that are relevant are the, for instance, in our case, the Indian Ocean Observing System, which then generates time series using a variety of different platforms. So using these, we can then look at how changes occur of the different resources. The third conceptual step is to understand sustainable economies. And this, for us, I believe, is the most difficult. What are the links to the markets? Do we understand change and its impacts? But I believe this is where the United Nations Decade of Ocean Science and Sustainable Development may possibly help us. Let me then go through this again in a slightly different way, using natural resources for sustainable economies. The challenge as I see it is our training is within a discipline. I happen to be a biologist. I understand to some extent living things, natural resources. Others may be trained in, for instance, economics. So no single person can bridge from the natural resources to sustainable economies. The answer to understanding natural resources and how they may be translated for sustainable economies is to use a team of people with different disciplines. The challenge here is what makes a good team. And my answer is a group of individuals with diverse specialist knowledge sharing an agreed goal. How? It's catalyzed by money. And I would argue that the more international this funding source is, the better it is to avoid bias. So let me brainstorm the next step, and that is what I call transformation research. Here we're using natural resources to underbuild sustainable economies. The elements could be, this is hypothetical, natural resource scientists, environmental economists, environmental lawyers as facilitators, and then stakeholders whose livelihood depends upon using natural resources within a sustainable economy. This third step is absolutely huge and is probably the most difficult for us to interact with in a normal way. The funding. I think if an idea such as this transformation research is accepted, we bounce this back to the United Nations Decade and say, you feel it's important that we use natural resources to underpin sustainable economies. You find the money. I think international funding should be easier and the team's optimum. In other words, I'm saying international teams. As the United Nations concept matures, a funding line needs to be created with a call for transformational grants. This is the sort of thing that I'm talking about, for natural scientists to work with facilitators and with stakeholders. These grants would allow international interdisciplinary teams of, say, between 5 and 8 people to use natural resources to underpin sustainable economies, to work together for a suitable period of time, 3 years to 5 years, to create more sustainable businesses. I was invited earlier this year, before COVID struck, to go out to Bangladesh, and this caused me to think about how we could use this sort of transformational research in Bangladesh. And being a marine scientist, I looked at what was happening at this boundary, and I focused on the Sundarbans, a beautiful area, And in this area, there is a huge amount of timber extraction that occurs. There's a huge amount of fishing. And if I can just find my notes, sorry about this. The figures are really quite significant in both these timber extractions and fishing. And tourism is also on the increase. So using timber extraction, using fishing, and using tourism, I told you I wasn't going to talk about SOLAS. This is really just to stretch your minds and get you thinking about how we may possibly be able to use the United Nations decade. I've come up with some examples. Transformation project for natural resource-based sustainable economies. Timber. The sort of person we would need in this funding would be a local representative who's a natural scientist. There may be possibly other people from outside the area. In this case, you know, it might be Bangladesh, it could be India, it could be anywhere. We would need facilitators, timber economists, local, and I've suggested Sweden. Why Sweden, I don't know. Natural botanists, local, and I suggested the UK. It doesn't have to be UK. But essentially, the most important thing is that we have to have representatives of those whose livelihood depends upon the timber industry. Similarly, with fishing, we need artisanal fishing, fishermen whose livelihood depends upon the fishing industry, and then people such as lawyers who understand fishing, both local, I've suggested France here, working together with natural scientists, fishing specialists, local area, and I've suggested Indonesia. Similarly for tourism, we need people whose livelihood depends upon tourism. Economists, I suggested a local person and somebody from the USA, wildlife experts, people who understand the biology of tigers and deer and other things, maybe even mangroves themselves in the area. So to summarize this part, I think I could envisage, let's say, big projects, 15 people working together, 9 in the case of Bangladesh, 6 international, perhaps 2 meetings in 3 years, 1 between work by 2 monthly video conferencing, a grant of 50,000 per year, small project, single economy, perhaps 3 Bangladeshi and 2 international, 5 people working together as above, a grant of something like 150,000. I think we would need funders for the administration, and I suggest we bounce this back to the International Group on Funding Authorities or the United Nations. So my last but one slide. The summary so far, we know the Indian Ocean is changing fast. It's warming, the pH is increasing, the oxygen is dropping, populations are growing, and that is just putting increasing pressure on the region. And that again is another very good reason why IIOE2 could be an excellent candidate for the United Nations decade. Something which I think all of us will fully understand, knowledge is strength. We need a strong program in the field and elsewhere is needed if we need to improve our understanding. So we need to continue to measure the ocean, whether it be in the Bay of Bengal or the open Indian Ocean. IIOE2 will continue at least to 2025 and probably beyond, but it needs inputs from all nations. And my cartoon here shows a house, a well-built house and a CRAP house. And knowledge is the same as measurements, is the same as foundations. The foundations of this house have sunk. The whole house is coming down. I would say that if you've got good foundations, you have a strong house, and this then will result in good, sustainable economies. And this is built upon natural resources. So the question is whether we want a strong house or a weak house. Of course, we always want a strong house. So I would say transformation research harnesses fundamental knowledge. And when I got to this stage last night, I realized that actually I hadn't given anything on legacies. So I'm going to go back and have legacies of IIOE2. SCORE has agreed to extend IIOE2 to 2025. That means we will fund IIOE2 think tanks meetings at annual basis, so on and so forth. And the other two sponsors, I think, just have an open-ended commitment. We need better understanding via publications, and here I show 1990, 2000, 2010, and then each year the number of publications in the Thomson ISI series. It's just over 2,000 a year, as I mentioned before. The other legacy which I would hope we will achieve is a really good database. This doesn't have to be IIOE2, but because I have a responsibility in IIOE2, I've identified it. And what we envisage here is that it's a distributed database with national platforms. If you're funded by India, there will be a requirement, I'm sure, to put the Indian data into Indian database. Certainly it is with the UK. But the main node is Hyderabad, and they are very, very good at this databasing. So I would say databases are required in order that those people who wish to data mine in the future are able to do so. And I would say another legacy, and it's come home in the discussions today, stronger international links between scientists. I would say beyond IIOE2, the decade is focused now to 2030. And I would ask the question about, will the transition from curiosity-driven research, which is very much SCORE's purview, is SOLAS's purview, is IIOE2's purview to date, to transformation research be achieved? This could be a legacy that leads to new funding. And I fundamentally believe that to be the case, but only time will tell. Thank you very much.
Thank you, Peter. Very interesting talk, very interesting ideas in there. I think for the sake of time, we will go to the panel discussion in a minute. Just want to let you know about one comment from Christa. She was suggesting that the Belmont Forum might also be a place to go for funding, because they're interested in funding these activities.
Yeah, the Belmont Forum is actually would be an excellent way of doing this. They're already operating to some extent in similar ways.
Yeah. Okay. Well, thanks again to Peter. Thanks to all the speakers from the two sessions before. I will hand this back over to Anoop now. Anoop, I'm very sorry that we're running late. I guess I'm not really good at stopping people, but
No, thanks a lot, Susan. I mean, the talks were very, very interesting, so I understand why it would go overboard.
Okay, thank you.
No worries, no worries. Thanks a lot. With that, we are done with our talks, but you know, the most exciting part of the day where there's a discussion is to come. Lisa, I'm just going to hand this over directly to you. You've already been introduced, so I'm not going to go through that again. If you just want to take over and start off, please go ahead.
Okay, if someone can maybe turn off Peter's screen sharing, please. Thank you very much for that, Peter, by the way. There we go. Excellent. So now we're coming down. We're coming down this to the last session of the day. If I can ask our panel members to please turn on your video. We've got Hermann already. Katie, are you on somewhere? And Vinaya Chandran, excellent, good. So we've got the whole team here. So now what we want to do is have a bit of discussion. We're going to be a little, we've only got half an hour, and even that runs us over a bit. So I hope that's acceptable to you guys. And the goal here now is we've pulled together some of the real visionaries to try and brainstorm and think ahead. And the overarching question here is, what are the big gaps that need to be filled, and how can we do that? And the people we've got to contribute to this conversation is, first we have Katie Altieri, who is a senior lecturer in oceanography at the University of Cape Town. She's a member of the SOLAS Scientific Steering Committee and the SOLAS Executive Committee. She's also the South African SOLAS National Representative. And she's an atmospheric chemist pursuing a variety of subjects crossing the intersections of the atmosphere, the ocean, and human society. We've been talking about other people today who seem to do everything and have their fingers in all parts of solar science. Katie is definitely on her way there. Next, we have Hermann, who you've all met several times already today. In addition to being a professor at GEOMAR and a member of the IIOE2 steering committee and the co-chair of the working group on science and research, he's also a member of the SOLAS Indian Ocean implementation team. Was the co-chair of SCORE Working Group 143 on dissolved nitrogen and methane. And yeah, again, a chemical oceanographer. I'm repeating myself. And then finally we have PN Vinayachandran. I hope I pronounced that right or close enough. Who is a professor. Right. Is a professor of oceanography at the Indian Institute of Science in Bengaluru. He's also a member of the IIOE2 steering committee, and he's the co-chair of the science theme on boundary current dynamics, upwelling variability, and ecosystem impacts. He's an interdisciplinary oceanographer, integrating physical and biogeochemical processes and numerical models and field expeditions. Another one of those does everything for everybody people. And I want to point out, he is the only person on this panel who actually has a Wikipedia page. So he's clearly a true authority on this subject. So now we have to try and be efficient. And I know I have a bad habit of getting sucked into what's going on too, but I'm going to be trying to watch the time because I want to make sure we get through a couple questions. And so when I'm wanting you to try and wrap up, and come to a close, I'm going to wave a red flag at you. Okay, if that doesn't work, I'll have Jesse turn off your microphone. But hopefully we won't come to that. We chose you guys carefully for that reason. So I want to start you off with an easy question, and just to get warmed up. And so the first question. We've got the big overall question of where are the gaps that need to be filled and how can we do that? But I want to frame that around a couple smaller questions. The first one I have for you is, what air-sea processes are unique to the Indian Ocean? So not so relevant in other oceans that require particular attention. And so the three of you can actually go ahead and turn off your microphones and go ahead and talk. One of you wants to go first?
Okay. Yeah, I'll take that. So, I mean, the most striking feature of this region is monsoons. And, it's very popular line that monsoon governs the life of this part of the world. For one thing, it brings all the water that we need. It's actually created the history of this part of the world and so on. So the air-sea interaction associated with the monsoon is definitely the most important aspect, whether it be science or it be culture or society or economics, that governs everything. Now, if you look at in a general view, the monsoon comes every year and we get rains, and that's the part which gives rain for the rest of the year for the almost entire country. Monsoon comes every year, but it has a lot of variability. For example, one year you get 10% less, another year you get 10% more, and this 10% is a kind of limit. Within 10% we can manage, and if it goes beyond that, we don't know what to do. We are in trouble. So air-sea interaction around in the Indian Ocean and even elsewhere is very important to understand this. So that happens in different time scales. It happens in intra-seasonal, happens at seasonal, and it's inter-annual time scales. So I would say that's the most important reaction. It's also relevant for SOLAS kind of topics because the rains wash out everything that's in the atmosphere down, and then it has to be built over again. So I don't want to stretch too much. So if there is any particular point we want to discuss, then we can go ahead.
Excellent. Yes, undeniably the monsoons are the big one, and I'd actually never thought about the whole historical and cultural part of it too. But of course, Katie, Hermann, do you have any other ideas, or you want to add to the monsoon story?
Katie, please go ahead.
Okay, yeah, so I think I was also thinking about the monsoons and the unique feature in terms of the impact of anthropogenic deposition on the Indian Ocean basin. So you have the surrounding regions, East Africa and India and beyond, so that can contribute anthropogenic pollutants, but also this back and forth between extreme dry and extreme wet deposition, and the relative importance of those two inputs into the basin, I think is a really unique feature of the system. And one that we can almost exploit to improve our understanding of how anthropogenic deposition is impacting the surface ocean in these two different ways. You know, it gives you kind of a natural variability experiment, which I think is really potentially very interesting.
I agree with both speakers, and I would like to point out that the coupling of the monsoon with the upwelling areas is very important. This is a very special feature for the Indian Ocean. We have the upwelling regions in the Arabian Sea. We have one very prominent of Somalia, but not to forget, we have one of the island of Java, so on the eastern side of the Arabian Sea. Sorry, the eastern side of the Indian Ocean. So this makes the Indian Ocean very special. And also I would like to point out that this brown haze, which was mentioned by Christa, for example, and all the pollutants which are carried over the Bay of Bengal is very special, and we don't know how this input of aerosols and pollutants into the upper ocean will affect the biogeochem cycles and ecosystem in the Bay of Bengal. And this is, I think, also a unique special feature of SC interactions in the Indian Ocean.
Excellent. Wow, very, very articulate.
Lisa, could I add another question?
Yeah, sure, Peter.
I completely agree with Vinay. You know, when we think about the Indian Ocean, it's monsoons. But the flip side of that is that it means the focus of the Indian Ocean research will remain in the north. What about the south? You know, we really don't know too much about that. And I come back to this point made by Roxy and I made in my presentation. What about the heat? The heat has to go into the atmosphere. And I would say the southern Indian Ocean heat transfer has to be another issue. And politically, that is really, really important because it takes us into part of the ocean that we know less about.
This may be a nice segue into my second question that I've got for you guys. Thank you very much, Peter. And that is, what research is needed in the Indian Ocean that cannot be done by scientists in just one country, but absolutely requires international collaboration? I ask this question because international collaboration is what SOLAS does and what we facilitate.
So I think I have to agree with Peter here, that from the perspective of the sort of working with South African postgraduate students who are studying the South Indian Ocean, the lack of very basic biogeochemical observations and understanding in the South Indian from sort of the east coast of South Africa across, I think is a great example where we absolutely need international collaboration, north-south collaboration, south-south collaboration, to address some of these fundamental questions that have been addressed in other basins, but have yet to be addressed in the South Indian. And I'm thinking also particularly about the Mozambique Channel, as if I can sort of include that as part of this.
Yeah, certainly as a polar oceanographer myself. Yeah. Go ahead, Vinya.
Yeah, I too agree with you. There is only so much we can do by being in one country and looking at that particular part of the coast. Because the ocean is divided. You just can't access any part of the ocean that you wish. You need the permission of that country, EEZ definitions, and so on. So I had also bugged Peter during the IOE meetings that we need to expand and include people, countries, and groups which are just not part of the system. How many countries are actively involved in Indian Ocean observations of any sort? So even in IOE, we have been able to achieve only limited participation in this. And that's our one field we have to really think what is required for more inclusion of a whole lot of countries which are not in the scene at all. It may be that they don't have the capability, they don't have the financial resources, or whatever it is. Unless those issues are addressed, a large part of the Indian Ocean are just going to remain not properly observed. For example, the Northern Arabian Sea off the coast of Pakistan, Iran, and to the west, and many parts along the western part of the Indian Ocean. So such regions are just not observed at all. To cite an example, I can quote an Indian experience. India has a program to measure the surface meteorological parameters. Okay, this program started in 2009, and in the last 10 years, they have more than 1,800,000 records, and this system is now fitted to 36 ships that fly in waters around India. So if you look at a distribution map of that data, the entire Bay of Bengal, the eastern half of the Arabian Sea, and up to the equator, we have an excellent data that is required to calculate the fluxes of heat from the atmosphere to the ocean. So it's not very expensive, but it requires coordination, interest, initiative, and so.
Have we lost him?
Have no gaps at all.
Vinya, you're breaking up. We seem to be losing your connection. I'll watch you, and when you start moving again, we'll come back to you. Hermann, did you want to say something about this?
No, I think pretty much was said already by the previous speakers. So yes, well, I mean that's what I meant with the pan-Indian Ocean effort we need. So we really need to join forces to tackle all the scientific issues.
Any ideas? I mean, we've been for decades. Oh yes, Peter.
Yeah, I just want to go back to the Southern Indian Ocean, and that is, I would have thought that it was absolutely central to SOLAS to understand the pool of warm water, which is ultra-oligotrophic. It must be spewing out biogenic gases. How many measurements are there down there? I'm talking about south of the equator, the area where the water is warming the most fast. That in itself, I would have thought, was absolutely, on the ball for SOLAS.
Yeah, unfortunately, we were supposed to have a participant here today from the Norwegian Polar Institute, who's doing a lot of work down there, but he got pulled into stupid institutional administrative crap today and had to bow out. But yeah, personally, I'd definitely be very interested in seeing more work in that area.
Just a brief add-on to what Peter said. I mean, the Southern Ocean is interesting for the heat exchange, but it's not that interesting for the exchange of trace gas, I have to say, because it's an oligotrophic area. Apart from the events where we see this immense and great phytoplankton blooms there. So the trace gases are not really very high supersaturated. So the story for the trace gas is really on the coastal areas and the upwelling areas where you find these extraordinary large emissions of N2O, for example, or methane, and so on. But
Okay,
I agree with people that the Southern Ocean is interesting to go, especially in the view that we see these huge blooms, the phytoplankton blooms there, and actually nobody knows what these blooms are triggering.
Yeah, then you want to you were talking about the need to bring in additional countries, and so do we actually have you? Oh nope, he's frozen again. So I'm wondering about how to actually do this. I mean, we've been trying to do this for decades. It's been a major focus of SCORE to try and build capacity in more countries to be able to do this kind of work. And it's being such a slow process. Any clever new ideas for things to try to move this forward, or is it just something that's a generational process?
Lisa, am I allowed to talk?
Yeah, you're allowed to talk. And you know what, Peter?
Okay.
I think you should turn your camera on.
Well, I'm not sure I can I? I don't know. I'll try.
Well,
no, what
just
I wanted
see if you
to
can
say,
turn Peter's camera on. Yeah, go ahead, Peter.
You know, SCORE is very, very concerned about capacity building. It's something that Ed Urban, when he was executive director, put in a lot of effort into. And Lisa, if I was in your position, I would contact Ed, who's now retired, but he's still committed to this sort of work, and just ask his advice. And I would say there is a very good opportunity. SCORE last year, 2019, agreed to extend IOE2 sponsorship to have 1 or 2 regional workshops geared to capacity building, which SOLAS may wish to lead, I don't know, in the region. I would go for it, but I would talk to Ed.
Okay.
I think there are 2 problems. So we can do this capacity building. And I think this can be done in a very easy way. We can have all these nice video conferences and organize summer schools. And the other thing is, or the other side of the coin is that we need to provide platforms to go to remote places like the Southern Indian Ocean. And therefore we need to set up a procedure to provide this platform. That means, for example, in hiring ships, or so there's, for example, a private organization which provides ships which could be hired and equipped for doing science in the ocean, of course. So the point is then, how do we can convince, for example, the United Nations to give us some money to do this international effort and just hire ships and equip them with research gear to do the research we want to do in the Southern Ocean, for example.
Yeah, I agree with Hermann. I don't know if it's always necessarily an issue of capacity necessarily. I think we need to be a little bit careful there. I think in some ways it's an issue of resources.
Right.
Sure.
If you had more resources, including autonomous platforms, access to ships, funding for student bursaries, funding for laboratories in the Indian Ocean Rim countries, then more of this work could get done. I don't know if it's necessarily capacity building. It worries me a little bit. It feels a bit, I want to say colonial, but I don't mean it quite so negatively as that. But I think it's more about upskilling and resourcing, the scientists that are already there and allowing for this type of collaborative work to move forward. And the positive of that is that it can be cheaper to do this kind of research in-house. The cost of one South African student bursary is shockingly cheap when you convert it to euros or dollars or pounds. And so I think that, we just need to be a little bit careful there.
Yeah, in my mind, capacity building runs the whole gamut, not just training students, but also helping with resources. And Yeah, that's a very good point, Katie. Thank you. Any other thoughts from we seem to have lost Vinaya Chandran, unfortunately. Hopefully he'll manage to get back in eventually. But we've gained Peter, so.
Well, yeah, I feel as though I've muscled my way in here. I don't mean to. I said right at the beginning, I'm not really a solar scientist. But I do feel, you know, just following on from that for a minute, you know, Hermann and I are both involved with IOE2, although I'm going to roll off IOE2 next month. You know, we've got an opportunity to engage Vladimir Ryabanin, who is the architect of the decade, to say, you know, what is the best way of getting some resources? And I think, as I said in my talk, the idea of transformational research, I would have thought would register. That is dependent upon having good fundamental knowledge. And if it is in the Southern Indian Ocean, so be it. You know, that is a good reason to push that particular angle. God knows there are enough small island states there that are affected by climate change, whether it be sea level rise or other activities. So, you know, that's the first point. I think the second point, which I feel increasingly, we love going to sea on ships, but they are bloody expensive and they are incredibly hard to get hold of now. So I would encourage SOLAS and everybody else to think about gearing their work, their research, to using autonomous platforms, which are going to be much, much cheaper, give you much longer periods of time than a ship would be able to be. Admittedly, you know, you're not going to be able to put your gas chromatograph on a, well, maybe you can, I don't know. You know, we live in a time when electronics get smaller and faster, but I think autonomous platforms, whether they be satellites or Argo floats or whatever, you know, is the way to go. And I would put ships as being expensive and difficult.
Yeah. It actually occurs to me as you were talking, and with the UN decade, it seems to me that could be an almost ideal way to get a bit of seed money and some support and start building some sort of a pan Indian Ocean observing network that included countries that have not historically been doing so much oceanographic research. So Anoop, Hermann, Parv, the SOLAS Indian Ocean implementation team, that's something to think about, is to put in an activity for the UN decade. That might actually that might fly.
Another thought, if I may, Lisa, sorry to hog this. You know, I looked at Katya here. What about Mike Roberts and his initiative? You know, this would be a good way of going. He puts all these sensing platforms in the Southern Indian Ocean. He's particularly interested in sea level rise, amongst other things. Mike being Mike, does all things to all people at all times, I think. But you know, maybe that would be a good opportunity for South Africa to take some international lead in instrumenting the ocean in some way.
You familiar with this program, Katie?
Yeah, I'm familiar with some of Mike's work. I think, you know, a lot of the focus from the South African science perspective in this realm has been on the Agulhas Current and with the ASCA array. And I don't know that there's been a big push to go sort of beyond that, geographically beyond that. And then, of course, we also have, we meaning nationally, a large glider program heavily focused on CO2 in the Southern Ocean, run by our Council for Scientific and Industrial Research. And I think this is one of those instances where it's a lack of bodies. You know, it's not a lack of interest. It's just that our community is only so big and you have to make decisions about what you're going to focus on. And so I think the push towards autonomous is something that our scientific community in general is talking a lot about. And so I think absolutely expanding on the variety of autonomous programs we have, including the work that's done on Marion Island, which is getting, you know, more difficult to have scientists there permanently, especially with the COVID situation. So So thinking about platforms, whether it be island platforms or autonomous platforms, I think is something we absolutely need to consider. As long as we have, and this is where I think capacity building is actually quite useful, as long as we have the capacity in terms of data management, data processing, and that kind of skill set improved in country at the same time. So it isn't a situation where we deploy these autonomous vehicles and then they send their data via satellite back to the Northern Hemisphere, and no one in South Africa learns how to manage it or has the ability to deal with it. So I think that is one instance where some capacity development would definitely help, along with this increase in this kind of technological approach to the problem.
Yeah. I think autonomous platforms are good, but they're not solving all problems. I mean, there are a lot of measurements which can't be done on autonomous platforms.
Hard to do process studies with autonomous vessels sometimes. Yeah. So,
yeah,
Naja, you're back. Do we have you now back? Are you here really?
Yes.
Oh, yeah. Yeah, it's still a little shaky.
Sorry about that. Yeah.
Yeah.
Fine. Yeah. I don't know how much of what I said was lost and how much reached you.
Yeah, well,
Lisa, does it make sense to use the chat line by Vinay?
Yeah, I think so.
Vinay, you might switch off your video, that might help.
Oh, nope, he's frozen up completely again.
Yeah,
okay.
I have switched off my camera so to save. Yeah, I have switched off my video.
Okay, so he's going to try again. I've got one more question. So Anoop's asking me to wrap up within the next 5 minutes, which seems about right. Do any of the three of you have anything more? 4 of you. Any of you? Well, I'll open it up at this point. Does anyone else have anything they'd like to say? Any other thoughts? Peter.
In a nutshell, one word: plastics. I don't know if this is part of SOLAS's purview, but it ought to be. The world is becoming more and more interested in plastics. Plastics in the Southern Ocean, it's a gyral system. I think thinking about the decade, that sort of issue is going to have a lot more traction than biogenic gases, I would say.
Yeah, there's a bit of activity in SOLAS. We had a discussion session at the last Open Science Conference, but there are so few. But the main focus is on the production of volatiles from the degradation of plastics, and there just aren't very many people working on that yet. But it's definitely on the radar, and so it's not really gained traction yet. But people are thinking and talking about it. Hermann, Katie, do you have anything more you'd like to say? We can even go back to the overarching question. Any other gaps that really need to be filled? Would anyone?
I could talk forever on the Indian Ocean, and my apologies. What about the global perspective? Is SOLAS tackling modeling at a global level? I don't know enough about SOLAS to know this.
Parv, are you still on? You want to say something?
Yeah. Hi everyone. So I think SOLAS has tended to focus on regional questions. We do have a greenhouse gas theme that is probably the most overarching in terms of its global perspective, where we look at CO2, nitrous oxide, and so forth. So that's also in Lisa's talk, she alluded to the new spin-up of the IOC Carbon Initiative, where we're planning a new strategy to look at ocean carbon uptake. I would say in terms of the Indian Ocean and greenhouse gases, I think Hermann's really the person to speak to this. It's a very localized issue, especially with things like nitrous oxide and methane. And we've done a little bit of work with the paper that Hermann alluded to in his talk. I think there really needs to be a much more intensive look at a regional modeling framework to look at the monsoonal effects, which are very unique, globally, and how they interact with the regional biogeochemistry. And there's been very little done on that so far. So I think that's really a sort of low-hanging fruit, if you like, that there's a lot of work to be done on the integration of, say, a regional modeling framework with, and one thing we really need for that are time series of the biogeochemical measurements to be able to, develop these models that, realistically model the biogeochemistry in this region.
Excellent. Thank you. Thank you, Parv. So yeah, we do that. We're on it. So I think I think it's probably time to be wrapping up. This has been, thank you to all our panelists as well as our volunteer panelists. Peter, thank you. I really appreciate you being with us all day today. You're definitely senior statesman, and your insights have been extremely valuable. And yeah, thank you to our other panelists, and Vinaya Chandran. I'm sorry we were having the connection problems, but up until we lost you, the first part of this discussion was really valuable. Thank you. So Anoop told me that it's thank you. So Anoop told me that it's my responsibility to give the closing statements, and so I want to say that this has been incredibly interesting today, and I think it's worked very well. I've learned a lot, and I hope all of you have also, and also I've heard a couple new collaborations that are maybe getting going, and hopefully this will continue on, and we can, and SOLAS can help facilitate communications. If you find a need for a specific workshop, let us know. We can probably help you organize it. So I've been listening to, in addition to this discussion group, I've been listening all day to what are the big issues, where do we need to go next? And pretty much what I've heard from everyone's talks is we need more of everything, more research, more measurements, more places. But there have been a few things that have recurred and come up more often than other things. And among them are the need for sustained measurements over long term, time series stations, maybe a dedicated site on an island somewhere, but that or in increasing, so sustained measurements, long-term monitoring is really key, clearly, to answer many of the big questions we've got. The snapshots are giving us some intriguing hypotheses, but proving them requires the sustained measurement. And also the need to look in the southern Indian Ocean. A lot more, there's a real imbalance in the work that's been done, which, with good reason. The northern Indian Ocean is where most of the people live, and it's easier to get to. But the Southern Indian, there are issues in the Southern Indian Ocean that are almost complete mysteries. And then, yeah, a number of very interesting process studies that need to be done. So I'm excited. I hope that all of you are excited about this, and that this leads to actual development of some of these new things. And yeah, please, if you haven't already, please do join the SOLAS mailing list and get involved with our activities. We need you to help us answer these questions and solve the problems we've heard about today. And now I'm going to hand it back to Anoop to wrap it all up. And as I do that, I want to thank you, Anoop, for hosting this and for the energy to actually make it happen. I think it was my second steering committee meeting back in 2012, and Ed Urban said, you know, you guys really need to get going on the Indian Ocean. And it feels like we finally are gaining traction, and the ball's starting to roll with this. So thank you.
Yes, Lisa. And yeah, I certainly hope that the ball starts to roll and keeps on rolling, because that's what we want to get out of these meetings. I'm just going to do a very quick vote of thanks. Basically, first and foremost, I want to thank all of you, because doing this all day in front of a screen is not easy. We all miss that intimacy of being with each other in a room and being able to talk, but unfortunately, we have to adjust with the screen. So thank you for having the patience to bear with us and looking at our faces on the screen itself. We hope that this will be the first of many Indian Ocean meetings focused on SOLAS science. And some good research comes out of it. As Lisa said, already some people are starting to think about collaborations, which is basically the main reason why we wanted to have meetings such as these. A big thank you to all the speakers right from the morning who have contributed talks to this meeting. Some of them have been absolutely interesting, thought-provoking, and some of them have really been insightful into what has been actually going on, which has not been documented very well up until now. Big thank you to all the session chairs, especially people from in US and Canada. You guys had to wake up at stupid hours. Susan, for example, woke up at like 2 o'clock at night to join this. So thank you so much for doing that. You really helped facilitate the sessions and take the pressure off of us in order to keep things rolling. Few people that I need to thank on top of everybody who has contributed to this. First of all, Hermann has been the driving force for synergetic science in the Indian Ocean for a very long time. And honestly, this focus on the Indian Ocean has also stemmed from his own interests. So thank you, Hermann. You've been very helpful, not just in this meeting, but overall also. Suntharalingam was also extremely helpful in the organization of this meeting also. And thank you for conducting the poster session along with Dr. Anil Kumar, who was also very busy over the last few days looking at all the posters that came on. Along with that, Lisa, of course, we have to be grateful that SOLAS has got such a wonderful chair. So thank you so much for being the continuous support that you have been, and honestly being the main reason that this meeting happened, because I remember you pushing me the first time you met me, and finally after 2 years it's actually happened. So thank you for being on us. Finally, the organizing of a meeting online is honestly a nightmare, and it wasn't a nightmare for me, mainly because the SOLAS IPO took care of basically everything. I had to send just a few emails, but Jesse, Esther, and Lily, they've taken care of everything. So I'm extremely grateful to them. Jesse is probably one of the most efficient people I know, and this meeting wouldn't have happened unless it was her. And I'm pretty convinced that this meeting would have been the initial 30-40 people that we had planned it for if it was just left up to us. But because Jesse and Esther and Lily got on, they exploded the number to 360 finally. So thank you so much for everything. And with that, all I'm going to say is I really hope that this is the first step on a long journey, not just in terms of SOLAS Indian Ocean, but also SOLAS India. As I mentioned, anybody who is interested in contributing to the structure of the national community in India, please get in touch. we'll be more than happy to have a conversation after this. And with that, I'll just say thank you and goodbye to everyone. Cheers. Bye-bye.
Thank you. Goodbye. Thank you very
Goodbye.
much.
Goodbye, everyone.
Bye.
Thanks, Anoop.
Cheers.
Thanks to Anoop for a very interesting and thought-provoking meeting.
Thank you.
Thank you.
Thank you so much, Anoop, as well as Parv, supporting me to make the poster session successful. Thank you.
Thank you, sir. You're raising your hand. Is there something you want to say?
I'm clapping my hand, Anoop.
Oh, really? Okay. All right,
Congratulations. Nice meeting.
Cheers. Thanks a lot. All right. Goodbye.